Hey, this is Andrew Brown, your favorite cloud instructor, bringing you another free cloud certification course. And this time, it's the Google Cloud Digital Leader, also known as the GCP CDL. And the way we're going to pass and achieve certification is by going through lecture content, doing hands-on labs in our own Google Cloud accounts. And as always, I provide you a free practice exam so you can ace that exam, put it in your resume, your LinkedIn, go get that cloud engineer role you've been looking to get. If you want to support more free courses like this one, the best way is to purchase the additional paid study materials, such as additional practice exams, the downloadable lecture slides, the cheat sheets, to get technical support and more over on ExamPro.co. If you don't know me, I've taught a lot of courses here on freeCodeCamp, AWS, Azure, GCP, Google, Terraform, DevOps, AI, and more. And I'll see you soon in the course. And yes, I'm from another angle. If you've ever watched my videos before, I usually shoot a different way. And I have my nice shiny thing here to help with lights. But anyway, let's jump into it and I'll see you soon. Ciao. Hey, this is Andrew Brown, and we're at the start of our journey asking the most important question first, which is, what is the Google Cloud Digital Leader? It is a fundamental cloud certification that introduces you to the core concepts of cloud and Google Cloud. The certification will demonstrate a person can define and understand a bunch of foundational concepts like digital transformation, core services, storage databases, AI networking, cost management, and more. And this certification has no known course code. Google does not make course codes for the certifications, but I call this the GCP CDL, and I specifically called this version the 03 because prior to 2022, that was their first version. Then they had another one. Then they had another one. And then we're at the current one. I say after 2024, right now of the time of this video, we're near the end tail of 2024. So you can really think of this certification as the 2025 certification. There's no way they're changing this in the short term. They just changed it. So if it's 2025, you're good. But let's go take a look at the GCP roadmap. So this is the roadmap for GCP certifications. The only one that's not listed here is the Google Workspace Administrator. That's because it used to be a pro and now they're switching it to an associate. And because it's in beta, I don't know what's going on with it. So I'm just leaving it out here. But imagine that there is another certification right here under the associate. But no matter what your path is, you're going to want to start with the Google Cloud Digital Leader, with the exception of the Google Cloud Administrator, because that is such a specialized area that you might not need the foundational to do that, and we don't even have it on the list here. But the natural progression is Digital Leader to Cloud Engineer to Cloud Architect, and then often you go to the other pros. Now, these are all pros, okay, but I have this dividing line here because I kind of think of these as specialties, and that's the way other cloud providers structure their certifications. They have pros, they have specialties. And so I took the three generic, most popular ones, called them pros. The rest here, we're going to consider specialties. So a lot of people will actually do the cloud architect and the engineer at the same time because they have so much overlap. And a lot of times people skip the ACE and they go right to the pro. Though I think you should do both. I think it's the better approach, but that is the natural path. And a lot of people who Google have to get their certifications for the pro. I know that because they're on my platform. And so, I see a mad dash for that certification quite a bit. Let's talk about the range of time you need to study to pass this exam. If you're a beginner, you're looking at 20 hours. If you're experienced, you're looking at 5 hours. It just depends on what experience you're coming in with. If you already have cloud knowledge, technical cloud knowledge, it's not going to be a long time to learn. If you're a beginner, you don't know anything about cloud, you don't have technical skills, you're going to be investing a lot more time here. The medium time is about 12 hours, average study time, split between lectures and labs and practice exams. You need to put as much time into your practice exams as the study content because learning it and then doing the exams are two different things, okay? So I would recommend 1 to 2 hours a day for 14 days. Pace yourself. If you try to cram everything, you will forget it. You need to spread out your learning, but not too much. You shouldn't spread it over a month, but 2 weeks is a good learning period for you. What is it going to take to pass the exam? Watch the lecture videos, do the hands-on labs, and I have hands-on labs for this. It's not required, but you should do them anyway because it's going to give you practical basic knowledge in Google Cloud, and it's going to help you memorize or remember things a lot better. So please do those hands-on labs that I provide you in your own Google account. You're utilizing free tiers, so you'll be okay. And do look into getting paid practice exams. For this specific certification, you really do need paid practice exams because Google, even their foundational cert is harder than the other providers. So if you have let's say the AWS Cloud Practitioner or the AZ900, I'm going to tell you, Google makes theirs very hard, and they have a very particular way of writing questions. We do have a free practice exam for you on the ExamPro platform at GCP CDL. But again, just remind you, these are hard to pass without practice exams. Invest the time to do them, okay? Where do you take the exam? At an in-person test center or online from the convenience of your own home. Google uses Criterion, which is interesting because they were talking about switching away from Criterion like 2 years ago, but they never did. The thing is that all of these online proctors are kind of awful, and so you're just trading problems for different problems. So maybe Google just decided to stick with Criterion. I find it's okay, but they're not the funnest experience. If you want to have the best success, I would recommend taking the exam in a test center if there's one nearby you, because then you'll be in a controlled environment. If anything goes wrong, you can blame the test center as opposed to something going wrong in your home, and you don't want to lose that money or have issues there. These are proctor exams, so there is a supervisor person who monitors students during the examination, but I believe that it's more AI-driven these days. Criterion in particular acknowledges that part of their validation process, checking your room, is done by AI. So I wish the cost of certifications would go down, because if a real person's not there, why are these so expensive? But anyway, just consider that. In terms of the exam guide outline, I think there's like 6 domains now. There used to be 4, and they've expanded them to 6. So we have digital transformation with Google Cloud, exploring data transformation with Google Cloud, innovating with Google Cloud Artificial Intelligence, modernizing infrastructure and applications with Google Cloud, trust and security with Google Cloud, scaling with Google Cloud Operations. And each domain has its own weighting that determines how many questions in a domain that will show up. The big change is this one, the Google Cloud Artificial Intelligence. They didn't have this here before in such great emphasis. I don't know why Google doesn't make a dedicated Gen AI or AI certification, but I guess the inclusion of that domain within this exam guide is to serve that foundational purpose there. So we put a lot of effort into that one in particular, because there's a huge interest, at least right now, in adopting AI. There's definitely been more stuff that's been added into these 2 sections here. So they don't just have digital transformation, they have business transformation, and just more tools for the executive level or the sales team or the decisions makers to understand how to migrate, how to do digital transformations and things like that, which is great. The passing grade here, I believe, is 700 out of 1,000. I think it is, because the only way to know is to sit the exam and see what happens, because they don't put it on the certification page what the passing grade is. But if you search other places, they'll tell you it's 70%. My experience is that it's 70%. And understand that this is a scaled scoring, so you don't want to get exactly 70% to pass. You want to be well above that, because you can get 70% and still fail based on scaled scoring. The response types here, we'll talk about in a second, but there's 50 to 60 questions. There used to be just 60 questions. Now it's a range. I don't know why they do that. But you can afford to get 18 questions wrong if we're assuming you get 60 questions. I got 60 questions, so that's just what it is. There's no penalty for wrong questions. The format type here is multiple choice, multiple answer, so pretty straightforward. The duration here is 1.5 hours, 1.5 minutes per question, so you have 90 minutes with 120 minutes seat time. The seat time is the amount of time you should allocate for the exam. This includes time to review instructions, show online proctor your workspace, read and accept the NDA, complete the exam, provide feedback at the end. This certification is valid for 3 years before you need to get recertified. And let's just have a little bit of real talk before you take this exam. If you are obtaining cloud certifications, you are expected to already have technical skills, not necessarily at this foundational level, but when you get into the ACE and the Pro, you're expected to know programming, scripting, SQL, IT networking, Linux and Windows servers, project management, developer tools, app development skills, comp sci algorithms, and more. And to fill these gaps, you can go over to freeCodeCamp. They have a huge catalog there. I also have paid content under my subscription plan that will fill these gaps as well. GCP itself does not care about GCP certifications for hiring for their own technical roles. If they hire you, it's going to be on different metrics. And when you start working at GCP, then they'll tell you to go get your certs, giving you internal resources or things like that. And I know that because a lot of people at Google take my courses, especially the Pro. So consider that. And the amount of time you might need to invest is between 250 and 500 hours to achieve full developer knowledge or cloud engineering knowledge. But again, this is the CDL, so this stuff is not yet expected, but I just want to give you that opportunity to prep you that if you're going for the ACE, make sure you make time in between the ACE and this certification to get better at these skills, okay? But there you go, and we'll just move on from here. Hey, this is Andrew Brown from ExamPro, and what I want to show you here is an additional resource that I think is going to help you pass the Google Cloud Digital Leader. And so I'm here on thecloudgirl.dev, and this website is by Priyanka. She's a Google developer advocate, so she knows her stuff. But what I find that's really useful is she makes all these great sketches that help visualize a lot of the core services. So, you know, I'm not doing tons of visualizations in the course, and I'm just giving you just the need-to-know information. But if you check these out, it might help you cement the information a bit better. And of course, there's a lot of accompanying videos to these sketches here. So if you go to the Cloud Girls YouTube, there's a lot of great videos here. So strongly recommend that if you feel that you feel that there's a deficit, whether it's a compute engine or GKE or whatever, just to go check out these additional resources, okay? Hey, this is Andrew Brown from ExamPro, and we are at the start of our journey for the Cloud Digital Leader Google Cloud certification, asking the most important question first, which is, what is cloud computing? So cloud computing, per definition, is the practice of using a network of remote servers hosted on the internet to store, manage, and process data rather than a local server or personal computer. And the way I like to think of it is that if you're on premise, you own the servers, you hire the IT people, you pay the rent and the real estate, you take all the risks. But when you're using a cloud provider, someone else owns the servers, someone else hires the IT people, someone else pays or rents the real estate, and you're only responsible for configuring cloud services and code, and someone else takes care of the rest, okay? So to truly understand cloud computing, we have to understand how we got to cloud hosting. And the way to do that is we're going to walk through how servers changed over time and the benefits and drawbacks to these different types of servers. So the first on our list here is a dedicated server. This was a physical machine that you would go out to a store and you'd purchase and you'd put it in your office. You'd have to set up the networking, install everything, even install the operating system. And the great thing about these things is that you would get full control over your server. And so theoretically, you would have the highest level of security possible. I say it's theoretical because, of course, with cloud computing, you have all these additional services that monitor and do things for you. But this was, again, the earliest option out there. And so they're still in use. We still have dedicated servers today. But, you know, it just made it very inaccessible for most people to be able to run web apps or etc. Then we had virtual private servers. So we're still using one physical machine, but now what we've done is we've isolated, virtually isolated our application using something called virtual machines, basically into submachines, and that allows us to run multiple workloads. Because if you have different machines with, different apps with different requirements, by virtualizing the machine, we're now able to meet the needs of each application. And so that was the evolution there. Going from there, we had shared hosting. This became very popular in the early 2000s. If you've ever used GoDaddy or HostGator, you've used shared hosting. The idea is you'd have one physical machine, and instead of virtually isolating each customer or tenant from each other, you just had a folder on the machine. And you could have hundreds and hundreds of businesses on a single machine. And the way the system worked is that you had limits in place, but also there was the expectation that there just would be a lot of people that would be underutilizing the physical machine. And so there'd just be a few people that might overutilize it. And so it would work out to be very cheap. But, because it's not full virtualization, you don't have full access to the OS and things like that. So it was very limited. And there was also the chance that some other customer could end up overutilizing the machine, and that could impact your workload. All right. So then came along cloud hosting. And this is where instead of having a single machine, you had multiple machines and they would have virtualization, right? And so the idea is that now you could have a lot more customers on the exact same machine, and it's highly distributed, so you don't have to worry about one customer overusing a single machine, and you basically get the best of all worlds. So it's flexible, scalable, it's really secure, it's really cost effective, it's highly configurable, and that's basically the reason why cloud hosting or cloud computing is so popular today. So before we talk about Google Cloud, we need to ask ourselves, what is Google? So Google is an American multinational technology corporation headquartered in Mountain View, California, and its claim to fame was in 1996 when they invented the Google search engine. And so the reason why this is such a big deal was that prior to Google, and really it didn't really take off until 2000, because I remember when this thing came out, where we saw mass adoption, but it was just that other search engines at the time, like Alta Vista, Hotbot, all the ones out there just couldn't do a very good job of finding things. But Google was smart that they would actually look at the contents of web pages, they would cache them, and that's how they would determine whether to serve you content. Another very impressive thing that they did was they didn't use high-end machines. They didn't have the money, but they had the money to buy up a bunch of low-end machines, and they created new technology to distribute compute and storage across those machines. And that technology is now open source, and it's called Hadoop. And we'll talk about it later in the course, but that is something that was very impressive as well. So the name Google is actually a play on the word Google. It's just a different spelling. And that word precisely means 10 to the power of 100. And so if you represent it out in this way, the idea was that you had a 1 followed by a lot of zeros. And so I guess this is Google saying, hey, we are a data-driven company. We work with a lot of data. And that's true, they do. Google is also an initialism for Global Organization of Oriented Group Language of Earth. You can tell that they came up with the word Google, and then they just decided to try to make it into something, make it to something. So I know that doesn't make a whole lot of sense, but it's just, they're having fun, I guess, back then. Another thing we need to understand is what is a cloud service provider. So a cloud service provider, commonly abbreviated to CSP, is a company which provides multiple cloud services, and those cloud services can be chained together to create cloud architectures. So here is a technical architecture for GCP, and this is actually a web application. And this is a pretty standard one. So you might run your web app on Compute Engine, which is where your virtual machine is. You might have assets and things you need to store into cloud storage, so this is like your files and stuff. You need a database, so maybe you need a Postgres database like Cloud SQL. You might have a CDN that sits in front of your web app just to cache commonly occurring pages. Then you need a mechanism to actually deploy the application. So maybe you want to set all this up, deploy multiple apps, the same structure. So you can use Cloud Deployment Manager. And maybe you have a really fun or a very useful way of doing customer support by having a conversational AI like Dialogflow. So there are lots of applications out there. So this combination can get very variant. But this is a pretty common example, okay? So now the question is, what is the Google Cloud Platform? Well, this is what Google calls their because they are a CSP, so this is what they call their platform, and it's commonly referred to as the GCP, and also it's Google Cloud. So I don't know why, but they don't use the word, like in their logos, they don't use the word platform, but Everyone knows it as Google Cloud Platform, and we all call it GCP. And the first service they came out with was App Engine all the way back in 2008. I don't remember them calling it Google Cloud at the time. I think it was just they wanted a way for people to be able to deploy applications really easily. I'm a little bit fuzzy about that there. But now, when we look retroactively back, you can say, okay, App Engine was the first service they ever released. Then there's also Google Workspace. And you're probably familiar with this because everyone got their Gmail over 10 years ago. And so Google Workspace is just a rebranding of G Suite. And so it's a bundled offering of SaaS products for team communication, collaboration for an organization. So there you got Google Calendar, Gmail, Google Meet, Google Drive, Google Sheets, Google Docs, Google Slides. And, this course isn't really about Google Workspace or the G Suite, but, it does overlap because when we talk about identity, getting access to your Google Cloud console, things like that, it can tie into Google Workspace. And so that's why I'm mentioning it here, and you're going to see it mentioned a few times in this course, okay? So let's talk about the benefits or the advantages of cloud computing. No matter what cloud service provider you're using, you need to know these, and they're generally 6 to 7 points. And in particular for Google Cloud, they don't ask you these questions on the fundamental exam. Like they're not going to say, can you tell me 3 of the 6? But they do matter. You need to know them because contextually they help you understand how to answer other questions, okay? And so Google doesn't really have a list like Azure and AWS will actually have a page and they'll say exactly what they are. And so I just had to repurpose these from Azure here so that you can understand what they are, okay? So the first one is that cloud computing is cost effective. You pay for what you consume. There's no upfront cost. So the idea here is that you have on-demand pricing or pay-as-you-go. So when we're talking about AWS likes to call it on-demand, and Azure likes to call it pay-as-you-go. And so that's just 2 different ways of saying it. But the idea here is you have thousands of customers sharing the cost of resources. Remember when we looked at cloud hosting and we saw that there was more than one customer on the same machine? That's how we're talking about it being cost effective because you don't have to pay for the entire machine. Another benefit is that cloud computing allows you to go global within minutes, okay? So the idea is if you want to launch a workload in Canada, in the US, in the UK, wherever they have a region, you just choose that region and you can launch that. That's a huge advantage than having a server in-house, whereas the larger on-premises, they might only have 2 data centers in the US, and that's just not sufficient, okay? Then we're talking about security. The cloud provider takes care of the physical security, and a lot of their services by default are designed to be secure. So they're less likely to have issues, right? They're gonna try to enforce best practices and try to lean you towards something that is going to be better for your benefit. And you have granular access to control anything you want. So this is something you might not have if you were self-hosting, but you can say, I only want this particular user in my Google console to only be able to launch instances. They can't shut them down. Maybe they can only choose a particular size. And so that level of granular control really does make it a lot more secure, okay? Then you have reliability. So a lot of services will have the ability to backup. They might have built-in disaster recovery or make it easy to strategize for disaster recovery. You could have data replication and fault tolerance. So that is something that is just a lot more better than on-premise, okay? There's scalability. So the idea is that when you need more resources, you don't have to go out and buy a machine. You just press a button and now you have additional compute. And if you're not using it, even like 2 minutes later, if you say, I don't need this anymore, you just shut it down. And so you only have to pay for the duration that it runs. And the idea is you can scale up very quickly. So, your capacity is very fitting to that. Then there's the concept of elastic. And so scalable means you have the ability to add or remove machines or compute or storage. But elastic means that you can also automate that. So the idea is that imagine you have a web app and a week goes by and the weekend's coming up, it's Black Friday, so there's gonna be a lot of sales. And so you might not be around to provision enough machines. You might not know how many machines to provision for that event. But with the cloud, you can automate it. So it'll just say, okay, you have a lot more capacity now. We'll just do it for you. We'll spin it up to meet whatever that demand is. And when people stop using it, we'll scale down the machines for you. We'll just get rid of them for you, okay? And the last point here is that the cloud is always current. So the idea is you have all this underlying hardware and it has to be patched. It has to be upgraded. There's always new technology coming out. And that stuff is being swapped out all the time by the cloud provider. And they're experts at it, right? Whereas if you bought a physical machine, you're going to hold on to it for like 10 years, but they might be switching out machines every year. Okay, so you're going to have, the best in class hardware underlying, okay, or access to things, okay? Hey, this is Andrew Brown from ExamPro, and we're going to take a quick look at the 4 main categories of cloud services that you'll find on a cloud service provider. So a cloud provider can have hundreds of cloud services that are grouped into various types of services, and the 4 most common types, I like to call these the 4 core, and specifically for infrastructure as a service, and we'll talk about IaaS in the next video, but we have compute. So imagine having a virtual computer that can run applications, programs, and code. Then you have storage. So imagining having a virtual hard drive that can store files. You have networking. So imagine a virtual network being able to define internet connections or network isolations. And you have databases. So imagine a virtual database for storing reporting data or a database for general purpose web applications. So those are the 4 core, and we're going to give them some additional attention in this course around the Google Cloud offering, because we're going to see them in the exam, and that's usually what these fundamental certifications are testing you on, okay? And so for Google, they have 60 plus cloud services. They have fewer than the other ones, but for them, it's less about having a lot of services and just having very high quality services. So it's by design, So when you see like Azure has 200, it's a little bit too much. For GCP is like, okay, we're just going to make sure that these services are multi-purpose, so you don't have to have as many as these other ones, okay? And I just want to say that the term cloud computing can be used to refer to all categories, even though it has compute in the name. So you'll say, and I said this, I didn't say it up there, but you might say cloud computing, but you really mean everything, right? Doesn't matter what it is, everything is cloud computing, okay? So we're just looking at the categories of cloud computing. Now let's take a look at the types of cloud computing. And so we have this pyramid on the left-hand side, and the idea is that each type is reliant on the technology beneath it, okay? And so the one at the top is called software as a service, also known as SaaS. And it is a product that is run and managed by the cloud service provider. So you don't worry about how the service is maintained. It just works and remains available. The keyword here is software. So imagine just using any old software, but it's over the cloud on the internet. So Salesforce, Gmail, Office 365. You could even consider Facebook or Twitter software as a service, okay? And these are specifically for customers. The next layer is platform as a service, also known as PaaS. And this focuses on the deployment and management of your apps. So you don't worry about provisioning, configuring, or understanding the hardware OS. You can just upload your code and it will do the rest, okay? And so here we would have things like Elastic Beanstalk on AWS, Heroku, or Google App Engine. And this is the original logo, and I always love this logo, so I use it whenever I can. But the idea is that if you have a web application, you just want to deploy it and just focus on your code, that's what a PaaS is. And this is specifically for developers. And then on the bottom, we have infrastructure as a service, IaaS. There's no easy way to say this as one word, but this is the basic building blocks of cloud IT. It provides access to networking features, computers, and data storage space. So you do not worry about the IT staff, the data centers, and the hardware. And for this, we have Microsoft Azure, AWS, for Google Cloud, and this is specifically for admins. And basically, when we talk about a cloud service provider, one of the key components or characteristics of a cloud service provider is that they have an infrastructure as a service offering. If they don't have that, we don't usually call them a cloud service provider. We just call them a cloud platform. And Google Cloud originally was a cloud platform. You didn't have IaaS offerings, and so that's probably where the origin of the name comes from, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at the shared responsibility model. And this is a simple visualization that helps you determine what the customer is responsible for and what Google is responsible for related to the Google Cloud platform. And every cloud service provider has one of these models. They vary. Generally, the categories are different. They just break them down slightly different, but generally they're all the same. So we're going to spend a little bit extra time with the shared responsibility model, just because it does show up on the exam and it's a very important concept. So I just want to make sure that you know it crystal clear and from all angles, okay? So generally these things are broken down into different categories. So we have infrastructure as a service, platform as a service, software as a service, the types of cloud computing. And then we have along the side a bunch of categories or responsibilities. And this, again, these are Google specific ones. So you have content, access policies, usage, deployment, web app security, identity, operations, access and authentication, network security, guest OS data and its content, audit logging, networking, storage and encryption, hardware kernel, IPC, that's inter-protocol something something. It doesn't matter, but it's just something low level. The boot, hardware. And so the idea is that you have things that Google are responsible and things that you're responsible for. So for a software as a service, and notice how much blue there is, you have the least responsibility, which is great because then you can just focus on fewer things. But remember, SaaS is something like Microsoft Word. So imagine what you could put in Microsoft Word. You'd write your article, right? So that's the content. You might share it with somebody, and you're just using the platform. So that's SaaS. Then you have platform as a service. Remember, this is like something like App Engine, where you have your web application. You built it, Ruby on Rails, Laravel, Next.js, whatever you want. You deploy it. You upload your code, so that's the content itself, and you have to choose how you want to deploy it, and you're responsible for the security of that application because you're the one who built it, right? So there's that. Then there's infrastructure as a service. This is the basic building blocks. The idea here is you can launch a virtual machine, and so if you do that, then you are responsible for the guest OS. So you're actually adjusting OS layer stuff, and then everything underneath is Google's responsibility. So the customer is responsible for the data and the configuration of access controls that reside in GCP. The customer is responsible for the configuration of cloud services and granting access via permissions. Notice I keep using the word configuration. I highlighted in red. It's just to help you remember. If you can configure it, you're responsible for it. Google is generally responsible for the underlying infrastructure, so it's the hardware. This is a concept from AWS. I wish all of them would use it, but the idea is there's in the cloud and of the cloud. So in the cloud is talking about you, the customer. If you can configure or store it, the customer, then you are responsible for it. And of the cloud is if you cannot configure it, then Google is generally the one that is going to be responsible for it, okay? So now that we've looked at the Google's shared responsibility model, let's take something like compute and compare it across different types of cloud computing so we can understand in practice what we would be responsible for or not responsible for. So we have infrastructure as a service, platform as a service, software as a service, and notice we have another one here called function as a service. You don't usually see these in the shared responsibility model, and it is a type of cloud computing, but it's kind of a bit of a hybrid, okay? So it's kind of an edge case, and it's going to just help us understand some of the caveats and how these models are a little bit flawed, okay? So starting at the bare bottom where we have the most responsibility is with bare metal. And so bare metal just means that it's a physical machine and you're basically responsible for everything else. You just want the cloud service provider to take care of the hardware for you. So you have control over the host operating system. So literally what's going to be installed on at the lowest level. And so at this level, that means you can control the hypervisor. If you want to install some type of different kind of virtualization or have no virtualization at all, it's all up to you. And so you are the most responsible at this layer. Then you have VMs, virtual machines. And so this would be Compute Engine. I wrote Compute Engine here because I'm not really sure what the offering is for bare metal. Bare metal is expensive, so that's just why, okay? But for virtual machines here, the idea is you're responsible for the guest OS configuration level. That's the OS that is running when you have a submachine running on top of the hypervisor. You could also install a container runtime. And so when you think of and technically, this is a little bit of an odd one because for Google, you can actually checkbox on and say, I want this virtual machine to have containerization. So technically, this would be Google's responsibility. But if you wanted to, you could install your own container runtime, okay? And so here we see Google is responsible for the hypervisor and the physical machine, all right? Looking at containers, and we have a few different options here, but we'll talk about Google Kubernetes Engine, GKE. And the idea here is that you are not worrying about the OS anymore. You're configuring your containers, and you're worried about the deployment of the containers and the storage of your containers. So Google's taking care of the OS. If there's a hypervisor, and if there's and the container runtime. So they're doing a lot of the stuff there, and so you're getting less and less responsibility. Then you have platform as a service. So this would be a managed platform like App Engine. And so here you're just uploading your code. You have some configuration of the environment. You have to choose the type of deployment strategy you want. You have to configure any associated services, but Google is going to be responsible for the server, the OS, the networking, the storage, the security, a lot more stuff, okay? Then you have software as a service. There's not a lot of SaaS products on Google Cloud, but like we'll just pull one from the Google Workspace or G Suite, like Google Docs. And so here you're just worried about the contents of the documents, the management of files, the configuration of sharing access controls. And Google is just responsible for the server, the OS, network, the storage, security, deployments, other like more stuff than platform as a service. Then you have function as a service, and this one's a bit of an oddball because here. This is serverless compute, okay? Cloud Functions is serverless, but you upload your code. Sounds a lot like platform as a service, but you don't have to worry about deployments, about scaling, anything else. It takes care of everything. So deployment, container, runtime, networking, storage, security, physical machine, everything, okay? There's another service, I don't have it on here, but it's called Cloud Run, and that is a serverless container. And so that's where you have it, and it's technically containers, it's technically serverless, so it kind of like fits in the middle. So I'm just saying that there's some variation there. The exam's not going to be that hard to figure out what these are, but I just want you to know that there is some caveats or variations to this stuff, okay? It's not clear cut as you might think it is. Just to give a better visual here, we'll just go across bare metal, dedicated hosts, virtual machines, container functions. We didn't cover this, I just didn't have room, but there was sole tenant node. Because when you have a virtual machine, right, a virtual machine can either be single tenant or multi-tenant. And so what that means is that when it's multi-tenant, and that's the whole advantage of cloud, is that you have you have multiple customers using the same physical machine, but you're virtually isolated having your own virtual machines. But if you wanted to have the entire physical machine, you could have a sole tenant node. So you're the only person on that physical machine with those virtual machines. And so that's something that's in between bare metal and virtual machine, okay? So just looking at the responsibility of the customer, level of control, look at code here. So code, you're responsible across the board. For app containers, it's up to the containers. At functions, you're not responsible for it. For the runtime, you have control over that in containers, right? If you want to run Ruby, you can just make a Ruby Docker file and upload it. Now you can run Ruby code. If they didn't support it. For the operating system, you have control at the guest OS here for virtual machines. For the dedicated hosts, it's still guest OS. And then at the bare metal, it's hardware OS. For virtualization, if you want to change out the type of hypervisor or virtualization method, only bare metal is going to let you do that. So hopefully that gives you a very clear picture of the shared responsibility model in action. And for different types of categories, it's going to be completely different, okay? So let's take a look at an alternate way of viewing the shared responsibility model. And this is the way AWS and Azure does it. And the reason I want to show it to you is because it's a lot more encompassing of everything that the cloud can offer you, whereas the Google shared responsibility model is really focused on the application. So you can really tell they're developers, right? But it's important for you to understand the full scope. So we have the customer and we have GCP. So GCP is responsible for the hardware and the global infrastructure. So the regions, right? Like everything that has to do with regions, the zones, and zones is a collection of data centers within a region, and the fault domains. Fault domains is a logical isolation of hardware that's within a data center, and then there's the physical security of the data center. They're responsible for that as well, right? Then you have software. So this breaks down to the core four. So you got your compute, your storage, your database, and your networking. Now onto the customer side, there's the configuration of managed services or third-party software. So that could be platforms, applications, IAM. IAM is a big one. That's a huge component for customer responsibility. Configuration of virtual infrastructure and systems, so operating systems, the network, firewall. So I notice you see networking down below. So we're talking about the actual like routers and switches and things like this. And up here, this is like cloud networking, okay? This is like, I want to create a VPC and I want to have these subnets in it and I want to use these cloud networking services, but you're not really dealing with lower level software like setting up the switch or the router or things like that, okay? Then you have security configuration of data. So, whether to use client-side data encryption, whether you're using server-side encryption, whether you turned it on, what type of encryption you want to use, protecting the network traffic. So whether you're monitoring it, and put any other kinds of controls to say, okay, who is allowed to see what, and your customer data. That's a big one, okay? So yeah, this is basically the AWS and Azure way of looking at, or sorry, I said Azure, but it's more like AWS and Oracle. Azure actually has their own way. It actually looks a lot more like this. And so theirs, they do on-premise. They put on-premise in the mix, infrastructure as a service, platform as a service, and software as a service. And so they just break it down to here. And these are going to look very, very, very similar to the Google's one. So you have applications, data, runtime, middleware, OS, virtualization, server, storage, networking. How many is there? 1, 2, 3, 4, 5, 6, 7, 8, 9. These almost match up to the OSI layer. That's like the layers, like the application layer, the networking layer, things like that. And so that's basically how Azure kind of does it. But it just helps you to see the names in a different way. So you can see there's still data. There's no mention of like access controls, but it's just assumed that if you have an application responsible for it, things like that. Okay, so hopefully that gives you a really clear understanding of the shared responsibility model. Hey, this is Andrew Brown from ExamPro, and we are looking at the cloud computing deployment models. This one's an important one. It will show up in your exam, so you'll want to know the difference. Starting at the top here, we have public cloud, and this is where everything is built on the cloud service provider. This is also known as being cloud native. So the idea here, and I know this is an AWS example, and we're doing GCP, just didn't have time to make the new graphic here. But the idea is that you have a virtual machine and a database. It's sitting within subnets, within a VPC. Both AWS and Google call their VPCs the same thing, so that makes it easy here. And everything's contained within the cloud service provider. There's no cloud services outside the cloud service provider, okay? Then you have private cloud. This is where everything is built on the company's data center. This is also known as on-premise because it's on the premises where your office is. And so here you would use something like OpenStack to have private cloud. So OpenStack, I believe it's by Rackspace. And the idea here is that it gives you a lot of the benefits where, like, imagine you want to distribute a virtual machine across many machines. You want to have granular permissions like IAM and things like that. That's what private cloud's going to do for you. Then you got hybrid, and hybrid cloud is where you are using both private and public cloud and you're connecting them, right? You're offloading some of your private cloud compute storage stuff to the public cloud, and that's happening via some kind of hybrid connection, okay? And then we have cross-cloud, also known as multi-cloud. A lot of people will call it hybrid cloud. It's not hybrid cloud. Hybrid cloud is when you have a private cloud and a public cloud connected. A cross-cloud is when you are using multiple multiple CSPs, and the workload is spread across them. A really good example here is something like Azure Arc, or for Google's offering, they call theirs Anthos. So the idea is that you have a control plane that will control compute across multiple cloud service providers and on-premise environments. Multiple cloud providers, or multi-cloud, is just when you use multiple providers, but you don't necessarily use data across them, okay? But Google's going to just treat multi-cloud and cross-cloud as the same terminology, all right? To try to just kind of give this more of like a business use case, or who's using these things, we talk about for cloud, or public cloud, we're fully utilizing cloud computing. This is where we're using cloud and on-premise, and this is where we're deploying on-premise using virtualization. It's sometimes known as private cloud, okay? So who's using cloud, like public cloud? We're looking at startups, SaaS offerings, new projects and companies. So think of Basecamp, Dropbox, Squarespace. For hybrid, we have banks, fintech investment management, large professional service providers, legacy on-premise. There's reasons why they're hybrid. They have to keep certain data on-premise for regulatory reasons, or it could be because of just because they have so much infrastructure, it's just too hard to move everything away, or they have customers that are concerned about the cloud or the public cloud. When we're talking about the public sector, like government or hospitals with super sensitive data, or very, very large enterprises with crazy regulation, like insurance companies, they might want to have 100% private cloud. They're starting to adopt a hybrid model. So we're seeing less and less of this, but like hospitals, AIG, which is an insurance company, or the government of Canada, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at the total cost of ownership, also known as TCO, to really understand what it is that we are paying for when we're using on-premise, and what we're paying for or not have to pay for when we're using GCP. These break down to CAPEX and OPEX. Notice here at the top, we're going to talk about that in the next slide here. Now, Google Cloud doesn't actually ever mention TCO, even though it's pretty common across all the other cloud service providers, but it does tie back to CAPEX and OPEX, so we're going to cover it anyway, and it's good to know this, okay? So to understand the TCO concept, I have these icebergs to really make sure, or to sell you that these are icebergs. I put some penguins and a whale on it for you. But the idea is that we have things that are above the surface, and these are things that we generally think about, and then the things below the surface, under the water, are the things that we're not thinking about that really helps us factor in the total cost of ownership. So when we're looking at things that are obvious, people think about, well, for on-premise, we just have to pay for our software license fees, right? If you have Microsoft servers, you pay for those licenses. And then on GCP, well, you just pay subscription fees. So maybe you're not paying for the licenses, but now you're just paying for using the services on demand, right? And so they might look at it and say, well, the costs they look pretty comparable. But then when you get below the surface, we talk about, because remember, on-premise, you have control of, you have those physical machines there, right? So there's the implementation, the configuration, the training, the physical security, the hardware, the IT personnel, the maintenance. There's a lot of cost in actually having those physical machines and all the stuff around them, whereas in the cloud service provider, you are worried about the implementation, the configuration, training, like how to use cloud services, but you're not worried about all that other physical stuff. And the idea here is that you can save up to 75% shifting over to a cloud service provider. GCP doesn't have an example of a cost-saving example, but AWS does, and they showed like 75%. It's going to be the same for all the CSPs. And the idea now is all this stuff in the red here is now the cloud service provider's responsibility. You don't have to worry about it. So let's talk about capital versus operational expenditures. So capital expenditures, known as CAPEX, and operational expenditures, known as OPEX, right? And so on the CAPEX side, this is where you're spending money up front on physical infrastructure and deducting that expense from your tax bill over time. So that's where a lot of people go, well, I can get this machine and then write it off year after year. And I guess that sounds okay, but you're going to save way more money, way more money than getting that small tax benefit. But let's talk about what are CAPEX expenses. So you have server costs of the computers, the storage costs, so like hard drives, network costs, routers, cables, switches, backup and archive costs, disaster recovery costs, data center costs, so rent, cooling, physical security, the technical personnel. So with capital expenses, you have to guess up front what you're going to plan on spending, right? Because once you have those, you're going to hold on to them for a period of time, right? For operational expenditures, the cost associated with the on-premise data center has now shifted to the service provider. So you only have to worry about non-physical costs. So this is leasing software and customizing features, training employees and customer services, paying for cloud support. Your billing is based on cloud metrics, so compute usage, storage usage. And with operational expenses, you can try a product or service without having to invest in the equipment. So you can spend a lot more time in things that matter to grow your business, and you don't have to immediately commit to a bunch of stuff. You have a lot of flexibility there, okay? So that's the huge difference. Hey, this is Andrew Brown from ExamPro, and we are looking at cloud architecture terminology. So these are very important concepts when utilizing the cloud, though Google will not ask you directly on their certification to describe these concepts or to pick them out of a lineup of terms, okay? However, they are still going to play into questions, so we generally need to know what these things are. So let's go through the quick list here, and then we'll do a bit of a deeper dive on each of these ones, okay? So first we have availability, your ability to ensure a service remains available. This is known as highly available, HA. You have scalability, your ability to rapidly grow unimpeded. You have elasticity, your ability to shrink and grow to meet the demand. And this has to do with the automation of it. You have fault tolerance, your ability to prevent a failure. You have disaster recovery, your ability to recover from a failure, also known as being highly durable, so DR. So looking first in more detail here, high availability. This is your ability for your service to remain available by ensuring there is no single point of failure or to ensure a certain level of performance. So I got a bunch of text here, but I have a graphic that makes this really clear. The idea here is that we have a load balancer, and for Google's, it's called Google Cloud Load Balancing. And the idea is that we have compute and we distribute it. So it's separate virtual machines, but they are in three different zones. And the idea is that if you were to lose one or two zones, you would still have a running service because the load balancer would detect that these ones are unhealthy and reroute the traffic to the remaining server, okay? And that helps us be highly available. Then you have the idea of being highly scalable. So your ability to increase your capacity based on the increasing demand of traffic, memory, and computing power, okay? So you have vertical scaling. This is where you are scaling up. You are increasing the size of the single machine, right? So maybe you are increasing the amount of storage, the amount of compute, things like that, resizing the machine. Then you have horizontal scaling. So you're just adding additional servers of the same size, and then you're distributing the workload across those machines, okay? You have high elasticity, so your ability to automatically increase or decrease your capacity based on the current demands of traffic, memory, and computing power sounds very similar to the last slide, but the key difference is that it's automated and you also have the ability to decrease, okay? So the idea here is that you have the concept of horizontal scaling where you can scale out, but you can also scale in. So scaling out is when you add more servers, and scaling in is when you remove servers, okay? And generally speaking, when we're doing things that are elastic, it's usually of the same size. There is an exception where you can have containers. I think it's like Mesos or whatever. They allow you to have a mix and match of different kind of containers, but generally it's the same size containers, okay? Or virtual machines, I should say. So vertical scaling is generally hard for traditional architecture, so you're not going to see the concept of elasticity with vertical scaling. It's with horizontal scaling, okay? The way we can do horizontal scaling or elastic automatic scaling is with managed instance groups with Google. So this is automatically increasing or decreasing the response to a demand or a defined schedule. Next, we have fault tolerance. So your ability to for your service to ensure there is no single point of failure or preventing the chance of failure. So I'm just going to lay out all this stuff here. And so it sounds very similar to high availability, but the idea is that it's all about preventing chance of failure. So the idea is that imagine, or I guess it's kind of the response of failure. So the idea here is that let's imagine you have a database and the primary database for whatever reason fails. okay? And so the idea is that your cloud DNS, which is at the your domain level, what it can do is say, okay, fail over to the secondary instance. So you have a redundant application running, you're syncing that data over. It's a standby service. The idea is that it's ready to take over when the first one fails, okay? So whether something happens, we can fault over to it. I know it gets confusing with high availability. We have high durability, your ability to recover from a disaster and to prevent the loss of data. So solutions that recover from a disaster is known as disaster recovery. How do you back up your data? How fast can you restore that backup? Does your backup still work? How do you ensure your current live data is not corrupt? So there you go. That is our terminologies, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at the evolution of computing. Your cloud service provider has all of these offerings, and the idea is that you need to choose the one that meets your use case. A lot of times, this all has to come around the utilization of space. That's what we're trying to illustrate here in this section here, and the trade-offs of why you might want to use some of these offerings, okay? For dedicated, we're talking about a physical server wholly utilized by a single customer. That's considered single tenant. And for Google Cloud, we're talking about single node clusters and bare metal machines where you have control of the virtualization, so you can install any kind of hypervisor or virtualization you want in the system. The trade-off here, though, is that you have to guess upfront what your capacity is going to be, and you're never going to 100% utilize that machine because it's going to have to be a bit under in case the utilization goes up. That's you choosing the CPUs and the memories. You're going to end up overpaying because you'll have underutilized server. It's not going to be easy to vertically scale. It's not like you can just say resize it because the machine you have is what you have, right? You can't add more. I mean, I suppose they can insert more memory for you, but that's a manual migration, so it's very difficult. And replacing the server is also very difficult, okay? So you're limited by the host operating system. It's not virtualized, so whatever is on there is on there. And that's what your apps are going to have access to. If you decide to run more than one app, which is not a good practice for these kind of machines, you're going to end up with resource sharing where one machine might utilize more than the others. Technically, with a dedicated machine, you have a guarantee of security, privacy, and full utility of the underlying resources. I put an asterisk there because, yes, it's more secure, but it's up to you to make sure that it's more secure. So that's up to your skills of security, right? Whereas if you had a virtual machine or anything above that, there's more responsibility on the cloud service provider to just provide a secure machine, and they can do a better job than you. So why would you use a dedicated machine? Well, maybe you're doing high performance computing where you need these machines like very close together and you have to choose what kind of virtualization you need to have, okay? So then we're looking at virtual machines. The idea here is you can run a machine within a machine. The way that works is we have a hypervisor. This is a software layer that lets you run the virtual machines. The idea here is now it's multi-tenant. You can share the cost with multiple customers. You're paying for a fraction of the server. You'll still end up overpaying for the underutilized virtual machine because a virtual machine is just like, you have to still say how many vCPUs, how much memory, and your app is, you don't want an app that uses 100%, right? You want to use exactly the amount you need, but you can see here, there's still going to be some underutilization. You are limited by the guest operating system, but now it's virtualized, so at least it's very easy to possibly migrate away. If you choose to run more than one app on a virtual machine, it can still run into resource sharing conflicts. It's easier to export or import images for migration. It's easier to vertically or horizontally scale, okay? And virtual machines are the most common and popular offering for compute because people are just very comfortable with those. Then you have containers, and the idea is you have a virtual machine running these things called containers. The way they do that is similar to a hypervisor, but instead you have, like here is a Docker daemon, so it's just a container software layer, okay, to run those containers. There's different kinds. Docker is the most popular. And the great thing is you can maximize the capacity because you can easily add new containers, resize those containers to use up the rest of the space. It's a lot more flexible, okay? Your containers will share the same underlying OS, but they are more efficient than multiple VMs. Multiple apps can run side by side without being limited by the same OS requirements and not cause conflicts during resource sharing. So containers are really good, but the trade-off is there are a lot more work to maintain. Then you have functions. And functions go an even step further. And the idea is that you the containers where we talked about, that's a lot of work to maintain. Now the cloud service provider is taking care of those containers generally. Sometimes not. It depends if it's serverless or not. But the idea is that you don't even think about, and this is called serverless compute, but you don't even think about the OS or anything. You just know that what your runtime is. You run Ruby or Python or Node, and you just upload your code, and you just say, I want this to be able to run for this long and use this amount of memory, okay? You're only responsible for your code and data, nothing else. It's very cost effective. You only pay for the time the code is running. And VMs only run when there is code to be executed. But because of that, there is this concept of cold starts. And this is where the virtual machine has to spin up. And so sometimes requests can be a bit slow. So there's a bit of trade-off there, but functions or serverless compute is generally one of the best offerings as of today. But most people are still getting kind of comfortable with that paradigm, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at global infrastructure. So what is global infrastructure? Well, it refers to the global presence of data centers, networking, and cloud resources available to the customer. And so just kind of some of the stats that Google Cloud has. They have 25 regions, 76 zones, 144 network edge locations, operating in 200 plus countries. So just an idea, like here is an example of the exterior of a Google data center, and this is an interior. So we're going to go and dive deep on all these cloud infrastructure concepts starting now. Hey, this is Andrew Brown from ExamPro, and we are looking at regions for global infrastructure. So regions are independent geographic areas that consist of zones. And GCP has 25 regions. So here we have a map, and you're going to notice that some are blue and some are white. White ones indicate that they are planning to have regions there in the future in the next 3 years. And I think most of not all of their regions always have 3 zones in them. So that's pretty good on them. So for the Americas, we got Oregon, Los Angeles, Salt Lake City, Las Vegas, Iowa, South Carolina, North Virginia, Montreal, Sao Paulo. For Europe, we have London, Belgium, Netherlands, Zurich, Frankfurt, Finland, Warsaw. In Asia Pacific, we have Mumbai, Singapore, Jakarta, Hong Kong, Taiwan, Tokyo, Osaka, Sydney, and Seoul. Okay, so there's quite a few of them. I mean, like a lot of people are used to running in US West or US East. I am always running in the Canada region because that's where I'm from, so it's there. But yeah, when you actually want to go use a region, it's as simple as choosing it. So if I'm launching a virtual machine with compute instance or compute engine, you're just going to choose the region you want to go in, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at Google Cloud's global infrastructure edge network. And so edge networking is the practice of having compute and data storage resources as closest as possible to the end user in order to deliver the lowest latency and to save bandwidth. And so when we're talking about edge networking, we're always talking about points of presence, POP or POPs. And this is an intermediate location between a GCP region and the end user. And this location could be even in a third-party data center, or it might just be described as a collection of hardware. So maybe it's not even a data center at all. And so here is the big old graphic that Google has for us. And if you see all those wires, that's basically just showing how things are interconnected, the actual global network between these POPs. And actually, there's 3 types of POPs or things we want to look at for edge networking devices or things. And this graphic will change for all 3. This one is, I think, for edge POPs. So just understand that it's not representative of all these 3 types. But the first is edge POPs. So a location where a user can quickly enter, so ingress the GCP network for accelerated access to cloud resources. Then you have a CDN, and this is a location to serve, so egress, leave, to leave the network, for cache websites, files, assets, so they load very fast for the end user. Then you have Cloud Media Edge. This is a location specialized for the delivery of media such as video content. And so there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at zones for Google Cloud's global infrastructure. So a zone is a physical location made up of one or more data center, and a data center is a secured building that contains hundreds of thousands of computers. And so this is an example of the interior of a data center, and of course you probably wouldn't want to have a dog in there unless it's a guard dog protecting those machines, okay? So a region will generally contain 3 zones. And I actually think Google's very good about that. They always have 3 zones, but other providers will try to get a foothold into new regions, and so they might only launch with a single zone offering, but I think GCP is good in this regard. The reason we make mention of that is because when we're talking about high availability, the only way to get that is when you have at least 3 zones. That's the standard, okay? Data centers within a region will be isolated from each other, so different buildings, but they will be close enough to provide low latency. And we'll talk about the interzonal latency coming in this section here. So common practice to run at least 3 zones to remain available in case 1 or 2 data centers fail, okay? So the way you choose zones within Google Cloud is after you've chosen your region, you just choose your zone. And sometimes you're choosing more than one zone, okay? So it's that simple. Hey, this is Andrew Brown from ExamPro, and we are looking at resource scoping for Google Cloud's global infrastructure. So we were just talking about zones, and I was saying that you can, when you launch a resource, sometimes you choose a single zone or multiple zones, and that comes into resource scoping, okay? So I just want to talk a little bit more or reiterate on zones one more time. So a zone is a deployment area for Google Cloud resources within a region. Zones should be considered a single failure domain within a region, and deploy redundant resources in multiple zones, multi-zones, for fault tolerance and high availability, okay? So let's now talk about product or resource scoping. So the idea is you can launch a resource in a single zone, in a single region. So this is a zonal resource. You have regional resources. This is where a resource resides in multiple zones in a single region. You have multi-regional resource, so resources reside across multiple specific zones. You have a global service. This is where resources reside globally and regions and zones are abstracted away. Very common with serverless services, okay? And then you have internal services. These are foundational services used by many other services. You don't interact with these services directly. They're managed by Google, such as Spanner, Colossus, Borg, and Chubby, okay? So the reason I bring this up is that, I saw a question or two on the exam and they were using this terminology. And so, it just helps you to kind of frame that question better if you know resource scoping, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at data residency for Google Cloud's global infrastructure. So what is data residency? Well, it's the physical or geographic location of where an organization or cloud resources reside. And the reason we care about this is so that we can do or have compliance boundaries. These are regulatory compliance, so they're legal requirements by a government or organization that describes where data and cloud resources are allowed to reside. So, if you're working with the Canadian government, they say, we're only going to use your software as long as the data resides within Canadian data centers. That is the idea behind this stuff. So when you're trying to run these kind of workloads and you need to meet compliance boundaries, strictly defining the data residency of the data and cloud resources, in GCP, you can use something called assured workloads. So this is a feature that allows you to apply various security controls to an environment. So it's not just for data residency, but that's its primary feature. So data residency, personal data access controls based on attributes, personnel support case ownership controls based on attributes, encryption. So in order to apply data residency, you're going to use an organizational policy called a resource location restriction and choose the allowed region or multiple regions. Will this show up in the exam? Probably not, but it's good to get you kind of exposed to global or organizational policies because those kind of do show up on the exam, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at Cloud Interconnect for global infrastructure. Technically, this is hybrid services, and so you have this in the hybrid section, but I like to put it in global infrastructure because it's just something that has to do with data centers and connecting things, so that's why I always kind of front-load it in this section here. So Cloud Interconnect provides direct physical connections between your on-premise network and Google's network. And so Cloud Interconnect enables you to transfer large amounts of data between networks, which can be more cost effective than purchasing additional bandwidth over public internet. So it's a direct physical connection. So fiber optics running from data center to data center, okay? And there are two offerings. We have dedicated and partners. So for dedicated, this is a direct physical connection between the on-premise network and Google's network through a co-location facility. We'll talk about co-location, what that means here in a moment. Then you have a partner interconnect. This is a direct physical connection between the on-premise network and Google's network through a trusted third-party data center or provider, okay? So on the dedicated side, this is between 10 to 200 gigabytes per second. And for partner, it's between 50 megabytes per second and 10 gigabytes per second. The reason you would be using a partner one is maybe because you just can't do dedicated based on your location. So you have to work through a partner, or maybe it's more cost effective, or or it meets your needs. So it's just going to be dependent on that kind of stuff. But generally the reason people are going with partners because they just can't get the dedicated one. So what is a co-location facility? So a co-location or carrier hotel is a data center where equipment, space, and bandwidth are available for rental to retail customers. So the idea is that it's a rental data center, right? And Google there's ones that they're cool with using. And so those is like you have a bit more direct control over it. So, it just depends on what you want to do. Okay. Hey, this is Andrew Brown from ExamPro, and we are looking at Google Cloud for Government. And so the first thing I want to answer is, what is public sector? So public sectors include public goods and governmental services such as military, law enforcement, infrastructure, public transit, public education, healthcare, and the government itself. So Google Cloud can be utilized by the public sector organizations developing cloud workloads for the public sector. And the way Google achieves this is by meeting regulatory compliance programs along with specific governance and security controls. So some compliance programs that would be used in public sector would be HIPAA for health, FedRAMP for dealing with the US, the Criminal Justice Information Service. It's like working with the FBI. And we got FIPS 140-2. And we do cover all these again in the course, so don't worry about having to memorize this second. Let's just mention FedRAMP. So this stands for Federal Risk and Authorization Management Program. So FedRAMP, it's a U.S. government-wide program that provides a standardized approach to security assessments, authorization, and continuous monitoring for cloud products and services. So what is GovCloud? Because this is something you hear a lot with cloud service providers. So a CSP generally will offer an isolated region to run FedRAMP workloads. And GovCloud offering in practice can result in degraded service offerings, lower service availability, and higher operational costs. So GCP has an alternate to offering GovCloud, where FedRAMP workloads are authorized in GCP's usual region data centers, and this scheme mitigates the disadvantages of GovCloud offering. So GCP regions will be authorized for either a high or moderate baseline. And so, that was the thing, was I was looking up GCP and I'm like, where's their GovCloud? I couldn't find it. And so they just have a different way of going about it. And supposedly they say that it is better. I don't know all the details about it, but that was what I could drum up. Will this show up in the exam? Probably not. I didn't really see anything for public sector on the exam, but from fundamental information, you should absolutely know this, okay? I just want to cover some basic networking infrastructure terms, just so that if you aren't familiar with, you can get caught up to speed very quickly. These things are very common, so we'll cover them in a rapid pace here. But the first we want to talk about is IP addresses and DNSs. So an IP address is a unique numerical label identifying a device on a network. Then you have a domain name. This is a user-friendly name mapped to an IP address. So an example here would be google.com maps to an IP address. Then you have DNS, a domain name system. So this is like the phone book of the web. It translates domain names to IP addresses. Then we have internet service providers known as ISPs. These are companies providing internet access to businesses and individuals. So an example here could be something like Verizon or SoftBank in Canada. It's like Bell Media, Rogers, things like that. You have global network infrastructure. And so under this, you'd have something called fiber optics. This transmits data as light pulses over long distances. We have subsea cables. These carry 99% of international traffic. And so there's like a map of all these cables running along the sea floor. That's how we're all interconnected. It's not through space. A lot of people think it's all satellites or in space, but actually we run physical cables across to other continents. You have Google's global reach. So here we have the data centers and edge locations. So we have those. We have network edge. So this is where we have Google's fiber optic network that connects data centers worldwide. We have network performance. So we have something like latency. This is the speed of data transfer and that's critical for user experience. And we have bandwidth. This is the capacity of data transfer across the network. So, in future videos or in courses like the ACE, we'll put more effort into explaining these things. But for this certification, you just have to have a general understanding of these basic network infrastructure terminologies, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at latencies for Google Cloud's global infrastructure. So what is latency? Well, latency is the time delay between two physical systems. And what is lag? Well, lag is the noticeable delay between the actions of input and the reactions of the server sent back to the client, all right? And you probably, if you play video games, you know what game lag is. So it's basically the same thing, okay? It's just between servers instead of game servers, all right? We have inter-regional latency. So this is latency between two regions. And then we have interzonal latency. This is latency between zones residing in a single region. And I just want to generally give you an idea of the latency in milliseconds. This isn't going to be exact because I honestly couldn't find something definitive by Google. And there are benchmarks out there and they vary because it's going to be between regions and different zones. But I want to try to kind of give you kind of a bit of a de facto way of understanding generally what they'll be. And so I would imagine that between two regions, you could see the worst case of 500 milliseconds. So that's in the triple digit. And then when we're talking about interzonal latency, maybe 10, 50 milliseconds. So double digit milliseconds, okay? The reason this is important is because I saw a question on the exam and it actually asked about 10 milliseconds and it was talking about high availability. And if you knew that that it's in the double digit between interzonal stuff, you wouldn't have chose multi-region. You would only choose a single region with multiple zones, okay? So don't get hung up on so much the exact number, but just understand triple digit, double digit for these two, okay? Let's talk about the benefits of the Google data center. Now, we do talk about defense and depth in defense or defense in depth with Google in particular because they do a really good job here. But this is kind of a reiteration in a different way that we are talking about Google's data centers. So the first is enhanced security. So we have a zero trust architecture with custom hardware with strong physical security, including biometric access. We have operational efficiency. So purpose-built servers that reduce energy and use and improve efficiency, like the Hamina data center with seawater cooling. That was hard for me to say. We have scalability, quickly add hardware to meet growing demands without disrupting services, customization, complete control over servers, allowing unique features, innovations, cost and environmental savings, lower cost environmental impact through efficient design and renewable energy. In fact, as of yesterday from this video, Google signed an agreement to start using nuclear power. So they're really thinking about how to push the usage of their data centers. But yeah, there you go. Hey, this is Andrew Brown from ExamPro, and we are taking a look at innovation waves, actually known as Kondrativ waves. That's a Russian name, so I'm sorry if I pronounced it incorrectly, but they are hypothesized cycle-like phenomenons in the global world economy. The phenomenon is closely connected with technology life cycles. So the idea here is that we have these waves that irreversibly change the society on a global scale, and generally we underpin these for particular technological advancements, okay? So here we have the steam engine and cotton. We have railway and steel. We have electrical engineering and chemistry innovations. Here we have petrochemicals and automobiles. We have information technology. And the idea here is that Google is suggesting that the wave that we're in right now includes cloud technology as one of the larger factors. When we look at one of these waves in greater detail, there is a common pattern to the wave that changes the supply and demand. And so they say there's an expansion boom, a recession, and a depression. And if you can detect that pattern, that's how you know that something is going on, okay? And so if we are in, if cloud technology is the case here, then we're definitely in an expansion phase right now. And we might be in a boom. It's hard to say. But yeah, so there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at the concept of a burning platform. So the term is used when a company abandons old technology for new technology with the uncertainty of success and can be motivated by fear that the organization's future survival hinges on its digital transformation. So this idea comes back to the oil industry, where you would have a platform and oil would catch fire. And so the only way to survive would be to abandon or jump off the platform. And so this term is not so popular today, but Google seems to still be using it. But the idea is that, it's just you have to take a leap of faith into this stuff if you want to keep up, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at the evolution of computing power. So computing power is the throughput measured at which a computer can complete a computational task. And Google has a variety of offerings for the innovations in this particular field. The one that we're all most common with are CPUs. So this is just like what's in your computer, your laptop. When we're talking about cloud computing, the one that we commonly see are Xeon CPU processors, because they're very, very good processors. And so the offering here at any cloud service provider would be via virtual machines. And so for Google, their virtual machines are offered via Compute Engine. Then we're looking at tensor computing. So Google created their own machine learning, deep learning framework called TensorFlow, and it has a new type of data structure called a tensor that is specifically optimized for neural networks. And the idea here is that Google decided to create a piece of hardware that is specifically designed for their tensor data structure. And so that's what they have, which is this TPU thing. And for this particular use case, it is 50 times faster than a traditional CPU, all right? And this is really for the space of neural nets. If you want to have this offering on Google Cloud, you'd be using the Cloud TPU, okay? And the last one here is quantum computing. And so quantum computing is interesting because it has the potential to be 100 million times faster. It is, we're literally using parallel a universe or dimension using things like quantum entanglement, very advanced concepts in order to perform insane amount of computation. But this field is very early days, and so being able to apply it is not very easy, but that doesn't mean that you can't play around with it. Google has an offering. I know AWS has an offering for this, but in particular, Google has been producing different hardware. So they first had Foxtail in 2016, then Bristol Cone in 2017, and I think the latest one they have is Sycamore in 2018. All right, and so this is all accessible via the Google Quantum AI. All right. Hey, this is Andrew Brown from ExamPro, and we are looking at the concept of digital transformation, and this is the adoption of digital technology to transform services or businesses through replacing non-digital or manual processes with digital processes, like going paperless, or replacing older digital technology with newer digital technology. So that means you previously were using on-premise, and you're moving into a hybrid architecture or using cloud-native technology, all right? And so this you could describe is that Google has their own Google Digital Transformation Framework or concept based off of Google's 7 solution pillars. So we have infrastructure modernization, business application platform portfolio, application modernization, database and storage solutions, smart analytics, artificial intelligence, and security. So in terms of the actual exam, they're not going to ask you what are the 7 pillars or what digital transformation is, but the exam is all business use case scenarios. So there are some tidbits in here which might help you with some of the questions, and that's why we're going to go through all the pillars, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look here at Google Cloud's solution pillars, and there's 7 in total here, and there's a lot of text, so let's work our way through it. So the first is infrastructure modernization. So replacing legacy hardware and software systems with cloud solutions allows organizations to adopt hybrid architectures and have more infrastructure mobility, choosing a mix of best cloud service provider offerings for their organization's use case. So in this case, if we're talking about hybrid architectures, one service that we could utilize would be Anthos. And this allows you to manage compute from both on-premise and public cloud in a single unified interface. Moving on to business applications platform portfolio. So the backbone of CSPs are built on top of robust, well-documented APIs standardized across all offered cloud services. Organizations can focus on the configuration and interconnections of various systems instead of having to build their own systems. So what are they talking about here? We're talking about Cloud SDK, Cloud API, Cloud CLI, and the Google Cloud documentation. For number 3, we have application modernization. So building web applications on top of cloud services allows organizations to globally deliver and rapidly iterate faster than ever before. CSPs offer automated deployment pipelines, AI-powered code reviews, easy staging and testing of new features, the ability to test in production, roll back changes. Apps are more durable and can remain available when facing catastrophic regional failure. So one thing that makes it really easy to build out very robust web apps is if you're able to migrate your web app over to App Engine, because it just takes care of a lot of the stuff for you. And all you got to do is upload your code and do some configuration, make some choices, but more or less it makes it very highly durable, available, and scalable. Then you have database and storage solutions. So most companies can tolerate losing application code. You can always write. You can always rewrite. Losing data is not something you can recover. Cloud service providers have guaranteed SLAs of data durability, as well as the ability to easily migrate and secure your data. So in this case, if we're looking at cloud storage, which is on the storage or file side of the scenario here, it can store files and documents as objects, and its availability is 99.5%, and it's SLA backed, okay? And the way they do that is that they're replicating your data across multiple zones. So if a zone fails, it'll just cover files from another zone, and it does that automatically for you. For number 5, we have smart analytics. So when you store data on cloud service providers, you can tap into big data and business intelligence cloud offerings assisted by AI to help you analyze your data. So for Google, there's Looker, and this is data exploration discovery business intelligence platform acquired by Google, and it is now part of GCP. Then you have artificial intelligence. So AI, deep learning, ML are specialized domains that traditionally required scarce and expensive subject matter experts. Cloud is commoditizing, simplifying AI knowledge while driving costs lower for adoption. So there's a lot of tools here that Google has, but the primary ones is Vertex AI. This is a unified platform for AI, ML, deep learning, auto ML. They have their own deep learning framework they've developed. It's really easy to use. This is my most favorite framework, and this is the one I always use. Then we have security. So cloud services by default have strong mechanisms built in for security, governance, and compliance. CSPs are continually developing new and innovative security offerings, not just at a service per service level, but to analyze, recommend, and remediate at the project and organization level. You can easily and quickly audit and apply security controls to become compliant in a fraction of the time than on an on-premise solution. And so things you get when you're working in the cloud, IAM. I mean, if you're using private cloud, I suppose you'd get that with OpenStack, but IAM, so role-based access controls and user management. One that I really like that Google has is BeyondCorp. It's a zero trust model framework. Then there's the Security Command Center. So it's a centralized, it centralizes visibility and control for security and stuff, for misconfigurations. But there's a lot more there, but this is just to kind of help you ground each of these pillars into something practical, okay? Hey, this is Andrew Brown, and we are taking a look at business transformation. This is the process of using cloud technologies to change how a business operates and delivers value to its customers. This term, I've never heard it outside of Google, so I think Google has invented it, just like how they've championed the word digital transformation. So just understand that this is more specific to Google to help get you in the mindset of how you can utilize cloud, similar to digital transformation. But let's talk about the points here. So we have transforming workflows with cloud tools to automate, increase efficiency, and reduce costs. Leveraging AI and data to innovate, improve customer experience, and unlock revenue streams. And we can look at this as pillars. So I don't think the official documentation lists this as pillars, but I'm trying to bridge the gap of that information from the digital transformation to the business transformation. So we're going to look at it from a pillar perspective. So we have intelligence, we have freedom, we have collaboration, trust, and we have sustainability. So those are the five that we're looking there. And so those are the 5 business transformation benefits. Memorize those because those will be on your exam. I saw them as a question. But let's go through each one and talk about them. The first one is intelligence. So this replaces traditional systems with cloud-driven data solutions that enable smarter decisions and unlocks AI capabilities. So what services could do that on Google for us? We have BigQuery and Dataproc. So those are 2 options there. For freedom, this is where we shift from legacy hardware to hybrid and multi-cloud architectures, offering flexibility, infrastructure choice. And so in this case, we're looking at Anthos. For collaboration, this transforms collaboration with cloud tools, enabling seamless, secure communication for remote, hybrid, and teams. And if you can guess it, it's Google Workspace. For trust, we have modernizing security and cloud-based protection, offering better visibility and control over data. So here we have Cloud Armor. For sustainability, we have moving away from energy-intensive hardware to Google's carbon-free cloud infrastructure, reducing environmental impact. And this is where we have carbon footprint, where Google can monitor carbon use. Now, I want to be honest with you here that this stuff sounds all great, but again, this is to get you into the Google Cloud ecosystem, and I don't necessarily subscribe that this is necessary to improve your business. I think on-prem still has its place, but understand that this is just PR marketing stuff to get you into the ecosystem of Google Cloud. Okay. All right, let's talk about Transformation Cloud, which is a set of cloud tools and services that help businesses modernize apps and infrastructure, improve collaboration, manage data better, and strengthen security and compliance. So if you go into the Google Cloud console, you can't type in Transformation Cloud and find anything. Confusingly enough, there is a website called transformation.cloud, which has no relation to this. So this is really just a collection of services that are considered services to help with Transformation Cloud, okay? So hopefully that is as clear as I can make it. But let's talk about app and infrastructure modernization. So Google Cloud helps businesses shift from legacy systems to scalable, flexible cloud infrastructure with tools like Anthos and GKE, supporting hybrid and multi-cloud setups. We have data access and efficiency, or we could say data democratization. That's a very hard word for me to say. So Google here will make data more accessible through services like BigQuery and Looker. Then we have people connection. So this is going to be through Google Workspace. As you can see here, you're kind of getting the routine here. And we have trusted transactions where we have Cloud Armor and Beyond Corp. So again, this is just another way for them to organize things where we have digital transformation, business transformation, and then Transformation Cloud. They're just framing it other ways for your organization to figure out how to adopt Google Cloud, okay? So how can we get business value out of our data? Well, if we have 3 kinds of data, let's say user data, industry data, and corporate data, where those all intersect, that's where we can derive business value. So let's just identify these 3 types of data. The first being user data. This would be your customer and behavioral information. So think purchases and returns. For corporate data, this would be internal metrics like sales and staffing. For industry data, this is external market trends and benchmarks. And so what we can do is we can combine these data sets to get better insights. So imagine linking sales data with market trends to improve inventory. We can make decisions based on detecting patterns. So we can make informed choices. That's called data-driven decisions. So here we could be offering personalized products based on customer demographics. We can create new value with data. So here, when we have new data, we can enhance the customer experience, improve the efficiency, staffing, inventory, and sales decisions. So hopefully that is clear. Those 3 components are going to help you find business value, okay? The data value chain is the series of processes where data is collected, stored, processed, analyzed, secured, and ultimately used to generate business insights or value. So let's go through all those steps because we just listed them. The first being data collection. This is where you're gathering data from sources like IoT devices, apps, and customer interactions. Then you have data storage. This is securely storing data in scalable cloud solutions like Google Cloud Storage or BigQuery. You have data processing. This is converting raw data into useful formats using tools like Google Dataflow and Apache Beam. We have data analysis. This is extracting insights using tools like BigQuery ML or Looker. We have data security and governance. This is ensuring data security with encryption and access controls using IAM and cloud security tools. We have data sharing. So this is distributing insights via APIs, dashboards, or Google Sheets. We have data monetization, turning data into business value by selling insights or optimizing decisions. So I really haven't seen this data value chain concept outside of Google Cloud, so I'm not sure if this is industry-wide. It just looks like a data pipeline to me. So there might be variants of this when you go to other providers, but it's still very, very straightforward and clear, so I still think it's valuable, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at what the Google Cloud Console is. And this is a portal that is a web-based unified console that provides an alternative to the command line tools. It allows you to build, manage, and monitor everything from simple web apps to complex cloud deployments. And so this is generally the main way you're going to be interacting with Google Cloud because it's the easiest way to do it. So the idea is that you have this hamburger menu. You can drop down and see all the possible services. You can also search for them. You can organize different projects here and switch between them. And in the background here, what you can see me doing is I'm actually trying to launch a new compute engine virtual machine instance. You can also get notifications and things like that. But basically, everything you want to do is via the console, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look here at Cloud SDK. So SDK stands for Software Development Kit, and it is a collection of software development tools in one installable package. So you can use the Cloud SDK to pragmatically create, modify, delete, or interact with Google Cloud resources. And the SDK is offered in a variety of programming languages. So we got Java, Python, Node.js, Ruby, which is my favorite, Go, .NET, PHP. And so here's an example of us using the SDK with Ruby code. So we've installed the package as a Ruby gem. That's how we did it. And we're accessing BigQuery, and we're just iterating out that table. Okay. Hey, this is Andrew Brown from ExamPro, and we are taking a look at Cloud CLI. So CLI stands for Command Line Interface, and what it allows you to do is process commands to a computer program in the form of lines of text. And operating systems implement a command line interface in a shell or a terminal. That's how you're going to interact with one. And so this is what it looks like to use the CLI. So once it's installed, what you'll do is write gcloud, and then whatever it is that you want to do. So in this case, we are you want to work with a compute engine. So we write compute for SSH into our instance. And so it's just as simple as that, okay? Hey, this is Andrew Brown from ExamPro, and we're taking a look here at Cloud Shell, and this is a free online environment with a command line access for managing your infrastructure and an online code editor for cloud development. So the idea here is these are the two interfaces. They're very pretty similar, but the idea is you'll press this little button here. It will launch generally a shell, and if you want to switch over to the editor, you just press that. And here you can see this is basically a bash terminal. And this one here is a VS Code environment. So there you go. Hey, this is Andrew Brown from ExamPro, and we're looking at projects and folders for Google Cloud. So a project in Google Cloud is a logical grouping of resources, and a cloud resource must belong to a project. So up in your navigation, you're going to see the project you're currently on. You can drop that down, change to another project, or quickly and easily create additional projects. A project is made up of settings, permissions, and other metadata. A project can't access another project's resources unless you use shared VPC or VPC network peering. Resources within a single project can work together easily, for example, by communicating through internal network, subject to the regions and zone rules. Each Google Cloud project has the following: a project name, which you provide, a project ID, which you can provide or Google Cloud can provide for you, a project number, which Google Cloud provides. As you work with Google Cloud, you'll use these identifiers in certain command lines and API calls. So each project ID is unique across Google Cloud. Once you have created a project, you can delete the project, but its IDs can never be used again. When billing is enabled, each project is associated with one billing account. Multiple projects can have their resources usage billed to the same account. A project serves as a namespace. This means that every resource within each project must have a unique name, but you can usually reuse resource names if they're in separated projects. Then there's the concept of folders. So folders allow you to logically group multiple projects that share common IAM permissions. Folders are commonly used to isolate projects for different departments or for different environments. We'll see more of this when we cover resource hierarchies, okay? Hey, this is Andrew Brown from ExamPro, and we're looking at the Google Cloud Adoption Framework, also known as GCAF. And this is a white paper that can determine an organization's readiness to adopt Google Cloud, as well as providing steps to fill in knowledge gaps and develop new competencies, okay? So to really understand the Google Cloud Adoption Framework, we need to know what is a white paper. So it is a report or guide that informs readers concisely about a complex issue. It is intended to help readers understand an issue, solve a problem, or make a decision. And white papers are generally PDF format, but they can also be in HTML format as well. So white papers are common among all the cloud service providers, and they're almost always an essential to study at the fundamentals level. And so for the Google Cloud Digital Leader, I recommend going through the Cloud Adoption Framework, which is what we're going to do here, okay? So the GCAP is composed of 4 themes, 3 maturity phases, the cloud maturity scale, epics, and programs. So let's get into it. Hey, this is Andrew Brown from ExamPro, and we are looking at themes for the Google Cloud Adoption Framework. So themes are just 4 different areas that your company needs to excel in order to be successful with their cloud adoption. So starting at the first here, we have learn the quality and scale of the learning programs you have in place to upskill your technical teams, your ability to augment your IT staff with experienced partners. So who's engaged, how widespread is that engagement, how concerted is the effort, how effective are the results. Number 2 here is lead. So the extent to which IT teams are supported by a mandate from leadership to migrate to cloud, the degree to which the teams themselves are cross-functional, collaborative, and self-motivated. So how are teams structured? Have they got executive sponsorship? How are cloud projects budgeted, governed, and assessed? The third theme here is scale, so the extent to which you use cloud-native services that reduce operational overhead and automate manual processes and policies. So how are cloud-based services provisioned? How is capacity for workloads allocated? How are applications updates managed? And for the fourth one here, we have secure. So the capabilities to protect your services from unauthorized and inappropriate access with a multi-layered identity-centric security model, dependent also on the advanced maturity of the other 3 themes, okay? So what controls are in place, what technologies used, what strategies govern everything as a whole, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at phases for the Google Cloud Adoption Framework. And this is all about the maturity of the organization, because depending on where you are is going to determine the type of action or advice here based on the phase, okay? So for tactical, this is short-term goals, which is individual workloads are in place, but there is no coherent plan. The focus is on reducing the cost of discrete systems, getting to the cloud with minimal disruption. The wins are quick, but there is no provision for scale. So really, they're just trying to utilize anything, and there's no real plan in place, okay? For strategic, this is where you are in the midterm of maturity. So a broader vision governs individual workloads, which are designed and developed with an eye to future needs and scale, have begun to embrace change. People and processes are now involved in the adoption strategy. IT teams are both efficient and effective, increasing the value of harnessing the cloud for your business operations. Then we have transfer transformative or transformationals. There we go. And so this is like long-term goals. So cloud operations are functioning smoothly. So you're in the cloud now, but you're focusing on integrating the data and insights working in the cloud. So existing data is transparently shared. New data is collected and analyzed. Predictive and prescriptive analytics via machine learning is used. People and processes are being transformed, which further supports technological changes. IT is no longer a cost center, but has become instead a partner to the business. Hey, this is Andrew Brown from ExamPro, and we are looking at the cloud maturity scale for the Google Cloud Adoption Framework. And so this is a matrix made up of the themes and phases that we just reviewed, and it will help your organization pinpoint their exact adoption position. So on the horizontal scale, we have learn, lead, scale, and secure to determine our adoption themes. And then on our vertical scale, we have tactical, strategic, and transformational for organization's maturity. So where it intersects with learn and tactical, the idea here is that you are self-taught and you are reliant on third parties. For strategic learn, these are organized training with third-party assisted. For learn and transformational, it's peer learning and sharing with third-party staff augmentation. So just to kind of make sense, because I know these are kind of abbreviated, so it doesn't make a whole lot of sense, but the idea is that if you are learning and you are in the short-term phase, then you're probably going to be self-taught in this, right? Okay. And then if you're strategic, you're going to have organized training because you are bringing people and processes in, as we saw in the as we were describing the maturity phases. And then for transformational, we have peer learning and sharing because we're now established in the cloud, but we're just trying to collect data, make things a lot better. Okay. For lead, lead for tactical looks like it's teams by function, and you have a heroic project manager. Basically, anytime you want to adopt cloud, no matter if it's Google or other ones, you need somebody in your team that's going to act as the hero or the evangelist for that adoption, for the adoption of the cloud. And you got to find that person to carry you through all the stages, okay? So for lead and strategic, we have new functional cloud team. So this is where you actually have a specialized team in your organization because you're now in the cloud, right? And so that's going to help support the workloads and move it further. And then down for transformational and lead, you have cross-functional feature teams, great autonomy. So the idea is you don't just have a single team, but you have multiple teams that are feature specific. So maybe you have data team, you have a DevOps team, and the idea is that you also want to make sure they have the control to do what they need to do in their own space, right? That means in Google Cloud, they're going to have their own folder and they can self-govern all their projects in there. They can do their shadow IT and they don't have to ask a centralized IT to do stuff. For scale and tactical, so change is slow and risk is ops heavy. Because basically everything is still in the old on-premise system, right? So that makes sense. For scale and strategic, templates ensure good governance without manual review. So, you just want to make sure that you have infrastructure as code is in place and you're putting governing rules in the midterm. For transformational scale, all change is constant, low risk, and quickly fixed. So you're really in good shape for scale here. Scale is going to be really easy, right? So whereas this, you're doing a lot of automation still to try to get your scale. For secure, fear of public internet, trust in private network. That's, of course, why people are on-premise, because they're really afraid to be in the public cloud or on third parties in general. So that is something you're going to have to fight with at that stage. For strategic, you have central identity, hybrid network. So that could be using the Beyond Corp, which is the zero trust model, or you could be doing federation between your Azure Active Directory on-prem into with cloud identity using Google's syncing directory service. Then the last one here is secure and transformational trust. Only the right people, device, and services. This is what they're talking about. They're talking about the zero trust model here. So that really is where Beyond Corp would come into play for the Google Cloud Adoption Framework, okay? Hey, this is Andrew Brown from ExamPro, and we were looking at TAMS, which stands for Technical Account Manager. And no matter if you're using Google Cloud, Azure, AWS, they all have TAMS. And this is a human resource assigned to work with your organization when paying for Google Cloud's premium support. So TAM can assist with Google Cloud Adoption Framework by performing a high-level assessment of your organization's cloud maturity, tell you how to prioritize your training, change management programs, partner relationships, cloud operating models, secure account configuration. So the idea here is that, if you don't know how to apply the Google Cloud Adoption Framework, you want to get a TAM because they're really going to help you connect you to people that do know how to do it or give you a bit of a kickstart in that process, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at compute for Google Cloud Platform. And so there's a variety of services, so let's get to it. The first being Compute Engine, and this one is for virtual machines or VMs. And this is generally the primary or traditional type of compute you are going to utilize on a cloud service provider. Then there is bare metal. So bare metal is where you have full control of the hardware. So you can install any kind of hypervisor you want on it or virtualization. It's going to allow you to have very low latency on Google Cloud. Then we have App Engine, which is a platform as a service. Build and deploy apps on a fully managed, highly scalable platform without having to manage the underlying infrastructure. We're going to spend a little bit more time on App Engine because the exam definitely pops up with a few questions that talk about its different core offerings. We have cloud GPUs, so add GPUs to your workloads for machine learning, scientific computing, and 3D visualization. You have Google Kubernetes Engine, also known as GKE, so reliably, efficiently, and securely deploy and scale containerized applications on Kubernetes. We have sole tenant nodes, and this is known as dedicated virtual machines in all the other different providers. So the reason you'd want to use these is you need to meet compliance, you have your own licenses, you need to keep these instances physically separated with dedicated hardware because maybe you're not allowed to run it with as a multi-tenant. So there's all sorts of reasons for that. You have cloud functions. So these are functions as a service. So you can create serverless single-purpose functions that respond to the events. I guess I could have put Cloud Run on this as well, which is serverless containers, but we have a container section, so it's not a big deal. We'll get to that. Some kind of auxiliary services that are used that are important to know with compute would be Google Cloud VM Engine or VMware Engine. So migrate and run your VM workloads natively on Google Cloud. You have Migrate for Compute Engine. So migrate servers and VMs from on-premise or another cloud to Compute Engine. This was formerly known as Velostrata. Preemptible VMs, so deploy affordable, short-lived compute instances suitable for batch jobs and fault-tolerant workloads. We're going to cover that again when we go to our pricing section. Shielded VMs, so deploy hardened virtual machines on Google Cloud. Hey, this is Andrew Brown from ExamPro, and we are taking a deeper look here at App Engine. So App Engine is a platform as a service for your applications. You can quickly deploy and scale web applications without having to worry about the underlying infrastructure. And a great way of thinking of this is if you know Heroku, it's basically the Heroku of GCP. So the idea here is you can use your favorite programming language, whether it's Node.js, Java, Ruby, C#, Go, Python, or PHP. You can also bring your own language runtime, and you do that by creating a custom Docker container. So there is all our familiar logos just to kind of put home as to what you can use. It has powerful application diagnostics. You have cloud monitoring, cloud logging to monitor the health of your performance, cloud debugger and error reporting to diagnose and fix bugs quickly, application versioning, so easily create development, test, staging, and production environments, traffic splitting, so route incoming requests to different app versions, A to B tests, and do incremental feature rollouts. You have application security, so defining access rules with App Engine Firewall, and you can leverage manage SSL TLS certificates by default. So the idea is that you have all this infrastructure, and this is not even the full list, but all this stuff around your application that you would generally have to do yourself, but they do it all for you, okay? Now, there are two types of environments that you can launch with App Engine. You got flexible and standard. It's very, very, very important that you know the difference for the exam because they will have scenarios where you have to pick one or the other, okay? So you can simultaneously use both environments for your application. So it's not you have to use one or the other. It just depends on what kind of workload you're running. An App Engine is well suited to applications that are designed using microservice architecture. So splitting it down the line, let's talk about standard, and then we'll talk about flexible. So standard, I would describe as being serverless compute. So it starts in seconds. It's going to run in a sandbox, meaning that there's like you don't have like you're not deploying a container. It's just you're uploading your code. Okay. It's designed for rapid scaling, so it can handle sudden spikes of traffic. It supports specific language versions, but it's not a custom runtime. So if you've ever deployed a serverless function where you're just like choose Ruby, that's the language you get of a particular version. Okay, you're not going to get that much flexibility around that. It can scale to 0 instances, so that's another characteristic of serverless compute. Its pricing is based on hours. You cannot use SSH to debug it, which is very common for serverless apps. There are no background processes. When we're looking at flexible, these are fully managed containers. So it starts in minutes, runs with Docker containers on compute engine VM. So that's what it's doing underneath. It's designed for predictable and consistent traffic. It supports generally any language version, or you can run a custom runtime. Must have at least one instance running. The pricing is based on vCPUs, memory, and disk. You can SSH to debug it, and you can have background processes. So just understand those two, and you'll be good for the exam, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at containers for Google Cloud Platform. So containers are a type of compute, but there is so much going on here with Google that it deserves its own page. So we have Google Kubernetes Engine, so GKE, which is reliably, efficiently, and securely deploys and scales containerized applications on Kubernetes. You have Cloud Build, so continuously build, test, and deploy containers using the cloud Google Cloud infrastructure. You have Artifact Registry, so store, manage, and secure container images and language packages. You have Container Registry, so store, manage, and secure your Docker containers images. These sound really similar, and that's because this is actually the second version of Container Registry. So both of them exist, but generally it's recommended always to use Artifact Registry, okay? You're not going to probably see that like them lined up against each other, but just so you know, the benefit's always towards Artifact Registry over Container Registry, okay? If you want to use a virtual machine, like a compute engine, you can pretty much just checkbox it on, and now you have a container optimized OS. So it's really easy to use containers, even with compute engine, which is nice. You have Cloud Run, which is a stateless container, fully managed environments, and you can also use it with Anthos. So this one, and I really should have highlighted this in yellow here, but stateless containers is something you want to remember for your exam. They also have containers for the AI platform deep learning. So this is when you'd be using Vertex AI. You might need to have a bunch of tooling around that. And then there's also the Google Marketplace for Kubernetes applications. So if you're using Kubernetes and you just need something that's already pre-built and you're willing to pay, or there's some free stuff in there, you can go there and get them, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at Kubernetes, which is an open source container orchestration system for automating deployment, scaling, and management of containers. It's originally created by Google and now maintained by the Cloud Native Computing Foundation, also known as CNCF. What's interesting is this foundation also has their own certifications, like the Certified Kubernetes Administrator and the Certified Kubernetes Developer, so don't be surprised if you see me making courses for that in the future. Kubernetes is commonly called K8. The idea here is that the 8 represents the remaining letters, so U, B, E, R, N, E, T. The advantage of Kubernetes over something like Docker, and you've probably heard of Docker for containers before, but it has the ability to run containers distributed across multiple VMs. That's what Kubernetes can do that Docker cannot do on its own. A unique component of Kubernetes are pods. A pod is a group of one or more containers with shared storage, network resources, and other shared settings. That is kind of the special kind of infrastructure or architecture that Kubernetes has. Kubernetes is ideal for microservice architectures where companies have tens to hundreds, I really should have highlighted that in red for you, tens to hundreds of services they need to manage. If you don't have, I didn't say containers, I said services, because that could be, there's even more containers than tens to hundreds, you know what I mean? There could be thousands. But the idea here is that Kubernetes does add a lot of management layer to it, but the idea here is that, when you have a lot of services, it is the best choice, okay? Hey, Hey, this is Andrew Brown from ExamPro, and we are looking at databases for the Google Cloud Platform. And the first on our list is BigQuery. And this one is a big deal because not only is it a data warehouse, it's a serverless data warehouse. And the reason why that is important is because traditionally, data warehouses are extremely expensive, but this one, because it's serverless, that means it can scale to zero, and it's only when you're using it do you pay for it, okay? And so that is a very unique cloud offering. Azure says they have kind of a serverless data warehouse. It's totally not true. The only one that has it is Google. And so it's a big deal, okay? And it's definitely going to show up more in this course, and it will absolutely be on the exam, okay? So it can store terabytes or petabytes of data using NoSQL. It is a wide column database service, and it also has built-in ML, which we'll visit later on, okay? Then there's Cloud Spanner. This is a fully managed relational database. This is not Postgres. This is not MySQL. It is a proprietary relational database designed by Google for scale. It has SQL, so you'd have to do a tiny bit of translation if you already have an existing database. But the idea is that if you want something that scales like crazy, then this is the service for you if you're using relational databases. You got Cloud Bigtable. This is a NoSQL key value store. It is a fully managed NoSQL database for large analytics and operational workloads. So that's there. We have Cloud SQL, and this is a relational database service. So if you're using MySQL, Postgres, SQL Server, it's just a managed service to host them there. Then you have Firestore. It's a NoSQL document database. It adds NoSQL document database to mobile and web apps. It can get kind of confusing because there's another service called Firebase, which we cover in this course, and it has Firebase Firestore, but it's the same underlying service, okay? This one is very similar to MongoDB. It's not MongoDB. It's a proprietary service by Google. But one of its key features is that it has a real-time component to store and sync data in real time. And that is a very big deal. And that particular note there you want to remember because that will show up on the exam. If someone's asking for a database and there's a real-time component, it's going to be Firestore, okay? You got memory store. This is not going to show up in the exam, but it's an in-memory database to achieve extreme performance using a managed in-memory data store service. So think of Redis. That is basically what this is. And then last on our list here, we have Database Migration Service, DMS. This is a serverless, easy, minimal downtime migration to Cloud SQL, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at databases. So a database is a data store that stores semi-structured and structured data, and a database is more complex data store because it requires using formal design and modeling techniques. Databases can be generally categorized as either a relational database, so structured data that strongly represents tabular data, such as tables, rows, and columns. That means it could either be row-oriented or column-oriented, or non-relational databases, semi-structured data that may or may not distantly resemble tabular data. And so the way these things work is you'll generally have a specialized language to query in, such as SQL, a specialized modeling strategy to optimize retrieval for different use cases, more fine-tuned control over the transformation of the data into useful data structures or reports. And normally when we just say database, we're generally referring to relational row-oriented data stores. So think MySQL, Postgres, MSQL, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at the concept of a data warehouse. So it's basically a relational data store or database designed for analytical workloads, which is generally column-oriented, okay? So companies will have terabytes or millions of rows of data, and they need a fast way to be able to produce analytical reports. Data warehouses generally perform aggregation. So aggregation is grouping data, so like finding a total of average. Data warehouses are optimized around columns since they need to quickly aggregate column data. And so data warehouses are generally designed to be hot. Hot means that they can return queries very fast, even though they have vast amounts of data. Data warehouses are infrequently accessed, meaning that they aren't intended for real-time reporting, but maybe once or twice a day or once a week to generate business or user reports. A data warehouse needs to consume data from a relational database on a regular basis. So that's what we're kind of seeing over here, where imagine that this is our data warehouse and we want to generate a report. The idea is that we're either ingesting data from SQL, or if we're ingesting data from a tabular-like structure, we have to use ETL so to transform the data into the format that we want, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at a key value store. So key value databases or data stores is a type of non-relational database, NoSQL, that uses a simple key value method to store data. And the way I like to describe them is that they're dumb and fast, and they generally lack features like relationships, indexes, aggregation, transactions, you name it, they don't have it, but what they do have is speed, okay? So a key and value store is a unique key alongside a value, and the idea here is that a simple key and value store will interpret this data resembling something that looks like a dictionary, so an associative array or a hash. And so when we look at it, kind of like a table, it can resemble tabular data, but it does not have consistent columns per row. Hence, it's called schemaless because it doesn't follow a particular scheme. Due to the simple design, they can scale well beyond a relational database. And key value stores are generally the ones that are the most scalable. But the idea is that because of the simplicity of these things, usually you are, like these are really great for like leaderboards where the data is exactly stored the way you want to see it, okay? So if you have to do joins or data manipulation, then these are not going to be very ideal. But if the data is exactly as you need to see it, then they work really well, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at document stores. So a document store or document database is a NoSQL database that stores documents as its primary data structure. So a document could be XML, but it's more commonly JSON or JSON-like. Documents are a subclass of key value stores. The main difference is that they can store nested dictionaries, nested hashes, okay? The components of a document store compares to relational database is the easiest way to explain it. So where you would have tables, they call them collections. Where you'd have rows, they call them documents. Where you have columns, they call them fields. Indexes are the same, and you do have some ability to do joining via embedding and linking. So, you can leverage that tabular data to kind of think about how document stores are, but fundamentally, they're not tabular data, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at serverless services for Google Cloud Platform. So what is serverless? Well, serverless architecture are fully managed services that automatically scale, are highly available, durable, secure by default, abstracts away the underlying infrastructure, and are built based on the execution of your business task. So the idea here is you pay for the value, you don't pay for idle servers, and serverless can scale to zero, meaning when not in use, the services don't generally cost anything. So let's look at cloud functions. This is functions as a service. When we're talking about serverless on any CSP, this is what people look at first, is what is the serverless functions, okay? And so you choose a runtime, upload single function code. So they're not full web apps, just parts of code, and they're intended to be short-lived, and everything else is taken care of for you. You have Cloud Run. This is for serverless containers, so run stateless containers on a fully managed environment or via Anthos. You have App Engine, platform as a service, so build and deploy apps using traditional web frameworks, and all the underlying infrastructure is taken care of for you. Platform as a service is not always serverless, but App Engine specifically has a serverless offering, which is the standard version. You have Event Arc, and this is a serverless event bus. So you build event-driven solutions by asynchronously delivering events from Google services, SaaS, and your own apps used for application integration. AWS's one is called EventBridge, so it's the same thing there. So the idea is it's application integration for Google services and other third parties, okay? You have Knative. This is serverless K8 containers, deploy and manage serverless cloud-native applications for Kubernetes. You have Workflows. This is a serverless state machine, so orchestrate and automate Google Cloud and HTTP-based API services with serverless workflows. You got BigQuery, serverless data warehouse. Understand your data using a fully managed, highly scalable data warehouse with built-in ML. Then you have cloud storage. This is serverless storage, so it's an object store, and the idea is that this stuff is highly available. It's distributed across multiple data centers. You just upload files. You don't think about anything like about the disks or anything else, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at storage for Google Cloud Platform. So we got cloud storage, persistent disk, and file store. There is cloud storage for Firebase. That's not going to show up on your exam, but let's dive into these three really quickly about their architecture and why they would be used in certain circumstances. So for persistent disk, the idea here is that it's using blocks as a means of storage. So it has a virtual disk and it stores things just like it would on a regular disk. The idea here is that you have direct access to the operating system. And it supports only a single write volume. All right, we'll talk about the use cases at the end of going through these three architectures. Then we have file store, which is a file share. So the file is stored with the data and metadata. We have multiple connections via the network share, supports multiple reads, but for writes, they're going to get locked when someone's writing, okay? Then you have cloud storage, which is for object or blob storage. So data is stored as objects. So there's metadata, unique ID. It scales with next to no upper limit in terms of the storage. It supports multiple reads and writes, so there are no locks in place. So what would you use these things for? Well, the first one, the idea is that you would, if you had a virtual machine and you need a volume, you could attach a block storage. This is just basically a virtual hard drive. So you could have a VM with multiple block storage or virtual hard disks. But the thing is that that virtual disk is only being used by one operating system at the time, the single VM, okay? So if you needed to have a virtual hard disk that could be accessed by multiple virtual machines, that's good where you're going to be using a file share, and that's what file store is. Or you could also just have users connect to it because it's using this NFS and SMB protocol, and these are ways where you could easily mount the drive to your Windows computer or to a virtual machine, okay? And so then last we have is cloud storage, which is an object serverless storage. The idea here is that you can just upload files. You don't have to choose the size of the drive, the type of the drive. You don't have to worry about backing up the drive or the redundancy of the drive. It just works, right? And there's no concept of a drive. It's just there's a bucket and you put everything in it. The only drawback here, it's not intended for high IOPS, so input outputs, reads and writes. Like it's pretty darn fast, but the idea is that, if you, it's not going to be used as the primary drive of a virtual machine, right? It's going to be for accessing files, okay? So hopefully those three categories are clear. Hey, this is Andrew Brown from ExamPro, and we are taking a look at cloud storage. So cloud storage is a serverless object storage service. You do not have to worry about the underlying disks, right sizing, availability, durability, the file system underneath. You only pay based on the storage, so the at-rest storage, and the download, so actually accessing or requesting files. Files are called objects, and folders are called buckets. It has unlimited storage with no minimum object size. Probably there is an upper limit. Most serverless object storages do have a particular limit, but theoretically it's unlimited storage. Worldwide accessibility and worldwide storage locations, low latency, so time to first byte, typically 10 milliseconds, has a high durability, so it has 9 nines of annual durability. When I say 9 nines, it's because it's 99 and then followed by 9 nines, okay? It has geo-redundancy if the data is stored in multi-region or dual region. It has a uniform experience with cloud storage features, security tools, and APIs. And I want to cover available storage classes because these do show up on the exam. This isn't something that other fundamental certifications would go this deep on, but Google really wants you to know better in detail their core services. So for available storage classes, we have standard. And so here, this is for frequent file use. So if you're building a web application or just general use, you're going to be going with standard storage. Now, this is the least cost-effective solution. It's not expensive, but there's ways to save, okay? You have nearline storage. This is when you're going to be accessing, on average, a file once a month or less, right? It's going to be cheaper than standard storage, but the key thing is once a month or less. Then you have cold line storage. This has a higher access cost than nearline store, but a lower at-rest cost. So that's kind of just a bit of a trade-off there. You have archive storage. This actually has no SLA availability. It's zero availability SLA because it's offline, right? So very slow retrieval, very cost effective, rarely or never intended to be accessed. You're using these to store like like reports or accounting information that you have an obligation to store for 7 years, that's when you'd be using that. Notice that there's this number here. It says 0, 30, 90, 365. This is the minimum storage duration. It's the minimum days a file needs to remain in a storage before deleting. If deleted prematurely, a charge will occur. So the idea is they want you to hold on to them for a particular time to effectively use them, right? Because if you delete them sooner, then it doesn't make sense for you or for Google Cloud. But yeah, I just want to emphasize that available storage classes will be on the exam, and they showed up more than once for me, so definitely know the difference, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at networking for the Google Cloud Platform. So the most important service to talk about is the Virtual Private Cloud, VPC. It is a logically isolated section of the Google Cloud Network where you can launch Google Cloud resources. And the idea is, once you have your slice of the network, the amount of resources you can launch is based on how many available IP addresses, and that's determined by CIDR range. So CIDR range or CIDR notation is a format that looks kind of like an IP address. It has this / thing on the end here, and that is what's determining how many available IP addresses are. If you have 65,000, that means you can launch pretty much 65,000 virtual machines. You don't ever just launch something into a VPC. You'll launch it into a subnet of a VPC. A subnet is a subdivision of the virtual private cloud. And the way that works is that you'd actually have to choose a CIDR range as well. That CIDR range is going to be smaller than the VPC one. Interestingly enough, the larger the number is, the smaller the IP range is. That's just how the math works. You don't need to know for the exam, but I like to cover this stuff anyway because it's fundamental information. We have public subnets and private subnets. Public subnets can reach the internet. Private subnets can't reach the internet. Now, there is no hard rule about that. Like, there's no constraint that is just like, you don't say create a private subnet. You just create a subnet. And if you don't want, if you want to treat it as a private subnet, just don't give them any external or public IP addresses. So here I have a little diagram I made here for you just to kind of explain some of the components. This is not an exhaustive one. Networking has so many features here. It just got too complicated, so we'll just have a very simple example here. So here we have our VPC. A VPC has to be launched within a region, so here it is in US West 1. We have a public and private subnet. These would be launched in particular zones. That's how you get multi-zone. So you create a subnet across one subnet per zone, so you have 3 zones, and that way you'd be highly available. We have compute engines. These are virtual machines running here. So if we wanted a virtual machine in our public subnet to reach the internet, it has to have an external IP address. It would also communicate through an internet gateway. In Google Cloud, you don't have to create an internet gateway like AWS. It's just there. There's already routes set for it. So that's really nice. You don't have to think about that. For a private subnet, if it has to go out to the internet, not internet coming in, you'd have to use a network address translation. So CloudNet, that's pretty standard across all the cloud service providers. If you're trying to get traffic into a virtual machine sitting in a private subnet, that is where you'd need some kind of hybrid connection. So a cloud VPN or cloud interconnect. You'd probably be using both of these in combination. That's usually how it goes, or just the cloud VPN. But that basically establishes a private connection to this VPC and its private subnet, and that way you could just treat it as the same network. The way you're going to protect your resources is via firewall rules. Firewall rules are at the instance level, and they're also stateful. So you can say allow or deny, which is, again, if you're in AWS, it's totally different, right? You have different controls for that, okay? But yeah, that's generally the main components there, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at more networking services for the Google Cloud Platform. Now, these are just basically auxiliary services. Not all of them you really need to know in detail for the exam, but you should know them in general, and they can kind of help you out. So let's go through them all. So we have Cloud Armor. This helps protect against DDoS and web attacks. We're going to cover that later again. This one could show up on your exam. Cloud Load Balancing is just a load balancer, a high-performance load balancer. We have Cloud CDN. So this is a content distribution network. It caches your data globally so that your websites load fast, stuff like that. CloudNet, the provision applications without public IP addresses, allows web apps to communicate in private subnets out to the internet to download things like packages or software updates, things like that. Cloud DNS, publish and manage your domain names using Google's reliable, resistant, low latency DNS service. Traffic Director, this is a global load balancer. This has to do with like service mesh stuff. Cloud Interconnect, so connect your infrastructure to the Google Cloud on your terms from anywhere. Cloud VPN, securely extend your on-premise network to Google's network through IPsec VPN tunnel. That's how you get a secure connection from your on-premise to your network, Google Cloud Network. Cloud Router, dynamically exchange routes between your Google Cloud Virtual VPC network and your on-premise networks using BPG. So that's just a component you need to do a hybrid connection. And then we have some auxiliary services, like very auxiliary services for just kind of like monitoring things like that. So Network Intelligence Center, a single console for comprehensive network monitoring, verification, optimization. Network telemetry, track network flows for monitoring, forensics, real-time security analysis, expense optimization. Network service tiers, optimize your network for performance or cost. So for your exam, Cloud VPN, Cloud Interconnect, Cloud Armor, and that's about it. Okay. Now they say like there's supposed to be things like SD-WAN and service mesh. I never saw those on the exam. So these are the real three that you need to know, but these are all the other things that are involved. Okay. Hey, this is Andrew Brown from ExamPro, and we still got one part left with networking. These are just kind of like features of VPC that I just want you to know they're not core to any questions on the exam, but they might show up as choices, and so it'll help you eliminate them as the wrong answer, okay? So we have private Google Cloud. This allows your instances to reach Google APIs and services using an internal IP rather than a public IP address. So sometimes services are publicly accessible, maybe like Firestore or something like that, or BigQuery. And so the idea is you want them to stay in the network, right? Because you're paying outbound or egress costs, or you're concerned about security. And so having private Google Cloud turned on is a good idea. That doesn't necessarily mean that your subnet's a private subnet because you turn this on. It just means that when it communicates with Google services, it's going to use a private IP address. For shared VPCs, this is a way of sharing subnets with other projects, so connect resources from multiple projects to a common VPC. This sounds like VPC network peering. It's more like a convenience feature where you're not doing it at the networking level, it's more at the project level. So it confuses me a bit, but I get it. There's VPC networking peering, so privately connect two VPC networks, which can reduce latency costs and increase security. So VPC peering is common in all cloud service providers. Just joining those VPCs together. Serverless VPC access, allow cloud functions, cloud run services, app engine, standard environments, apps to access resources in a VPC network using those private IP addresses. I wonder if you have to have private Google Cloud turned on for that, but it sounds like the other way. So private Google Cloud is like my machine connecting with other Google Cloud services, and serverless VPC access is just services that are generally public facing, where you access them over a public IP address, access things via the private network, okay? BigQuery is a serverless, fully managed data warehouse and analytics engine designed for fast, scalable data processing across clouds. So here is a screenshot of the BigQuery Studio. And I'm just going to tell you that this is the best-in-class data warehouse out of all the cloud service providers. If there's one service really worth using on GCP, it is BigQuery. And so the idea here is that you can run SQL queries in your editor. It's pretty straightforward to use. You can easily connect to various data sources and BI tools for smooth data import. You can quickly browse data sets and tables through the user-friendly interface. You can use the UI, command line, APIs, making it simple for both beginners and experts. In terms of the workflow, it kind of looks like this. So on the left-hand side, you have data ingestion. So you have things coming from BigQuery, cloud storage, Google Sheets, databases, apps, files upload. You're bringing that raw data into BigQuery. It's interesting. You can bring BigQuery into BigQuery. And here we can refine the data, and then we can output it to BigQuery or cloud storage. And then from there, we can analyze the data with BigQuery or BigQuery ML, Looker, which is obviously a BI tool, Google Data Studio, partnered BI services like QLink, or send it to the cloud AI platform. In terms of key features for BigQuery, we have serverless and managed. There's no need for infrastructure. Google handles scaling and updates. And I'm going to tell you, there's other providers that have serverless, I'm doing air quotes right now, serverless data warehouses, but the only one that I consider truly serverless is BigQuery because it's so easy to use. It's real-time and flexible. It supports continuous data streaming and handles structured and unstructured data. It has multi-cloud analytics, so it can analyze data across multiple clouds using open formats like Apache Iceberg, which is becoming a very popular table format. We have efficient storage and querying, so columnar storage for fast queries with built-in analytics and machine learning. Security and governance, so centralized access controls, encryption, and compliance tools. It has flexible pricing, so on-demand or reserved pricing to optimize costs. And when we're talking about data import, it can support a variety of format types, so CSV, JSON, Avro, Parquet, Google Sheets for analysis. But Excel is not supported, which kind of makes sense. It's a Google product. And if you ever tried to parse an XLS file, it is a pain. So I kind of understand that. But a really, really good service. It is worth your time to learn more about it, okay? All right, let's take a look at Looker, which is a business intelligence tool that allows users to explore, visualize, and share their company's data to make informed business decisions. Looker lets non-technical users analyze data through easy-to-use dashboards and drag-and-drop tools, allowing them to create custom reports and insights without advanced data skills. Looker offers 3 platform editions: Standard, so ideal for small teams under 50 users; Enterprise, designed for internal BI analytics at scale; Embed, ideal for external analytics and large-scale customer apps. In terms of feature sets, we have a unified data platform, so real-time access to multiple data sources for consistent, up-to-date insights across teams. For personalization and customization, it can quickly create custom dashboards and reports, which they call looks, for personalized insights. For collaboration and sharing, we can easily share data and reports via emails, links, or integrated tools. For development and integration, we can use LookML and APIs to customize data models and embed insights into other apps. And so there's an example of what a look would look like. I don't have strong opinions about Looker because I have more familiarity with Power BI and Tableau. And, the base cost for this service is a bit makes me uninterested in utilizing it, but in further GCP certifications, you actually have to utilize it a lot more. So in those courses, we look at it a bit deeper, but I look at this offering just like I look at Amazon's BI tool, AWS's BI tool. I can't remember what it's called off the top of my head right now, but anyway, it's nice that they have it, but, if it's a real company, I think they're going to be using Power BI or Tableau. But, if you want to keep all of your data within the Google ecosystem, that's one reason why people might want to utilize this, okay? All right, let's talk about integrations between BigQuery and Looker. So BigQuery and Looker lets you explore and visualize BigQuery data directly within Looker, making it easy to analyze large data sets without needing complex queries. So, the idea is that with SQL, you can get it from Looker, Looker can get from BigQuery using SQL, and Looker can bring results back to BigQuery. So that's kind of a little screenshot of that example. But anyway, you can query BigQuery data in real time, getting insights without waiting or delays. No data transfers, so no need to move data, keeping workflows smooth and fast. Unified access, so intuitive interface for exploring data without needing SQL skills. Seamless integration, so combine BigQuery power with Looker's visualization for fast and actionable insights. So there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at internal services for the Google Cloud Platform. So these are services that you generally cannot use, and they're designed to be supportive of all the underlying infrastructure for many Google Cloud services. I just want to get you exposed to these because they might show up as choices, as distractors on your exam. And you might see them in the documentation with no context, and so you just might wonder what these things are. So that's why we're going to cover them. And the first one actually is an exception where you can use this service, but it's Spanner. And so Spanner, without the word cloud, is the internal service, globally consistent, scalable relational database. And then Google made this available to us as Cloud Spanner. Then you have Borg. It's a cluster management manager that runs hundreds of or thousands of jobs from many thousands of different applications across a number of clusters, each with up to tens of thousands of machines. Borg, I think, is inspired by Star Trek, right? The Borg. We have Chubby, a distributed lock manager, DLM, as a service that temporarily prevents files and records from being used by another user or operation on a virtual machine. And then you have Colossus, cluster level file system, successor to the Google File System, GFS, provides the underlying infrastructure for the Google Cloud Storage Service, from Firestore to Cloud SQL to Firestore again, I suppose, and to Cloud Storage. I guess I was trying to write something else there, but that's okay. But there we go. Hey, this is Andrew Brown from ExamPro, and we're looking at what is Apogee. So Apogee Corporation was an API management and predictive analytics software provider before its merger into Google Cloud. So Apogee is a founding member of the Open API Initiative. So that's what we're talking about, Open API 3.0 specification, originally known as the Swagger specification. So Open API specification is an open source standard for writing declarative structure of an application programming interface API, and can either be written in either JSON or YAML format. So here it is. But what they're talking about here is that there's things called API gateways. And API gateways is a hosted version of an API. And if you're familiar with APIs, the idea is you can define endpoints. You can say, I want a route to users, and it's a GET. And the idea is I want to send it to somewhere. I want to send it to this Lambda, to this virtual machine or whatever, okay? CSPs will have fully managed API services known as API Gateway. These API gateways generally support open API standards, so you can quickly import or export APIs. So like on AWS, you can use Open API 3.0 or Swagger, which is 2.0. Same thing with GCP, same thing with Azure. They all have these things, okay? But in particular, Google has Apogee, okay? And so their Apogee services were blended into Google Cloud Platform, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at API management. So API management is where you have API gateways that are basically hosted API endpoints that access Google Cloud resources. We got a couple of options here. We have the Apogee API platform. This is an API gateway. Develop, secure, deploy, monitor APIs everywhere. Expensive, but has many features. Then you have Cloud Endpoints. This is also an API gateway. Develop, deploy, and manage APIs of Google Cloud. Cheap and simple. Good integrations with app engines and other services. I don't know if Cloud Endpoint came before Apogee, but I mean, I can understand why there's two offerings here. You know, they acquired a company that had an API gateway, and then they just wanted a cheaper one that's more like serverless kind of offering on the right-hand side. So, but we'll look at what Apogee does, because it does a ton. So we have API analytics. We have API monetization, where you can actually, people pay to access particular resources via the API. Apogee Sense, so add intelligent behavior detection to protect APIs from attack. Apogee Hybrid, so manage API on-premise, on Google Cloud, or in a hybrid environment. So you can use your APIs outside of Google Cloud, which is cool. Cloud Healthcare API, help secure APIs that power actionable healthcare insights. I think that last one is on the Apogee side. For Cloud Endpoints, now it doesn't sound like it does much, but it has one really cool thing, which is a developer portal. So the idea is that once you've created your API, you can press a button, and it takes about 10 minutes. But what it'll do is it'll spin up a website or web app that allows you to explore the API. And that's really useful if you're just like looking for documentation, or you want to interact with the API for the developers on your team. And I really like that feature. So there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at data analytics services for the Google Cloud Platform. So the number one here is BigQuery. Understand your data using fully managed, highly scalable data warehouse with built-in machine learning. You got Cloud Composer, create, schedule, monitor, and manage workflows using a fully managed orchestration service built on top of Apache Airflow. You got Dataflow, develop real-time batch and stream data processing pipelines. It is using Apache Beam in this case. Cloud Data Fusion, so quickly build and manage data pipelines using fully managed code-free data integrations with a graphical interface. You have Data Prep by Trifacta, so explore, clean, and prepare data for analysis. Data Proc, perform batch processing, querying, streaming using a managed Apache Spark Hadoop service. You got Google Data Studio, tell great stories to support better business decisions. PubSub, ingest event streams from anywhere at scale. Data Catalog, discover and understand your data using a fully managed scalable data discovery and metadata managed service. Cloud Life Sciences, process, analyze, and annotate genomic and biomedical data at scale using containerized workflows. For the exam, you want to know the difference between Dataflow and Data Proc because these will come up like side by side in choices, and they seem very similar because they do the same thing. Actually, these three all do the same thing. They're ETLs. They take data and they do batch transformations on them or streaming on them. But this one here, Dataproc, is when you want to use Hadoop. Then you have Dataflow, and this one is more of a fully managed service. And then Cloud Data Fusion. This is where you actually have a graphical user interface and it's code free. All right. So, if you understand the difference between those three services, you're going to get yourself some extra points there on the exam. Other than BigQuery, nothing else really showed up here. Just those three. Okay. Hey, this is Andrew Brown from ExamPro, and we are going to make sure we know the difference between Dataproc, Dataflow, and Cloud Data Fusion because they're going to show up on the exam and they can get confusing, okay? So Dataproc is for open source pipelines, Apache Spark, Apache Hadoop. So it can do batch processing, querying, and streaming. And so the real focus here is really on Spark because Spark is known to be the fastest tool. I think it's like 50 times faster, 100 times faster than standard Hadoop jobs, and overall, it's super, super fast, extremely popular. So, that is the reason why you'd go with Dataproc because you're using Apache Spark or Hadoop. The downside here is there's more management to be involved here. Some of it's abstracted away, but not all of it. Then you have Dataflow. This is a fully managed pipeline for batching and streaming, okay? It's powered by Apache Beam, which is technically open source, but that is not an open source tool for actually doing the batching and stuff. It's to manage the pipeline, okay? So if you need a fully managed service, that's what you're going to use. Then you have Cloud Data Fusion. This is a way of visually building pipelines. It's a no-code enterprise solution for building ETL pipelines via drag and drop interface. I don't think you can use this for streaming. It has 150 plus pre-configured connectors and transformations. So you just drag and drop stuff. You just run it, and as it's consumed, that's what it does. If you're using Azure, this is the same thing. This is similar to Azure Data Factory or AWS. This is similar as Glue, okay? Again, I don't think it does streaming, but I think that Cloud Data Fusion probably would have the highest price point. For best performance, you would be using Dataproc. For the least amount of headaches, but still doing things pragmatically, you'd be using Dataflow, okay? So those are the three, and remember them, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at developer tools. Now, these aren't really going to show up on the exam, or if they are, we've already covered them, the most important ones. But I just wanted to go over these just so that you had a full scope, just for your own knowledge of things that are here. I couldn't even be bothered to even pull out icons for this one, but let's get through it here because I think that, you might be able to take something away from this that you might use in your own development workflow, okay? So you have Artifact Registry, so this is for storing containers. You have the Cloud SDK, we covered that earlier. This is a package to interface with the command line interface or pragmatically write code in your code. You have Container Registry. This is the older form of storing containers, recommended to use Artifact Registry nowadays. You have Code Cloud Code. Man, that's a hard one to say. Extend your IDE with tools to write, debug, deploy Kubernetes applications. So it's just I think you saw that with Visual Studio Code, but it's just stuff around Kubernetes. Cloud builds. So we looked at this in our container section. This is for running containers for build environments. Cloud source repositories. So manage code and extend your Git workflow by connecting Cloud Build, App Engine, stuff like that. It's just a way of connecting Git repos to various services. Cloud Scheduler, schedule batch jobs, big data jobs, cloud infrastructure operations using a fully managed cron job service. If you use AWS, that's CloudWatch, right? Cloud tasks, asynchronously execute, dispatch, deliver distributed tasks. When you're working with cloud functions, you're going to be working with cloud tasks. Cloud code for IntelliJ, so debug production cloud apps inside IntelliJ, okay? Tools for PowerShell, so you can work with PowerShell with Google. They got tools for Visual Studio Code, Eclipse, App Engine plugins, a Maven App Engine plugin. So it's all for Java there, the Gradle and the Maven. Firebase Test Lab, so test your mobile apps from a variety of devices and device configurations. That one I'm interested in checking out. Firebase Crash Analytics, but these are all within Firebase, so that's the only issue there. So get clear, actionable insights into your app issues. Tecton, so create CID style pipelines using Kubernetes native building blocks. Workflows, orchestrate and automate cloud, Google Cloud HTTP-based services. That's a serverless state machine. EventArc, build event-driven solutions by asynchronously delivering events from Google services. That is just a serverless event bus. So a lot of these we've already covered, but just wanted to show you some of these tools because maybe you use one of these IDEs and you just went, oh, okay, I'm going to go check this out. I use Eclipse. That'd be cool, you know? Hey, this is Andrew Brown from ExamPro, and we are looking at hybrid and multi-cloud services for Google Cloud. Now, it seems like we're reiterating over the same services again and again in different ways, and that is on purpose because I want you to know these services so you can remember them for the exam. So let's get to it. The first is Anthos, so modernize existing apps, build web apps, build in hybrid and multi-cloud environments when enabling consistency between on-premise and cloud environments. Remember, Anthos allows you to extend your control plane to not only other other cloud service providers, but also on-premise. You can do compute and Kubernetes. You have Anthos deployed on VMware, so modernize existing apps and build new apps on your VM environments. They're never going to ask you to do a VMware deployed on, or Anthos deployed on VMware, but VMware can show up on the exam, so you should know what that is. Anthos GKE, so that's Google Kubernetes engine. So deploy, manage, and scale containerized applications on Kubernetes powered by Google Cloud. This is just showing you that Anthos handles Google Kubernetes environment. Anthos config management, automate policy and security at scale for your hybrid Kubernetes deployments. You have Cloud Run for Anthos, so easily leverage and the benefits of combining Kubernetes and serverless. Apigee API management, deploy, secure, and monitor APIs everywhere. Remember, you can use Apigee in hybrid or multi-cloud, okay? So that is one of its advantages. The Google Cloud Marketplace for Anthos, easily deploy containerized apps with features of pre-built deployment templates and consolidated billing. Migrate for Anthos. So if you're trying to move servers onto Google Cloud, this is going to be specifically for containers. I've seen this questions on the exam where you have to choose between migrate for Anthos and migrate for Compute Engine. And so if it's virtual machines, you're using Compute Engine. If it's containers, you're using migrate for Anthos, okay? There's operations, so aggregate metrics, logs, and events from your infrastructure to get signals and the speed of analysis. That's under Compute Engine. You have Traffic Director. This is a global load balancing across clusters and config sophisticated traffic control policies for open service mesh. What you really need to know is Anthos, because Anthos is what's going to show up on the exam, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at Internet of Things. So Internet of Things are physical objects embedded with sensors, software, and other technologies that stream data to cloud services or other edge devices. An edge device is a device that is an entry point to a service provider network. So Google has exactly one offering for IoTs, and that's IoT Core. securely connect and manage IoT devices using a fully managed service. If you're wondering what kind of things would be IoTs, maybe you'd have something like a smart plant health sensor, video security. This is the Ring device by Amazon, where it will, when people press the button, it will record. You have conversational AI, so home assistant, like Alexa, Google Home, temperature control with Nest. There's these IoT kits. This is the AWS one, but Core 2 is pretty much a standard one for IoT kits to start learning how to use IoT. And of course, drones. So there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at Cloud Deployment Manager. So to understand this, we need to know what infrastructure as code is. So IAC is the process of managing and provisioning cloud services through machine-readable definition files, so YAML or JSON files, rather than manual configuration. When you want to have governance in your cloud, you want to use IAC because it means that it will exactly define what there is, and that is a really great way to keep track of exact configuration, okay? So for Google's, it's called Cloud Deployment Manager. So that is their IAC service. You write them as YAML files, and you deploy them via the Cloud CLI. I was a bit surprised to see that they didn't have like an upload, and so I was a bit confused as to how they go do this. If you search for IAC for Google Cloud, you'll see Terraform a lot, which is a third-party provider. For some reason, they just kind of like bury their own IAC solution, but it does exist. And I don't believe there's a JSON format, just the YAML files. But there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at the Operations Suite, which is just a collection of operation or monitoring services for Google Cloud. So allows you to monitor, log, trace, and profile your apps and services. So the main one here is Cloud Monitoring. It provides visibility into the performance, availability, and overall health of the cloud-powered applications. You got service level monitoring, so define and measure availability, performance, and other service levels for cloud-powered applications. For cloud logging and error reporting, you have cloud logging, so store, search, analyze, monitor, and alert on log data and events from Google Cloud and AWS. Error reporting, identify and understand application errors. Then you have APM, so you have cloud trace, find performance bottlenecks in production, cloud debugger, investigate code behavior in production, and cloud profiler, so continuously gather performance information using low-impact CPUs and heap profiling services. Is this stuff going to show up in the exam? Probably not. You should just know cloud monitoring here, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at Firebase. So this is Google's fully managed platform for rapidly developing and deploying web and mobile apps. Really, it's a platform as a service utilizing serverless technology. Firebase offers the following services and features. So Cloud Firestore, machine learning, cloud functions, authentication, hosting, cloud storage, real-time database, Crash Linux, performance monitoring, test lab, app distribution, Google Analytics, in-app messaging, predictions, A/B testing, cloud messaging, remote config, dynamic links. So Firebase is basically an alternative to using Google Cloud directly for users who want to focus on building and deploying their applications in a highly opinionated framework. If you ever heard of AWS Amplify, that's the AWS competitor for this. The only thing that I find, like, this service is great, but I find that it's very hard to migrate off of Firebase onto Google Cloud. But the idea is that, if you don't really want to learn all the infrastructure as a service stuff, and you just want all this convenience around you, this thing is really great, okay? Dataflow is a unified stream and batch data processing that's serverless, fast, and cost-effective. So there's a screenshot of a flow right there. It can do stream analytics, so ingest, process, and analyze fluctuating volumes of real-time data for real-time business insights. It has real-time AI, so streaming events to Google Cloud's Vertex AI and TensorFlow extension, so TFX. It has many use cases like predictive analytics, fraud detection, real-time personalization, and anomaly detection. It's supported with CI/CD for ML through Kubeflow pipelines. It can do IoT streaming for sensor and log data processing. In terms of its other features, we have Dataflow SQL, so it allows you to use SQL directly in there. So that's really useful. It has flexible resource scheduling, so advanced scheduling techniques to reduce batch processing costs. Dataflow templates, so easily share your pipelines across your organization teams. It has Vertex AI notebook integration. which is really straightforward. You can get a private IP. It has horizontal scaling. It can work with Apache Beam. If you're not sure what Apache Beam is, it's an open source unified model for defining both batch and streaming data parallel processing pipelines. We have Dataflow Prime. So this is a serverless no-ops auto-tuning architecture. It also has vertical scaling. It has right fitting. So it's a very, very good service. This is why Google is known for ML and data, because they have some of the easiest and most robust data and ML services, Dataflow being one of them, okay? Google Cloud PubSub is a messaging service that lets different applications communicate by sending and receiving messages in real time. I always say application integration. That's more of a term over on AWS, but this does the exact same thing. It can support low latency messaging for real-time data pipelines, enabling fast event-driven workflows. It has publishers, which send events to a topic, and subscribers, which receive them asynchronously, very hard word to say, separating event creation from processing. It works with tools like Dataflow for streaming, BigQuery for analytics, and cloud storage for distribution. It's ideal for real-time apps, data, IoT streams, cache refreshing, load balancing, and database replication. There are two service options here. We have the standard, and then we have PubSub Lite, which is lower cost with manual capacity management and zonal storage. So it really depends on what your use case is here. In terms of a message lifecycle, you first have a publisher, which sends a message to the PubSub topic. I'm going to get my pen tool out here just to make it a lot more clear, but we have publisher here, and they're sending that message to the topic, right? Then the message is stored somewhere. So here it's in the message store. The PubSub delivers the message to all topics or topic subscriptions. Okay, so that is this step here. And so in this example, there's only one subscription, but there could be more, right? We could see multiple subscriptions here. The subscription forwards the message to a subscription application. So I'm going to assume it's here. Yep, right there. That's the app down below. That's the subscriber. The subscriber processes the message and sends an acknowledgement, which we call an ACK, to tell them that the message was received, and then PubSub will delete its storage. Very similar to other PubSub systems, like SQS on AWS or whatever the two. There's two different ones on Azure. Can't remember off the top of my head, but very similar kind of service. Okay. Hey, this is Andrew Brown from ExamPro, and we are looking at migration services for Google Cloud. The first on our list here is the database migration service, and this is when you're migrating open source relational databases into Cloud SQL. Didn't see this one in the exam, which is kind of a surprise because I think that would be kind of an essential one. It might show up in the future. Maybe I just didn't get any questions for that. We got BigQuery data transfer service. This is when you're importing data into BigQuery. Again, another one I did not see on the exam. Then we have Migrate for Compute Engine and Migrate for Anthos. These are two you want to remember when you want to import from your on-prem into or migrate on-prem into your Google Cloud. You're going to be using Compute Engine for VMs, and for Anthos, you're going to be using containers. You got to remember the difference between these two because they will show up in a lineup for sure. Another one, and this time it's for storage, not compute, but you have Cloud Storage Transfer Service. So this is when you're migrating just general storage like data. It could be from S3, it could be from on-prem. And then there's also Transfer Appliance. This is where you are transferring storage, but you have so much data, like terabytes of data, that you need a physical drive to ship the data. So these two, I'm giving you extra emphasis here, these two and these two are going to show up in a lineup on the exam for sure, so know the difference between them, okay? I have just a few key cloud migration terms that I didn't know where else to fit in slides. So this slide is really boring, but it's really straightforward that I wanted to get you exposure to before we start talking about all these migration types. So the first is workload. This is your apps, your services, or tasks that you can plan to migrate to the cloud. You have retire. This is where you're decommissioning workloads that are no longer needed or useful. And we have retain, so keeping workloads in the current environment, typically due to complexity or compliance reasons. So those are your three terms that you will see repeated when we're talking about different types of migration. I just wanted to get you some exposure there, okay? All right, let's take a look at the types of migrations. And so there are four main types of migrations from on-premise to the cloud. I want to point out that these terms, some are universal, but other ones are just made up by Google. And there used to be fewer, but now there's more. I'm not saying I necessarily agree with them, but I'm just saying that Google's created this language to help organizations to frame their migrations, to just understand that. But the idea is that they work on a spectrum, so the ones on the left are easier to implement with limited cloud benefits, and the ones to the right are labor intensive with full cloud benefits. And we have here rehost, so lift and shift, replatform, lift and optimize, refactor, move and improve, rebuild, rip and replace. So for rehost, you have little to no modification, taking the least advantage of the cloud. Fastest migration strategy for replatform, lift workloads with minor adjustments, leverage more cloud features with major changes, slower than rehost but gains more cloud benefits. For refactor, refactor your existing apps to smaller cloud native features, take advantage of the most offerings of cloud, slower migration process but offers better performance scalability. For rebuild, you're building your app from scratch, you're taking advantage of the maximum value of offerings, but this can take the largest amount of time or longest amount of time. So we'll look at these in more detail, but it's pretty straightforward what these are. But there you go. Let's take a look at rehost or lift and shift, as it's more commonly known everywhere else. But this will move workloads from a source environment to a target environment with minor or no modifications or refactoring. It's ideal when you have a workload that can operate as is in the target environment with little or no business needs for change. Your considerations here is it requires the least amount of time because the amount of refactoring is kept to a minimal. Teams can continue to use the same set of tools and skills that they were using before. It doesn't take full advantage of cloud platform features like horizontal scaling, fine-grained pricing, highly managed services. So, a rehost would be like, imagine you run everything on a VM, a virtual machine. You just run it on a Google Cloud VM. Just bring that on over. That would be an example of rehost, okay? Let's take a look at replatform. So replatform moves workloads to the cloud with minor optimizations for cloud benefits. This is ideal when the app can run in the cloud but needs slight optimizations. Small changes improve cloud performance or cost efficiency. Considerations here is it requires more effort than lift and shift. Optimizations might need code or configuration changes. Learning new cloud features or tools may be necessary. Maybe an example here would be, okay, we're going to leverage, let's say we're running everything on VMs, but now we're utilizing Cloud Spanner to replace the SQL component or things like that. So this is where you're making minor integrations of cloud services, okay? Let's take a look at refactor or move and improve. This is where you modify and modernize the workload while migrating to take advantage of cloud native capabilities. This is ideal when the current app architecture isn't cloud ready. Major updates or improvement are needed for performance. Considerations here, it takes more time than basic migration, requires refactoring the code during migration, demands extra effort and new skills for optimizing the cloud. So if you're used to just kind of taking a VM and vertically scaling it, maybe you want to make sure that your app can do horizontal scaling. And so the way you handle sessions could be different. This could be using more heavier integrations for cloud. So maybe your background jobs, you're moving them into cloud functions, or you're changing the way your code is written so that maybe if you're using containers and there's layers that are abstracted away on Google Cloud Run, that you just remove those layers. All sorts of things you can do here, but the idea is not 100% from scratch, okay? Let's talk about rebuild or remove and replace, sometimes called rip and replace. This is where we decommission an existing app and we completely redesign it and rewrite it so it's a cloud native application, or we can say cloud first. If we're over on AWS, we call it a cloud first application. This is ideal when the current app isn't meeting your goals. You want to remove legacy technical debt. But everybody knows that debt just never goes away. You just create new debt. So you're just trading one kind of debt for another, but that's totally fine. Here it requires the most amount of time to develop, requires the most amount of learning, but you can maximize the most that you can get from cloud. So maybe one solution would be like, maybe you're going to utilize Firebase, like the whole Firebase ecosystem, and leverage it there, or make it 100% serverless and use Cloud Functions and Google Cloud Run. So yeah, there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at migration path. And the reason I want to go through this stuff is not because they're going to ask questions on the exam, but it's going to help you contextualize a lot of the business use case scenarios, because, you know, this isn't like a normal fundamental certification. They just make it a lot harder. So you need that contextual knowledge, okay? So there are 4 phases of your migration. There's assess, plan, deploy, and optimize. This is going to be text heavy, but we'll work our way through it and you'll leave with some knowledge, okay? So for assess, perform a thorough assessment and discovery of your existing environment in order to understand your app and environment inventory, identify app dependencies and requirements, perform total cost of ownership calculations, and establish app benchmarks. We got plans to create the basic cloud infrastructure for your workloads to live in and plan how you will move apps. This planning includes identity management, organization, project structure, networking, sorting your apps, and developing a prioritized migration strategy. We got deploy, so design and execute a deployment process to move your workloads to Google Cloud. You might also have to refine your cloud infrastructure to deal with the needs. Optimize, begin to take advantage of cloud native technologies and capabilities to expand your business potential to things such as performance, scalability, disaster recovery, cost, training, as well as opening the doors to machine learning, AI integrations for your app. So we'll spend more time right now into each of these 4 phases just to kind of cement this knowledge, okay? Phase 1 is the assessment phase. You gather information about the workloads you want to migrate and their current runtime environment. So you're going to take an inventory, build a list of your machines, hardware specifications, operating systems, and licenses. You'll have catalog apps, so build a catalog matrix to help you organize apps into categories based on the complexity and risk in moving to Google Cloud. I don't think we show it in here, but the idea is if you want to see it, they have an example in the Google Cloud documentation. Educate your organization about Google Cloud. So train and certify your software and network engineers on how the cloud works and what Google Cloud products use. Maybe you could use this course to do that. Experiment and design proof of concepts. So choose a POC and implement it. Calculate the total cost of ownership, TCO. So compare your costs on Google Cloud with the costs you have today. Use the Google calculator. Choose which workloads to migrate first. So identify apps with features that make them likely to be first movers. All right. And starting with a less complex app lowers your initial risk because later you can apply your team's new knowledge to harder migration apps. Phase 2. So in the plan phase, you provision and configure the cloud infrastructure and services that will support your workloads on Google Cloud. So establish user and service identities. So for Google accounts, an account that usually belongs to an individual user that interacts with Google Cloud. Service accounts, an account that usually belongs to an app or a service rather than a user. Google Groups, a named collection of Google accounts. Google Workspace Domains, a virtual group of all the group accounts that have been created in your organization group workspace accounts. It's good to know what all these things are because, you know, there is overlap in the course for these, okay? Cloud identity domains. These domains are like Google Workspaces, but they don't have access to Google Workspace applications. This is when you just need, and we covered cloud identity, but this is just when you need access to Google Cloud, but not to, the G65 suite or the G Suite, okay? So design your resource organization. So organize your resources using the Google resource hierarchy. Organizations are the root of a resource hierarchy and represent a real organization such as a company. Folders are an additional layer of isolation between projects that can be seen as sub-organizations. Projects are base-level organization entities and must be used to access other Google Cloud resources. Hierarchy architectures, we have environment-oriented, function-oriented, granular access-oriented. We cover these in its own section, because that's how important it is. This one, super, super important for this course, is understanding this stuff. You'll see exam questions around resource hierarchies, okay? Define groups and roles for resource access. So set up groups and roles to grant the necessary access to resources. Design your network topology and establish connectivity. So set up the network topology and connectivity from your existing environment to Google Cloud. This could be via Cloud VPN, peering, so VPC peering, Cloud Interconnect, okay? And those three, well, at least the two, Cloud VPN and Cloud Interconnect, are going to show up on the exam for phase 3. This is the deploy phase. Implement a deployment process and refine it during the migration. So you have fully manual deploys. Lets you quickly experiment with the platform and tools, but it is error-prone and often not documented and repeatable. Configuration management tools, abbreviated to CM. So configure an environment in an automated, repeatable, controlled way. Run remote commands on VMs that check the state and remediate of an instance to the desired configuration state. You have container orchestration, so consider using Kubernetes so you don't have to worry about the underlying infrastructure and the deployment logic. So you could use Google Kubernetes Engine for that. Deployment automation, so automate the deployment process by implementing continuous integration and continuous delivery pipeline. You have infrastructure as code. Write a script that defines resources to be created or updated in a single deployment action. Share and stand up entire workflows and environments easily. IC tools here is Google Deployment Manager or HashiCorp Terraform. And Terraform is just, it's an IAC, but it works across all cloud service providers. And it's really important to know all these different type of deploy types at the fundamental levels. It can really help you on the exam, okay? Phase 4, the optimize phase. Start optimizing your target environment. So build and train your team, train your development and operations team to take full advantage of new cloud environments. Monitor everything. Monitoring is the key to ensure that everything in your environment is working as expected. Prometheus, Google Cloud Logging, Google Cloud Monitoring. Automate everything. So manual operations are exposed to a high error risk and are also time consuming. Automation leads to cost and time savings and reduces risk. So we're looking at Google Cloud Composer, which is using Apache Airflow, SpinMaker. They're not going to ask those on the exam. Codify everything. So by implementing processes such as infrastructure as code, policy as code, make environments fully auditable and repeatable. Use managed services instead of self-managed ones. Cloud SQL, AutoML, GKE, App Engine. Optimize for performance and scalability, so horizontal scaling, vertical scaling, and you want to reduce the cost, so take advantage of sustained use discounts, SUDs, committed use contracts, which sometimes are committed use discounts, so CUD, so don't get too hung up on the word contract there. Flat rate pricing, such as BigQuery, which I think is the only service that does that kind of flat rate pricing, okay? So there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at Migrate for Compute Engine, and it enables you to migrate lift and shift of your virtual machines with minor automatic modifications from your source environment to the Google Compute Engine. The reason we're giving this a little bit more detail is because on the exam, I just saw some more questions that are kind of around the feature set of Compute Engine. And so I just didn't want you to get tripped up on the exam, okay? So continuously replicates disk data from the source to VMs to Google Cloud. No downtime on the source via transfer. Quickly clone and test a migrated VM. So after it's migrated, you can use test clones and make sure everything's working fine. If not, you can roll back. I'm highlighting this one in particular because I saw it on the exam. Easily perform all migration tasks with Google Cloud Console. So just understand there's no downtime with this thing. It continuously replicates and you can use test clones, all right? Hey, this is Andrew Brown from ExamPro, and we are looking at Anthos for Google Cloud. And I know I've mentioned Anthos so many times, but it is in the exam, so that's why I want to show it to you from different angles. So Anthos is a modern application management platform used for managing hybrid architectures that span from Google Cloud to other AWS or on-premise data centers running VMware. Anthos is a single control plane to manage Kubernetes compute in hybrid scenarios. Core components of Anthos would be infrastructure, containers, cluster management. It has a managed service mesh. This is great for seeing where your resources are and trying to be able to define SLOs, service level objects, to give guarantees to your customers. Multi-cluster management, configuration management, migration, service management. It's serverless, secure software supply chain, logging, monitoring, and it has a marketplace. So it is a pretty darn robust system. If you're building service-based architecture applications, Anthos is a great enabler for this with microservices. But there you go. Hey, this is Andrew Brown from ExamPro, and we're looking at Migrate for Anthos and Google Kubernetes Engine. Normally it'll just be Migrate for Anthos, but we just extend it with the full name here so you understand what the utility of Anthos is, which is for migration of containers to GKE. So when Migrate for Anthos, you can migrate your VMs from your supported source platforms to Google Kubernetes Engine, Anthos clusters on VMware, Anthos clusters on AWS. So you can bring them in from a lot of different places. You use auto-generated container artifacts, including container images, Docker files, deployment YAMLs, and persistent data volumes to deploy migrated workloads and integrate with services such as Anthos Service Mesh, Anthos Configuration Management, Stackdriver, Cloud Build for maintenance using CI/CD pipelines. Migrate for Anthos is offered at no charge, and no Anthos subscription is required when migrating to GKE. Charges for other GCP services may still apply, okay? So the big takeaway is that you use this for migrating containers to GKE, and there's no cost to doing that, and you don't need a subscription, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at Storage Transfer Service, which allows you to quickly import online data into cloud storage, set up a repeating schedule for transferring data as well as transfer data within cloud storage from one bucket to another. It's going to enable you to move or back up data to a cloud storage bucket, either from other cloud storage providers or from your on-premise storage, move data from one cloud storage bucket to another so that it is available to different groups of users and applications, periodically move data as part of data processing pipeline or analytical workflow. You can schedule one-time transfer operations or recurring transfer operations, delete existing objects in the destination bucket if they don't have a corresponding object in the source, delete data source objects after transferring them, schedule periodic synchronization from a data source to data sync with advanced filters based on file creation dates, file names, and the times of day you prefer to import data. So what I want you to understand here is that you can use it for cross-region replication. So because you can move it on a schedule from bucket to bucket, that you can get data from other cloud storage providers like AWS, or you can get it from on-premise, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at Transfer Appliance, and this is a hardware appliance you can use to securely migrate large volumes of data, so migrate hundreds of terabytes up to 1 petabyte. Comes in two configurations, so 100 terabytes and 80 terabytes. Imagine when they say a petabyte, you just have multiples of these drives that you would ship. So the one on the left here would be the 480 terabyte. The one on the right is the 100 terabyte. You can mount Transfer Appliance as an NFS volume, making it easy to drag and drop files or rsync from your current NAS to the appliance. When you want to use Transfer Appliance, your data has to be greater than 10 terabytes. That's generally when you want to do it. Or it would take more than a week to upload your data over the network. You'll want to remember these last two. They will absolutely help you on the exam. For just features in general, they're tamper resistant, so they cannot be easily opened. Apply tamper evident tags to the shipping case. They're ruggedized. That means like they have like an exterior case that makes them so they're not damaged, you know. Trusted Platform Module, TPM chip is installed on these, so they're a mutable root file system and software components that haven't been tampered with. It has hardware attestation, so they validate the appliance before you can connect it to your device and copy data to it. For other features when you're in transit, it has AES 256 encryption, customer managed encryption keys, NIST 888 compliant data erasure. Okay. For performance features, all drives are SSD, so there's no moving parts. It's very fast IOPS. Multiple network connectivity options here. We got 10 gigabytes per second, 40 gigabytes per second. It's scalability with multiple appliances, so use multiple appliances to increase the transfer speed. That's where I imagine you get up to a petabyte of data. Globally distributed processing, so ships quickly to and from the data center to Google Cloud. Minimal software, so use common software already on your Linux or Mac or Windows system, okay? All right, let's talk about what is AI. So AI, which stands for artificial intelligence, is when a machine performs jobs that mimics human behavior When we're talking about machine learning, this is machines that get better at tasks without explicit programming. When we're talking about deep learning, we're talking about machines that have artificial neural networks inspired by the human brain to solve complex problems. When we talk about Gen AI, which is not shown here as it is a slice or subsection. I'm trying to draw here. I'm not sure why. Every time I try to draw on this one, it just fails or it's delayed. But it is there. It is. It is a specialized subset of AI that generates out images, videos, text, and audio. And so what you have to remember is these layers because AI uses machine learning, and machine learning can be deep learning. But the key difference between ML and DL is that deep learning is utilizing neural networks. So hopefully that is really clear. And if it's not, what we can do is do a comparison between AI versus machine learning. So AI focuses on understanding and decision making, whereas machine learning learns from data to predict or make predictions or decisions. For data handling, AI analyzes and makes decisions based on existing data. ML uses data to train models and make predictions. AI applications span across multiple various sectors, including data analysis, automation, natural language processing, and healthcare. And machine learning is used in recommendation systems, fraud detection, and predictive analysis. Then we can go further and we can compare AI ML to data analytics and BI tools. So when we're talking about functionality for AI ML, this is where we use models to predict outcomes and automate decision making. Whereas with data analytics and BI, you analyze historical data for insights. For data handling on the AI ML side, it learns from large data sets to make predictions and automate tasks. For the data side, it processes and visualizes existing data to find patterns. For apps, for the ML side, it's used in automation, predictive analytics, personalization, innovation. On the data side, it's used in reporting, dashboards, decision making based on past trends. For outcomes, on the ML side, it creates automated processes and continuous learning from data. And on the data side, it provides descriptive and diagnostic insights for decision making. That was really hard to say, but hopefully that gives you kind of a clear picture between the layers of AI and also AI ML versus the data side of things. But obviously they play really well together, so we'll see them interconnected, but they are two separate things. Let's talk about supervised versus unsupervised versus reinforcement learning, because when we're learning about machine learning, we need to know about these three types. The first being supervised learning. This is where data that has been labeled for training, and supervised learning is often described as being task-driven because it makes a prediction. So when the labels are known and you want a precise outcome, when you need a specific value returned, this is when you're trying to do things like classification or regression. We'll talk about those here shortly in the next slide. We have unsupervised learning. This is data that has been labeled. The ML model needs to do its own labeling. And this is where we're trying to make data-driven decisions. It recognizes a structure or a pattern. When the labels are not known and the outcome does not need to be precise, when you're trying to make sense of data, and this is where we're doing clustering, dimensionality reduction, and association. Then we have reinforcement learning. This is where there is no data, there's an environment, and the ML model generates data from many attempts to reach a goal. So here, this is decision-driven. Think of game AI. Imagine Mario, like an AI trying to learn how to play Mario, or ML trying to learn to play Mario. Learning tasks, robot navigation, things like that. But let's go a little bit deeper here and talk about supervised learning models. And let's define what is classification. So classification is a process of finding a function to divide a data set into classes and categories. So an example here would be, will it be hot or cold tomorrow? And so classification algorithms here could be logistic regression, k-nearest neighbor, that's one that comes up a lot. Support vector machines, also known as SVMs, kernel SVMs, naive Bayes, decision tree classification, random forest classification. You don't have to remember all those types of algorithms. I'm just giving you exposure. What you need to remember is classification is useful when you're trying to divide a data set into more values. And look at that graph on the left-hand side. Notice the line, and notice it's dividing one side to the other. So here, one side is hot, one side is cold. What is regression? Regression is a process of finding a function to correlate a data set into continuous variable and number. So an example would be, what is the temperature going to be tomorrow? We're trying to predict a value along that line. So, if this line keeps extending and then we have a dot here, then we can determine what that value is based on the trajectory of that line. So for regression algorithms, we have simple linear regression, multiple linear regression, polynomial regression, support vector regression, decision tree regression, random forest regression. Let's talk about unsupervised learning models. Let's just get it all out of the way here. Let's talk about clustering. So clustering is a process of grouping unlabeled data based on similarities and differences. So as you can see on the left-hand side, they're clustering things based on age. Clustering algorithms here could be k-means, db-scan, k-modes. What is association? Association is the process of finding a relationship between variables through association. So maybe there's a combination, like if you have bread and butter, right? If someone buys bread, then you suggest butter, right? So here we have a priori, I never can say that properly, a bunch of words I cannot say, so I'm not going to even try to say those algorithms, but there are a few here that we can utilize. We have dimensionality reduction. This is the process of reducing the amount of data while retaining data integrity, often used as a pre-processing stage. And we have algorithms for that as well as PCA, LDA, GDA, SVD, and then LDA. But notice that one is latent. It's a different one, even though it has the same initialism. And then we have more, and we have more. There's tons for dimensionality reduction, but hopefully that gives you an idea of learning models when we're talking about ML, and it's clear the difference between supervised, unsupervised, and reinforcement learning. So there you go, okay? Let's take a look here at what an algorithm and function is. So what is an algorithm? It is a set of mathematical or computer instructions to perform a specific task. An algorithm can be composed of several smaller algorithms. So, the thing that you want to remember about an algorithm is how do you do something, okay? So an example of an algorithm would be k nearest neighbor. It's worth bringing this one up because you'll see k and n quite often. And it can be used to create a supervised classification machine. And so the way this algorithm works is it will say, tell me who are my closest neighbors, and we will infer that I be considered of the same class. So here we have the red diamond, and we're looking around and saying, okay, these are my neighbors, so therefore I must be similar to them. With k and n, you use different distance metrics. So these are the different kinds of algorithms that we can utilize within k and n. So we're talking about a algorithm composed of smaller algorithms. And so here's an example of one, which is the Minkowski algorithm. They have a bunch of names that are always very hard to say. I assume it's named after the people that invented these algorithms. Let's talk about what is a function. So a function is a way of grouping algorithms together so you can call them to compute a result. So it kind of sounds like a machine learning model in a sense. Obviously, a function is something that's also very well defined in computer programming when you're using programming, but understand that it is a multi-purpose term. So KNN itself is not a machine learning model, but when applied to solve, or I should say machine learning algorithm, but when applied to solve machine learning problems, then it makes it a machine learning algorithm, okay? So it's the context to which it is used in that makes it an algorithm. Because I remember looking at these and going, how are these machine learning algorithms? And it's really just based on context, okay? Let's talk about what a machine learning model is, but let's first define what a model is in general terms. So a model is an informative representation of an object, person, or system. So a model could literally be a person posing for a painting, but then there's this abstract idea of models. And so this is where we have things like algorithms, mathematical, computer code, written word stuff. That's what we're talking about when we're talking about machine learning models. And so an ML model is a function that takes in data, performs an ML algorithm to produce a prediction. And so an ML model is trained, not to be confused with the training model, which is learning to make correct predictions. An ML model can be the training model that is just deployed once it has been tuned to make good predictions. I think I have a bit of a word mishap there. Once it has, let's stick that word out there, it has been tuned to make good predictions. So let's kind of have a visual so we understand. So we have our training data. This is our labeled data. And then you have the training model, which is a learning algorithm. And then you're going to continuously pass information and tweak the model. That's called hypertuning. And then once we have trained our model, we get our trained model that we can then run predictions through with unlabeled data. And when we are trying to make a prediction, it's called inference, because we're saying we want to infer what this could be, and then we get out a prediction. So hopefully that makes sense. Let us take a look here at what is a feature. So a feature is a characteristic extracted from our unstructured data set that has been prepared to be ingested by our ML model to infer a prediction. So ML models generally only accept numerical data, and so we prepare our data into machine readable format by encoding, and so we'll revisit this encoding later in detail. But what is feature engineering? So feature engineering is the process of extracting features from our provided data sources. So imagine you have multiple data sources and you turn that into raw data. You're going to need to clean and transform that data into features, and those features are what is fed into the machine learning model. So there you go. Let's take a look at what is inference. So inference is the act of requesting and getting a prediction. Inference relating to ML is when you input data into a machine learning model that has been deployed for production use to output a prediction. So imagine we have a banana and we ask the machine learning model, what is this thing? And it's going to output yellow banana with a confidence score of 0.9%. Okay, so this is us inferring, right? So this part here, I'm going to get my pen tool out. This part here is the inference, okay? So the textbook definition of inference is steps in reasoning moving from premise to logical consequence. So you kind of get an idea how that makes sense there, okay? So what is training? Training is the process of teaching a machine learning model to recognize patterns by feeding it data so it can make predictions or decisions based on new and unseen data. And so that could be unlabeled data or labeled data. It depends on the type of learning that you're doing, whether it's supervised, unsupervised, reinforcement learning. But the thing is that you don't want to overtrain or undertrain your model. If you undertrain your model, it's not going to make good predictions. If you overtrain your model, like it's fit too much to your data set, then it's not going to have enough intelligence to make predictions outside of that data set. It's always going to be very biased and return very canned answers back to you. That's not going to be useful either. So you want something in between. So that's what well-trained data looks like. So there you go. Let's take a look at what are parameters and hyperparameters. So what is a model parameter is what we'll first ask. So a variable that configures the internal state of a model and whose values can be estimated. The value of the parameter is not manually set and will be learned, outputted after training. So parameters are used to make predictions. Now let's talk about what is a model hyperparameter. This is a variable that is external to the model and whose value cannot be estimated. The value of the hyperparameter is manually set before the training of the model. Hyperparameters are used to estimate the model's parameters. So things like learning rate, epochs, backside. Epochs is something you'll see very often. And if we're looking at a visual here, we should have showed this up a lot sooner, right? But this over here is the hyperparameter, and over here, this is the internal state, the connections between them. Okay, so hopefully that is clear. Hey, this is Andrew Brown from ExamPro, and we're looking at AI and ML services, and the most important one here is Vertex AI. So this is Google Cloud's unified ML platform for building ML solutions end-to-end. And so a lot of the stuff you're going to be doing when it's ML or deep learning is going to be with Vertex, okay? So let's just kind of define what a ML pipeline looks like. So we have data readiness, feature engineering, training, hyperparameter tuning, model serving, understanding, edge. So that would be like deploying to the edge, like on mobile devices, model monitoring, and model management. And so we're just going to break it down here into 3 sections. And so before we get into the actual functionality of machine learning services, we need some way to actually run these models. So there's specialized or train or run or infer, but they have specialized virtual machines and containers. So that's part of the deep learning environment. These will be compute that already has pre-installed on them like Python and TensorFlow, and they might be optimized for GPUs, things like that. Now that we have our compute, we need an actual environment to build these in. And the golden standard across the board for no matter what platform you're on is Jupyter notebooks. And every single platform, just like GCP, they'll just call them like Vertex notebooks, but really they're Jupyter notebooks, okay? So now that we have an environment or a developer environment we can work on and we have our compute, let's talk about the services throughout this pipeline. So starting on the left-hand side, we have data labeling. This is a service that the idea is that if you want to train a supervised machine learning model, it needs to have labeled data because it's going to use that to learn. So the idea is that you can input data and then get people to help you label it, okay? You have data sets. That is just a curation of your data that's going to be ingested into the pipeline or into the ML model or prepared for feature engineering. Feature store is you extracting out key data and making it machine readable for the ML model. You have experiments. This is when you are trying different iterations of the ML model. So you need to remember like parameters and configurations and the history about them. You have AI accelerators. This is just, I think this is fractional. This is fractional GPU. So the idea is that if you have a virtual machine and the GPUs are too expensive, you can just have fractional GPUs. Visor optimization. This is a closed source service that does optimizations on your models. I imagine it's for hyper tuning. So we have training. So that's where you are just training your model. So you use like a container or a virtual machine to do that. Then there's actually the prediction. So that's you doing inference. Explainable AI. So the idea is there's this big concern about the ethics or responsibility of AI. And so if you can see how it works, then you can detect for bias or other unfair things. We have hybrid AI. So I imagine that is just being able to take a model and deploy it on a phone or low-end devices, like on the edge, closer to the people. For model monitoring, we have continuous monitoring. You want to watch for things like drift or degradation, because if you have a machine learning model, it can get worse at predictions over time. I know that sounds very unusual, but it's something that can happen. So you want to watch out for that kind of stuff. And for model management, we can collect a bunch of metadata. And I imagine that would be just for like we'd have a model catalog, like a place to store our models for easier deployment. And then we want to automate this entire thing. So we have pipelines. This is called ML Ops. It's the automation of the end-to-end pipeline for building, training, inferring, deploying a model. Then we have Auto ML. And so this is basically automates a bunch of this away. It's kind of like your platform as a service for machine learning. So this can do it for vision, for video, for language, for translation, for tables. The idea is you just upload your data, and then it pretty much does the rest for you. It will actually run a bunch of experiments, and you'll just choose which is the best one. So it really makes it easy if you don't know what you're doing, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at TensorFlow. So TensorFlow is a low-level deep learning machine learning framework created by the Google Brain team. And TensorFlow is written in Python, C++, CUDA, And there are APIs to allow you to use various other languages. And so TensorFlow is all based around this idea of a tensor. So a tensor is a multi-dimensional array. And so they call it ts.tensor in their stuff. And it's similar to a NumPy ND array of objects. And so tf.tensors can reside in accelerator memory like a GPU. So they're basically a new type of data structure that's just very specialized for machine learning. And Google actually has created their own hardware called a tensor processing unit, specifically optimized for TensorFlow and the tensor data structure. The way you write TensorFlow is in Python. An example of an ML model in TensorFlow is here on the left-hand side. Technically, this is Keras. Keras is a high-level abstraction of TensorFlow. And so it can get a bit confusing initially, the difference between Keras and TensorFlow, but they're essentially the same thing because Keras is packaged with TensorFlow. For the Google Cloud Platform, they specifically offered TensorFlow Enterprise, so they accelerate and scale ML workloads on the cloud with compatibility tested and optimized TensorFlow, along with enterprise-ready services and support, okay? Hey, this is Andrew Brown from ExamPro, and we are talking about Vertex AI again. And the reason why is I just want you to understand the history of it, like how it came about, to avoid some confusion in the Google Cloud Console. So Vertex AI is the unification of AI platform and the addition of AutoML to offer an end-to-end solution for all your custom ML and DL needs. So AI platform is technically deprecated. You can still use it, but it's not recommended to use the platform. They're always suggesting you to migrate over to Vertex AI. But the idea here is you would be able to prepare supervised training with data labeling, notebooks to write and document building ML models, a model registry to hold all your trained models, pipelines for setting up automated CI/CD to rapidly deploy new changes, also known as MLOps. And the other component to Vertex AI is AutoML, so easily trained, high-quality custom ML models. You just upload your data, choose what you want to predict, and it does the rest, okay? And actually I had a bit of a hard time finding this service. I was typing like AutoML, but really there's a thing in there which is called tables. And so you could build and deploy machine learning models on structured data. So you just you'd upload or actually be through data sets. So you'd upload a data set, and from there you say, okay, I want to analyze this tabular data, okay, through AutoML. Hey, this is Andrew Brown from ExamPro, and we are looking at ML and DL environments. So we're talking about the compute and the notebooks, okay? So to predict, train, tune, predict for machine learning models, you need to use compute optimized and specialized for ML and DL tasks. So an ML compute solution will be pre-packaged with specific ML frameworks, data science libraries, and you'll have to make the choice between a CPU or utilizing GPUs. CPUs are great for classical machine learning, so supervised, unsupervised learning, things that are math-based, like or statistics-based algorithms. GPUs are really well suited for deep learning. They're very powerful, but they're also really, really expensive. So you got to really decide whether you really want to use GPUs or not. You have deep learning images and you have deep learning containers. So here I'm launching up a notebook instance. So a notebook instance has to utilize some kind of compute. And so I believe this is a VM here that we're launching. And it has TensorFlow Enterprise as the prepackaged ML framework. It probably has data science libraries along with it. And here it is using GPUs. So we have NVIDIA Tesla T4. And of course, there's CPUs alongside GPUs, but you don't just use the GPUs on their own. There's also cloud GPUs. So this adds GPUs to your workloads for machine learning, scientific computing, and 3D visualization. Why do you need this? Well, this is fractional GPUs because GPUs are so expensive. Sometimes people just need a little bit of GPUs, and that's where this service kind of fulfills that cost-effective gap. For notebooks, it's a web-based application for authoring documents that combine live code, narrative text, equations, visualizations. A notebook makes it easy to code all the steps to an ML solution while intermixing documentation. It makes it easy to rerun segments of code for a fast and iterative developer experience. Vertex AI notebooks are powered by Jupyter Labs IDE. So Jupyter is the industry standard for interactive notebooks for building ML models or for data analysis. If you're already in the data sphere, you know what this is. If you don't, you should go out there and learn it. It's very useful. So that is the IDE, and then this is the Jupyter notebook, okay? So yeah, there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at the AI services offering for Google Cloud Platform. So AI is when machines mimic human behavior or can perform human tasks, and AI leverages ML and DL, and generally AI refers to fully managed ML SaaS offerings. I don't know why Google decided to call Vertex AI with AI in it, because it's really just for ML and deep learning. Anytime we just say AI, people just think fully managed services, okay? But these are the fully managed services that Google offers. They're not part of Vertex AI, so they're just outside of it. But let's take a look here. So we have Vision AI. It derives insights from images, text, and more, and custom or pre-trained models. Video AI enabled powerful content discovery, engaging video experiences. Natural language API, so derive insights from unstructured text. Recommendations AI, so provide a catalog of records, will suggest recommendations to users. Translation, so dynamically translate between languages. Document AI, natural language processing to train and simulate human review of documents. Talent solution, the capability to create, update, read, update, delete job postings. This one is such an oddball. I think I looked at it before, but I don't fully understand it. For the exam, they might give you a lineup of vision or video AI. Okay, so if you know what these generally do, it's not really that hard to figure out here. So we don't have to go very deep on these AI services, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at conversational AI, and this is technology that can participate in conversations with humans, so chatbots, voice assistants, interactive voice recognition systems, so IVRS. Use cases here would be online customer support, accessibility, HR processes, healthcare, Internet of Things, computer software. Mostly we're seeing it as the first one there, online customer support. Google has really good conversational AI, and they have a few different offerings here. So we have Agent Assist, empower human agents with continuous support during calls by identifying intent and providing real-time and step-by-step assistance. You got Dialogue Flow, so build engaging voice and text-based conversational interfaces. And they have more than one offering here. So they have Dialogue CX, so provides an advanced agent type suitable for large or very large agents. Dialogflow ES, so provides the standard agent type suitable for small and simple agents. Just some auxiliary services here. We have text-to-speech, so convert text to natural sounding speech using ML, and speech-to-text, so convert speech to text using power of ML. I suppose the last two there should have been in our AI service lineup, but we got through it. Will you see this stuff on the exam? Probably not, but you should know it because it's one of Google's greatest strengths, and I'm really surprised they didn't have it in the exam. Let's take a look at BigQuery ML, which lets you build machine learning models directly in BigQuery using SQL, making ML accessible to data analysts without coding expertise, which is really cool. Types of models that BigQuery ML can create are linear regressions, logical regressions, k-means clusterings, time series forecasting, deep neural networks, matrix factorization, principal component analysis, and more. These models can be integrated with Google Cloud's Vertex AI for further customization and optimization. Other features include that it has a user-friendly interface powered by SQL to build models without Python or Java, so really useful for data folks. ML models are created with BigQuery, avoiding the need for data movement. It has access to the Google Cloud Console, BigQuery API, and more. You can manage deploy BigQuery ML models with Vertex AI. It offers built-in models, as we saw a moment ago. Import models from Onyx, TensorFlow, and others for prediction. Onyx is a really, really useful framework. But here's an example of an integration that we can utilize to bring data in here. But yeah, let's just talk about the workflow now. So the idea is that you might have streaming or batch data, and you're bringing that into your data warehouse, which is BigQuery in this case. Then we move on to data processing. We export that data. We train that model. So here we're using Python or R. We deploy the ML model, and this is kind of the entire workflow. But again, you don't need to know much about the code, but if you're using Vertex AI, I believe that you'll have more customization over there. There's some terms we might want to know. So we have data governance. So how do you control and secure your data? How are you going to, or who's going to handle the infrastructure? Where do you run the model? Okay, and this is all solved with BigQuery or BigQuery ML because it has built-in governance. It has automatic resource handling. It simplifies deployment. So there you go. All right, let's talk about responsible AI and explainable AI. So responsible AI is a set of broad guidelines to ensure AI is used responsibly. And Google has their own. Every provider has their own. And so, I can just click through these really quickly because they're not that exciting, but, be socially beneficial, avoid creating or reinforcing unfair bias, be built and tested for safety, be accountable to people, incorporate privacy design principles, uphold high standards of scientific excellence, be made available for ethical use. So they all are kind of the same, but they're all kind of different. And Google has the PDF that you can download that describes this in greater detail. We'll look at that in a moment. But the other thing that we want to know is about what is explainable AI. So the thing with these models is that we can't truly fully understand exactly how they work, but there are ways that we can analyze and reason as to how the models are making decisions. So it's not 100% explainable, but the idea is that we have a better idea of how data or other things are influencing the output. And so this ties back to responsibility because, if we want a model to be unfair, we need to prove that it's not being unfair. And so that's where explainable AI comes into play. Specific providers are using very specific open source tooling to do this. I believe that Google has something called Vertex Explainable AI. And so it's built in there. I'm not exactly how we would show that. But the idea is that responsible AI is very straightforward. Explainable AI, very straightforward. But let's take a closer look at that AI principle PDF, okay? All right, so I just looked up responsible AI, and there's two websites. We have Google AI, so AI.Google, and then Google Cloud. So their scope might be a little bit different, or they might be the same. But if we go here, we can scroll on down, and we can see the AI principles over here. It also has explainable AI, model cards. Let's take a look at this. So here's our principles. So those are the things that we saw in the slide earlier, which you can read a lot more about. You can also download a PDF of this. So we'll take a look and see if that actually has more information or if it's just the same stuff. Yeah, it's the same stuff. So nothing super exciting, very straightforward. But we'll close this one out. Let's take a look here at Vertex Explainable AI. And so they're just saying things like, Vertex Explainable AI offers feature-based and example-based explanations to provide key understandings. Okay. Vertex AI uses nearest neighbor, so we learned about KNN, that specific algorithm, to search to return a list of examples. So yeah, we'd have to read through a bunch of stuff, but there are really specific models out there for understanding responsible AI. And, I'm not exactly seeing that here. Like, we're seeing some patterns that it's applying. But normally what I'm looking for is something like, let's just say explainable AI open source. And so, I'm not really seeing it here. SHAP. SHAP is, I think, what AWS uses. GitHub. Right? And so this would be an example of trying to explain models. So I'm not exactly sure what Google uses. Again, I didn't find it. But also, let's take a look at model cards. So model cards will definitely tell you how a model will work. Normally, we're talking about large language models, and actually they have them here. These are large language models right here. We open them up. They'll tell us a bunch about them, like how the model works, the data processing, the benchmarks it ran against. And so in this sense, this kind of provides explainable AI to a degree, but it's not the same thing as what SHAP would do, which is actually running evaluations against the model to determine how fair it's being. But this is descriptive of the model, and so you could say that is also part of explainable AI. So hopefully that is pretty clear. Nothing super exciting here, but yeah, there you go. Let's take a look at what we should consider when selecting Google Cloud AI ML solutions. I don't personally like this slide, but it's part of the curriculum, so I'm just going to list it out here just in case to cover our bases. So when we're considering Google Cloud AI ML solutions, we should consider speed. So how fast do you need the model in production? So here we might use pre-trained APIs that are fast or custom models that take time. You have to consider effort. So effort depends on the problem complexity, data readiness, and team skills. Solutions can range from quick implementation to longer custom development. We have differentiation. So how unique does your model need to be? Simple needs to fit off-the-shelf models. Vertex AI allows customization for unique cases. We have required expertise, so assess your team's expertise and needs. Advanced AI projects may need specialized engineers or training. So these are all considerations, okay? Let's talk about some common threats that you may encounter in the cloud. So a threat is in cloud security is a potential negative action or event facilitated by vulnerability that results in unwanted impact to a computer system or app. Google wants you to know these 5 types of threats. The first is phishing attacks. These are deceptive emails used to steal credentials or sensitive data. You have DDoS attacks. These are servers that are overloaded with traffic to disrupt services, leading to downtime and loss of revenue. We have ransomware. This is a type of malicious software that, when installed, holds data, a workstation or network hostage until the ransom has been paid. We have cloud misconfiguration, so poorly configured cloud environments that expose vulnerability that can lead to data leaks. We have insider threats, so internal individuals misuse their access, leading to data theft or other security breaches. So there we go. Let us compare cloud security versus on-premise security. So for location, the data, the apps are hosted off-site data centers managed by cloud providers. In a traditional one, your org is going to be hosting them within your facilities or in a co-tenant location that you are renting. For responsibility, the security of the infrastructure is the responsibility of the actual provider, but the customer is responsible for the data, the app, and the access. For traditional on-premise security, orgs secure the entire stack, so you're responsible for everything. For scalability, the cloud service provider, here we're talking about Google, can provide a lot of scalability out of the box. On-premise, you're responsible for it for maintenance and updates. Again, the cloud service provider, Google, in this case, is updating and maintaining the underlying infrastructure. If it's traditional, you're doing all the work. For the cost model, you have pay-as-you-go or operational expenditures. For traditional, you have capital expenditures with significant upfront investment. Which one you choose to do is dependent on what you want. You can use a mix of these things, especially with emerging AI ML technology. We're seeing cloud I never gonna say the word, but basically people leaving the cloud. So, you have to choose what it is that you want. Neither is good or bad. You just have to decide what it is your organization wants to utilize. But there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at identity and access services and also security services for the Google Cloud Platform. So at the top here, we have identity and access management, so IAM. This establishes fine-grained identity and access management for Google Cloud resources. We got cloud identity, so easily manage user identities, devices, and applications from one console. Identity platform, add Google-grade identity access management to your apps. Beyond Corp Enterprise, a zero-trust solution that enables secure access with integrated threat and data protection. Identity-aware proxy, that's always used with Beyond Corp, so use identity and context to guard access to your applications and VMs. Managed service for Microsoft Active Directory. So this is just if you need Active Directory and you want it hosted on Google, you can do it that way. Resource Manager, this is a hierarchical managed resources on Google Cloud. Security key enforcement, so enforce the use of security keys to help prevent account takeovers. Tighten security keys to defend against account takeovers from phishing attacks. These are security keys made by Google. Not going to show up in the exam, but they look really cool. They're supposed to be really good, so check them out. Before we move on to the next slide, I just want to give some focus here. You want to know what IAM is. You want to know what cloud identity is. You want to know what Beyond Corp Identity Aware Proxy is. You definitely want to know what Managed Service for Microsoft Active Directory is. These are the ones that are going to show up on the exam, okay? Moving on to security, so access transparency. get visibility over your cloud provider through near real-time logs, binary authorization, so deploy only trusted containers on Kubernetes engines, cloud asset inventory, so view, monitor, and analyze Google Cloud and Anthos assets across projects and services, cloud audit logs, gain visibility into who did what, where, when, all that stuff on Google Cloud. Cloud data loss prevention. Sometimes I write protection in there, but it's prevention. Discover and redact sensitive data. Cloud HSM, protect cryptographic keys with a fully managed hardware security module service. Cloud key management service, manage encryption keys on the cloud. This one is the multi-tenant. This one is the single tenant, okay? Security command center, so understand your security and data attack service. Shielded VMs, so deploy hardened virtual machines on Google Cloud. VPC service controls, protect sensitive data in Google Cloud services using security perimeters, incident response management, improve your incident and medium time to mitigate. I'm just going to erase the ink here for a second. The ones you should be focused on for this exam is cloud data loss prevention and security command center. That's why I give them the icons here so they stand out, okay? So there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at user protection services. And this is like stuff that would be offered via Android or via the Chrome browser, right? So, not core to Google Cloud, but you should know these things anyway. So you get phishing protection, so help protect your users from phishing sites. ReCAPTCHA Enterprise, so help protect your websites from fraudulent activity, spam, and abuse. Web risks, so detect malicious URLs on your website and in client apps. But I thought this one was the most interesting, is that if you want this I'm not a robot thing, you can get that in Google Cloud, okay, and put it on within your apps, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at Secure by Design infrastructure for Google Cloud. And this isn't exactly going to show up in the exam, but the idea here is it's going to help you understand to what level Google takes its security seriousness, okay? So we have operational device security. So develop and deploy infrastructure software using rigorous security practices. Operation teams detect and respond to threats to infrastructure from both inside and external actors 24/7, 365, okay? Internet communications over internet to public cloud service are encrypted in transit. Network and infrastructure have multiple layers of protection to defend our customers against denial of service attacks. For identities and users and services are strongly authenticated. Access to sensitive data is protected by advanced tools like phishing-resistant security keys. Storage services, so data stored in the infrastructure is automatically encrypted at rest and distributed for availability and reliability. Guards against unauthorized access and service interruptions. Service deployment, any application that runs on our infrastructure is deployed with security in mind. We don't assume any trust between services, and we use multiple mechanisms to establish and maintain trust. Infrastructure was designed to be multi-tenant from the start. Hardware infrastructure, from the physical premises to the purpose-built servers, networking equipment, and customer security chips or custom security chips to the low-level software stack running on every machine. Our entire hardware infrastructure is Google-controlled, secured, and hardened. Data centers. So Google Data Centers features layered security with custom-designed electronic access cards, alarms, vehicle access barriers, perimeter fencing, metal detectors, biometrics, laser beams, okay? Laser beam intrusion detection. They're monitored 24/7 by high-resolution cameras that can detect and track intruders. Only approved employees with specific roles may enter. Continuous availability. Infrastructure underpins how Google Cloud delivers services that meet our high standards for performance, resilience, availability, correctness, security, design, operation, and delivery all play a role in making service continuously available. So hopefully that makes you confident in Google's security practices, but there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at Compliance Report Manager. This provides you with easy, on-demand access to critical compliance resources at no additional cost. Really, this is just downloadable PDFs that prove that GCP is compliant with various compliance and security standards. So you don't even have to log in to access this. You just go to the Compliance Reports Manager, and it's not even in Google Cloud, it's in the marketing websites, and you just checkbox what you want, and then you can go ahead and download that and read through it and see that they're being compliant, okay? Hey, this is Andrew Brown from ExamPro, and we are going to look at a bunch of different compliance programs that Google is meeting. Not the most exhaustive list, but the most popular, and these will be the most popular with other cloud service providers, and they're good to know, okay? So we'll work our way through here. The first here we have is the ISO and IEC. Or IEC. These are commonly used together because one is international standards for software, and the other one is like when you're using physical or physical devices like hardware, okay? So we have control implementation guidance, enhanced focus on cloud security, protection of personal data in the cloud. So we're talking about personally identifiable information, privacy information management system framework, so outlines controls and processes to manage data privacy and protect PII. I know CTOs, they're always going for the 27001, but the numbers are there to useful to remember. So 27001, 27017, 27018, 27701. And I do actually have these memorized because that's how frequently they come up. We have systems and organization control, SOC, and there's 3 layers of SOC, SOC 1, SOC 2, SOC 3. So SOC 1, 18 standards and report on the effectiveness of internal controls at a service organization relevant to clients' internal control over their financial reporting. I'm not hearing people going after SOC 1, but they're always going for SOC 2. Evaluates internal controls, policies, procedures that directly relate to security of a system at an organization. SOC 3, a report based on trust service criteria that can be freely distributed. You hear 2701 a bunch and SOC 2 a bunch, okay? PCI DSS, so Payment Card Industry Data Security Standard, a set of security standards designed to ensure all companies that accept, process, store, and transmit credit card information maintain a secure environment. You got FIPS, so Federal Information Processing Standard 140-2, so U.S. and Canadian government standard that specifies the security requirements for cryptographic modules to protect sensitive information. This one's one you're going to want to remember when you're using a cloud service provider that stores cryptographic keys. They're going to be FIPS 142. And it's either going to be for multi-tenant or single tenant. I think if you're doing like Cloud HSM, which is a single tenant, it's going to have FIPS 140-3, okay? Which is better. It's more strong, okay? We got the Personal Health Information Protection Act, so PHIPA. I'm in Ontario, so this one's pretty relevant to me, but it's just an example of one that's outside the standard HIPAA one, okay? We have HIPAA, so Health Insurance Portability and Accountability Act. This is a U.S. federal law that regulates patient-protected health information. We have CSA, so this is an independent third-party assessment of a cloud provider's security posture. We have FedRAMP, so Federal Risk and Authorization Management Program. We spent more time with this earlier on in the course. So U.S. government standardized approach to security authorizations for cloud service offerings. So how the government works with the cloud. Criminal Justice Information Services, so CJIS, any U.S. state or local agency that wants to access FBI's CJIS database is required to adhere to the CJIS security policy. Then we have the General Data Protections Regulation, GDPR. So a European privacy law imposes new rules on companies, governments, agencies, nonprofits, other organizations that offer good, secure services to people in the European Union or collect and analyze data tied to the EU residents. You want to know GDPR, you want to know FedRAMP, okay? So there you go. Hey, this is Andrew Brown from ExamPro, and we're going to look at privacy and transparency for Google. And this is more just to communicate the practices they do for these things, okay? Not necessarily going to show up in your exam, but something you should know at the fundamental level when you're convincing the executives why to use Google Cloud, okay? So Google Cloud Enterprise Privacy Commitments describe how we protect the privacy of Google Cloud Platform and Google Workspace customers. So you control your data. Customer data is your data, not Google's. We only process your data according to your agreements. We never use your data for ad targeting. So we do not process your customer data to create ads, profiles, or improve Google ad products, which it kind of feels a bit, I feel like Google's probably done it in the past, but they don't do it anymore at least. We are transparent about our data collection and use. We're committed to transparency, compliance with regulations like GDPR and privacy best practices. We never sell customer data or service data. We never sell customer data to third parties. Security and privacy are primary design criteria for all of our products. Prioritizing the privacy of our customer means protecting the data you trust us with. We build the strongest security technologies into our products. Google provides resources on privacy regulations such as LGPD, GDPR, CCPA. the Australian Privacy Act, My Number Act, PIPEDA, and a bunch more. For transparency, Google has trust principles. You own your data, not Google. Google does not sell customer data to third parties. Google Cloud does not use customer data for advertising. All customer data is encrypted by default. We guard against insider access to your data. We never give any government entity backdoor access. Our privacy practices are audited against international standards. So there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at Cloud Armor. And to understand the service, we need to know what a distributed denial of service attack is, a DDoS attack, so a malicious attempt to disrupt normal traffic by flooding a website with large amounts of fake traffic. So you got an attacker on one side and a victim on the other side, and the internet sits between them. So what the attacker does is they use a bunch of remote machines, and they issue commands to those machines and tell those machines, hey, go produce a bunch of spoofed data and send it over the internet, and it's going to go towards the victim. Now, the great thing is, if when you're using a cloud service provider, you're within their network, they generally have built-in DDoS protection. Now, what's unusual with GCP is they don't really call that out very clearly, but I'm sure that they have some layer of built-in DDoS protection. But the service that provides, more robust DDoS protection is going to be Cloud Armor. Now, Cloud Armor is a bit different from other cloud service providers in that it does DDoS protection, and it's also a web application firewall. These are usually separated as two different services and other providers. GCP decided to roll it into one. Some of its feature sets are IP-based and geo-based access controls, support for hybrid and multi-cloud deployments, adaptive protection, detect and mitigate attacks against your cloud load balancing workloads, predefined WAF rules to mitigate OWASP's top 10 risks, named IP lists, rich rule language for web application firewalls, visibility and monitoring, and Cloud Armor has two tiers. You got the standard, so pay as you go, and Managed Protection Plus, starting at $3,000 a month. Pretty standard to see those two-tier pricings for DDoS protection. Not that standard to see these two tools rolled into one, but that's just how they do it, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at private cloud, which allows you to package Google Cloud resources into service offerings that can be made available and discoverable in a catalog internally to your organization to quickly deploy governed stacks and workloads. So this is what the catalog would look like. The idea is that you would build different kinds of products within this catalog or workloads, whatever you want to call them, stacks. And the idea here is you would apply permissions to say who in your organization is allowed to launch them. And so this is a great way to stay compliant because you have these workloads that your developers or your engineers have made sure that are safe to be used within your organization. And then it allows your departments to just procure resources they need. Okay, so there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at Security Command Center, and this is a centralized security and risk management platform for your Google Cloud resources. So there's a lot that you can do in here. I don't know if you can make it out, but you got threat detectors, VM patching, cryptographic keys, binary authorization, security scanners. You might have noticed these terms as we're listing through them very, very quickly. So there's a lot of stuff that lives within this command center that you can do. Three things I want to highlight that could be relevant to your exam is asset discovery and inventory. So inventory and historical information about your Google Cloud resources, threat detection, so audits your cloud resources for security vulnerabilities, threat prevention, fix security misconfigurations with single-click remediation. If the exam is asking you which service has a holistic view or everything in one place to do stuff for security, this is the service, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at Google Cloud Data Loss Prevention, so DLPs detect and protect sensitive information within GCP's storage repositories. So we're looking at personally identifiable information, so PII, so any data that can be used to identify a specific individual. Really great example here is of McLovin, from a movie from 10 years ago. He has a fake ID here, but it gets the point. We're talking about, driver's licenses, government IDs, passports, email address, mailing address, birthdays, any of that kind of personal identifiable information. Then there is protected health information, PHIs. This is very similar, except it's talking about the identity health information about a patient. Some of its features of DLP here, it provides tools to classify, mask, tokenize, and transfer sensitive data, support for structured and unstructured data, create dashboards and audit reports, automate tagging, remediation, policy-based findings, connect DLP results into the Security Command Center data catalog, or export to your own security information and event management system, SIEM, or governance tool, schedule inspection jobs directly in the console UI, over 120 built-in information types, so info types, and info types define what sensitive information can be scanned. So there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at BeyondCorp for the Google Cloud. So the zero trust model operates on the principle of trust no one, verify everything. And so the idea here is malicious actors are being able to bypass conventional access controls, demonstrating traditional security measures are no longer sufficient. So BeyondCorp is Google's implementation of the zero trust model, and it's going to allow us to do things such as single sign-on, access control policies, access proxies, user-based authentication, device-based authentication, authorization. And by shifting access controls from the network perimeter to individual users, BeyondCorp enables secure work from virtually any location without the need of a traditional VPN. So the principles here for BeyondCorp are access to services must not be determined by the network from which you connect. Access to services is granted based on contextual factors from the user and their device. Access to services must be authenticated, authorized, and encrypted. Okay? So a zero trust model puts identity as the primary security perimeter, because remember we shift that over to the users away from traditional firewalls to be protected. BeyondCorp is just a collection of identity, access, and security services to meet the zero trust model requirements. Okay, so that's where it gets confusing, because there's BeyondCorp Enterprise, which actually is a service, and BeyondCorp is more of a conceptual idea of these identity, access, and security services. Okay, so the idea is that we have apps and data, so web apps, virtual machines, SaaS applications, infrastructure, APIs. We're trying to restrict, control access to these things to mitigate security risks, right? And so on the left-hand side, we have user trust and device trust, right? And this is where we're going to be looking at their identity and their behavior. For devices, it's identity and the posture being the conditions in which the environment they're in, right? So the idea is that they're going to come into the Google network through a global front end, and this is where we're going to get context, location, and time. So that could be extracting information like the IP, the location, the region, the session age, the time, the device type, things like that. We're going to pass that through a rules engine, and then from there we have an enforcement point where it makes further decisions before it accesses our apps and data. So this is generally the idea of a zero trust model, okay? And this is kind of the rough outline of where BeyondCorp is going to be. The idea here is that we now incorporate services. So here we're using cloud identity. This is for endpoint verification. This is just Google's front end. This isn't a service in particular. This is just the Google network, okay? Then you have Access Context Manager. And then for enforcement points, we have Cloud IAP, Cloud IAM, Cloud Identity, VPC Service Controls. I've highlighted the three in yellow because to me, that's really what BeyondCorp is. It's adding those three components into it. But basically, BeyondCorp is the collection of all these services working in this model, okay? Let's talk about SecOps, which stands for Security Operations. This is the practice of protecting your data and systems in the cloud by integrating security and operations to reduce risks and improve response to threats. So what we have here under SecOps is vulnerability management, so identifying and fixing security vulnerabilities, which we can do through the Google Cloud Security Command Center, log management, which we can do through Google Cloud Logging, incident response, security awareness training, okay? The business benefits of SecOps is reducing risk of data breaches, increased uptime, improved compliance, enhanced employee productivity. So this term SecOps was something that came up in the exam guide, so we wanted to make sure we covered it here, okay? Let's take a look at data sovereignty, and this ensures that data is subject to laws of the country where it's stored, protecting individual rights, such as GDPR in the EU. Data residency refers to the physical location of data storage, with some countries mandating that data be stored within the borders for compliance. So the way it works for Google is Google Cloud offers options to select regions of data storage, ensuring compliance with local regulations. We have features like VPC service controls and Google Cloud Armor, which restricts data access, traffic location, ensuring compliance with data residency and sovereignty requirements. So there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at the concept of a directory service. So a directory service maps the names of network resources to the network addresses, and a directory service is shared information infrastructure for locating, managing, administrating, and organizing resources such as volumes, folders, files, printers, users, groups, devices, telephone numbers, and other objects. A directory service is a critical component of a networking operating system, and a directory server, also known as a name server, is a server which provides a directory service. Each resource on the network is considered an object by the directory server. Information about our particular resource is stored as a collection of attributes associated with that resource or object. So very well-known directory services would be a DNS, so domain name service. This is the directory service for the internet, so you don't know it, but you're using it right now. There's Microsoft Active Directory. This is basically the industry standard for most or almost all organizations in the world. Underneath, you have Azure Active Directory, also known as Azure AD. This is a managed service on the Azure cloud. There's Apache Directory Server. Oracle has their own. There's Open LDAP, Cloud Identity, which is Google's identity as a service provider. And then you have Jump Cloud, which is one that is kind of an agnostic one where you can connect a bunch of directories to it. Okay, so there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at Cloud Identity, and this is identity as a service by Google Cloud that centrally manages users and groups. So you get a bunch of stuff in here like user lifecycle management, account security, single sign-on, cloud directory, device management, reporting, analytics, app management, extensible through APIs, does a bunch of stuff. And the idea here is to confederate things between Google Cloud, Active Directory, Azure AD, and many more directory services. You can manage access and compliance across all users in your domain. You can create a Cloud Identity account for each of your users and groups. Then you can use Identity Access Management, so IAM, to manage access to Google Cloud resources for Cloud Identity account. If you want to give someone access to your Google Cloud without having a Google Workspace account, so not having a Gmail and the G Suite, this is what you would use Cloud Identity so that it could just get access to just Google Cloud. So there are two versions of Cloud Identity. We have free and premium, and there is a lot of features here, but let's just run through it so you get the idea or the scope of what Cloud Identity can do. So it can handle device management, and in the free version, we have basic mobile management, directory or device inventory, basic passcode enforcement, remote account wipe, Android, Apple iOS. In the premium, you get advanced mobile management, advanced passcode enforcement, security policies, application management, network management, remote device wipe, reporting, application auditing, company-owned devices, mobile audit, MDM rules. So that would be mobile device management rules. Okay. Then for directories, you have in the free basic directory management, organizational units and groups, and they're unlimited. That's pretty standard in all directory services. Admin managed groups, groups for business, Google Cloud Directory Sync, which we'll give closer attention to later on, admin rules and privileges, Google Admin app for Android, Google Admin app for iOS, just showing you works on both. Admin SDK API, so you can pragmatically work with the directory. Secure LDAP. For the premium, we have user lifecycle management, and there's no user cap on this. Secure LDAP. I guess it's in both, so maybe we don't have to list it in both there. Single sign-on and automated provisioning. So for free, we have set up SSO using Google as identity provider to access pre-integrated list of third-party SAML apps. Set up SSO using Google as an IPD to access custom SAML apps. Set up SSO using a third-party IPD with Google as a service provider. For premium, we have automated user provisioning. For security, we get user security management, self-service password recovery, which is a great feature. Azure AD also has this, so I really like this. Two-step verification, so I guess that's multi-factor, including security key management, we have enforcement control, so with security key enforcement and management, password management and strength alert. For premium, first-party session management, Google Security Center. For reporting, we get admin, login, SAML, groups, token, audit logs, security reports, SAML audit logs, app reports, account activity reports. For premium here, we get device audit logs, auto export audit logs to BigQuery, and you get an SLA of 99.9% of premium. So here you can see it does a lot. You don't need to remember all this stuff for the exam, but if you're going to take anything away from here, just understand that Google Cloud Directory Sync is a subservice of Cloud Identity, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at Active Directory. Now, this isn't a Google service per se, but the thing is, no matter what you're using, no matter the cloud service provider, you'll want to know Active Directory inside and out because it's fundamental knowledge, and most enterprises are using it. And now with everyone going towards a zero trust model, identity and Active Directory just go hand in hand, okay? So we're going to put some extra attention here on this one. So Microsoft introduced Active Directory domain services in Windows 2000 to give organizations the ability to manage multiple on-premise infrastructure components and systems using a single identity per user. So here's the big architectural diagram that I created. So the idea is that you have your enterprise, which is the forest here, and these are made up of domains. A domain is a means to host these different directory services, and it's also the means to which people authorize or authenticate to your directory, okay? So the idea is that you can think of domains as actual servers, and you're going to have redundant ones because if the main one goes down, you'll want to make sure people can still log in and do their business. And you might want domains that are closer to the region to which they are authenticating, so things are very, very fast. That's why we're seeing a lot more here than just a single one, okay? When we look inside of a domain, doesn't matter if it's a child or a domain, we have organizational units. These are just ways of structuring maybe departments or things like that. And with organizational units, we have objects. And so objects could be groups, users, printers, servers, devices. We saw a larger list when we listed out directory service, so we don't need to go through it, but the idea is that it's just basically things within your network, okay? Then we have Active Directory Domain Services, shortened to ADDS. So these are the services that consist of multiple directory services. All right, I know it gets confusing because there's directory service and then there's directory services, but these are services within a directory service, if that makes any sense. So domain services, these are the foundation stone of every Windows domain network, stores information about members of the domain, including devices, users, verifies the credentials, and defines the access rights. The server running this service is called a domain controller. All right, so usually when we talk about the actual server, that people are calling them domain controllers. All right. Some of the services that can be found within Active Directory would be Active Directory Lightweight Directory Service. So this is an implementation of LDAP protocol for Azure Directory Domain Services. We're going to definitely talk about LDAP in this course. We have Active Directory Certificates Services, so it establishes an on-premise public key infrastructure, create, validate, revoke public key certificates for internal uses. All right, we have Active Directory Federation Services, so a single sign-on. We talk about single sign-on in this course too. So users may use several web-based services, network resources, using only one set of credentials stored at a central location. We have Active Directory Rights Management Service. This is a server software for information rights management shipped with Windows Server, uses encryption and a form of selective functionality denial for limiting access to documents. There's a bunch of terminology for Active Directory. I want to get you used to it, so let's go through it. Domain is an area of a network organized by a single authentication database, and an Active Directory domain is a logical grouping of 80 objects of a network. A domain controller is a server that authenticates user identities and authorizes their access to resources. So this is the logical grouping, and this is the actual server that does the work. A domain computer is a computer that is registered with a central authentication database. A domain computer would be an AD AD object. An AD object is the basic element of an Active Directory, such as users, groups, printers, computers, shared folders. GPOs, group policy objects, is a virtual collection of policy settings. It controls what AD objects you have access to. Organizational units is a subdivision within an Active Directory into which you can place users, groups, computers, and other organizational units. Very common to make your departments out of OUs. Directory service, such as Active Directory Domain Service, provides the methods of storing directory data and making the data available to the network users and administrators. A directory service runs on a domain controller. So, hopefully you have some kind of idea what Active Directory is. But yeah, that's the quick crash course, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at managed service for Microsoft Active Directory, and this is just Active Directory hosted on the Google Cloud Platform. Why would you want to do this when you have cloud identity? Well, there's just a lot of rich features within Active Directory that Cloud Identity doesn't have, or maybe your team is used to using Active Directory. You can use Cloud Identity and Active Directory together because you can just federate your Active Directory over to Cloud Identity. But traditionally, Active Directory has always been hosted on-premise. However, a lot of people are shifting to the cloud because you just don't have to deal with those servers anymore. So there is a use case for this. I think a lot of people, if they're going to be using a managed Active Directory, they're going to use Azure AD just because Azure or Microsoft is the best at it. But other cloud service providers such as AWS and GCP will give you a managed version of Active Directory. So compatibility with AD-dependent apps. So runs real Microsoft AD controllers, uses standard Active Directory features, so GPOs, remote server administration tools, virtually maintenance-free, so high availability, automatically patched, configured with secure defaults, protected by appropriate network firewall rules, seamless multi-region deployment, so simply expand the service to additional regions while continuing to use the same managed AD domain, hybrid identity support, so support your on-premise AD domain to Google Cloud, deploy a standalone domain for your cloud-based workloads. So there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at the concept of identity providers, also known as IPDs. And so a system entity that creates, maintains, and manages identity information for principals and also provides authentication services to applications with a federation or distributed network. A trusted provider for your user identity that lets you use authenticate to access other services. Identity providers could be things like Facebook, Amazon, Google, Twitter, GitHub, and LinkedIn. So federated identity is a method of linking a user's identity across multiple separate identity management systems. And the way you're going to do this is via OpenID, so Open Standard and Decentralized Authentication Protocol. So this is your ability to be able to log into a different social media platform using Google or Facebook account. OpenID is all about providing who you are. You have OAuth 2.0. This is the industry standard protocol for authorization of OAuth. Doesn't share password data, but instead uses authorization tokens to prove an identity between consumers and service providers. OAuth is about granting access functionality, and I put these in the lineup because you know what? I even get these two mixed up, but they go hand in hand, all right? So providing who you are, about granting access to functionality. Then you have SAML, so Security Assertion and Markup Language is an open source or open standard for exchanging authentication and authorization between an identity provider and a service provider. An important use case for SAML is single sign-on via the web browser, and that's the reason we're bringing up SAML, is so that we can talk about single sign-on. Hey, this is Andrew Brown from ExamPro, and we are taking a look here at single sign-on, also known as SSO, and this is an authentication scheme that allows a user to log in with a single ID and password to different systems and software. So SSO allows IT departments to administer a single identity that can access many machines and cloud services. So here on the right-hand side is the many things that we want to access, and on the left-hand side we have our directory service. In this case, it's Azure Active Directory, and we have a user that wants to connect with a single username and password to all this stuff. So through the SAML protocol, which we covered in the last slide, we can do single sign-on to all of these services. And the key thing to remember is that SSO is seamless. So once a user logs in to their primary directory, they don't have to keep on entering their passwords in. It's just going to seem like they're already logged in when they visit these resources, okay? Hey, this is Andrew Brown from ExamPro, and we're taking a look here at Lightweight Directory Access Protocol, LDAP, is an open, vendor-neutral industry standard for application protocols for accessing and maintaining distributed directory information services over IP networks. So a common use of LDAP is to provide a central place to store users and usernames and passwords. LDAP enables for same sign-on. So same sign-on allows users to use a single ID and password, but they'll have to enter it every single time they want to log in. So the idea is you might have an Active Directory server on premise, and it's going to synchronize with an LDAP directory, so you can get access to things to like Google Cloud, Kubernetes, Jenkins. And you're noticing that I'm not listing out generic web apps. These are more kind of like heavy-duty workloads, because that's where LDAP kind of is used a lot, okay? So why use LDAP when SSO is more convenient? Because with SSO, you don't have to enter your password and username every single time. Well, the thing is, SSO systems are often built on top of LDAP, but LDAP was not designed natively to work with web applications. So you don't do single sign-on with LDAP, and a lot of times you just don't see direct integration with them. So you'll see LDAP more on-premise or using DevOps workloads like Kubernetes or Jenkins. So some systems only support integration with LDAP and not SSO, so there's just times when you have to use it, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at Google Cloud Directory Sync. So it enables administrators to synchronize users, groups, and other data from an Active Directory LDAP service to their managed service for Microsoft Active Directory within Google. So it's just a synchronization service, and so this one will show up on the exam for sure, so make sure you know what it is so you can choose it correctly, okay? Let's take a look at DevOps and SRE. SRE is actually a term invented by Google, and they have a whole white paper on it, I think. But let's first define DevOps. It is a method that combines development and operation teams to improve collaboration and accountability. So there's the term of silos, so isolated teams that don't collaborate. So DevOps breaks these barriers to improve teamwork. We have gradual change, so making small incremental updates to reduce risk and improve system reliability. There's tooling and automation. So this is when you want to reduce manual work and increase efficiency. We have the idea of measure everything. So tracking performance to understand what's working, what needs improvement. Then we have the term SRE, Site Reliability Engineer. Again, this was a term invented by Google, a job title that they invented. It is a method that applies software engineering to operations, making systems more reliable and scalable. We have the idea of shared ownership. So developers and operation teams share responsibility for system reliability. We have blameless post-mortem, so reviews after failures to learn from mistakes without blaming anyone. I'm sure people are not going to get blamed if things fail, but that's interesting that they have that. We have error budget, so the allowed margins for failure before it impacts the user experience. We have toil. So repetitive manual tasks that can be automated to improve efficiency. So there's a bunch of DevOps and SRE terms that you should know. Hey, this is Andrew Brown from ExamPro, and we are taking a look here at service level agreements, also known as SLAs. So an SLA is a formal commitment about the expected level of service between a customer and a provider. So when a service level is not met, and if customer meets its obligation under SLA, customers will be eligible to receive compensation. So financial or service credits. You can think of them as store credits because you can use them towards the services provided by the CSP, whether it's compute, storage, databases, etc. But there will be sometimes exceptions. So maybe like registering domains, because that actually costs money, okay? So then you have service level indicators, so SLIs. This is a metric or measurement that indicates what measure of performance a customer is receiving at a given time. A SLI metric could be uptime, performance, availability, throughput, latency, error rate, durability, and correctness. Then you have SLOs, so service level objects. That is the objective that the provider has agreed to meet. So SLOs are represented as a specific target percentage over a period of time. So an example here could be availability SLA of 99.99% in a period of 3 months. Target percentages that you commonly see are 99.95%, 99.99%, 99.99999999, and so that is nine nines after the decimal point. So we'll say 9 nines of availability, 9 nines of durability. Then you have one that's for 11. So you'd say like 9 11s of durability. And so the idea here is that the SLA contains SLOs, right? And these are at the service level. And then the SLOs are based off of the SLIs, okay? Hey, this is Andrew Brown from ExamPro, and we're going to go through the SLAs for Google Cloud Platform. Now, it's in the exam guide, but it doesn't really show up on the exam, so I don't think you have to pay close attention here. And this is really boring because we're just going to list out a bunch of numbers, but, you know, maybe you'll remember some that are 95 and some that are 99, and that might help you on the exam. So let's get to it. So for Compute Engine, and mostly, I think all of these are going to be in the monthly and generally for uptime. But for covered services, instances in multiple zones, 99.99%, single instance, 99.5%, load balancing, 99.99%. Then what we have here is Cloud SQL and Cloud Functions. It's monthly uptime of 99.95%. For BigQuery and App Engines, it's monthly uptime for 99.99%. For Cloud Storage, it's going to vary based on the type of storage, but standard storage in multi-region, dual region is going to be 99.95%. Standard storage in regional location for cloud storage, nearline, cold line, multi-region, dual region is going to be 99.9%. Nearline or cold line storage class in regional location, cloud storage is going to be 99.0%. That's because of the durability is reduced. You're paying for, like it's cold line. You're not going to access it very often, so it's less of a problem, but that makes sense why it's lower. For CloudNet, this one is just the outlier where it's 99.9%. And then AI platform training prediction is 99.95%. It's like the one up here. I should have grouped it up here, but I didn't. So for Cloud Bigtable, we have a bunch of different values. So if it's multi-cluster routing, so 99.999. If it's less than fewer than 3 regions, it's just 2 nines. Single cluster routing policies, 0.9. Zonal instance, 0.9. For Apogee, and it's very unlikely they'll ever ask you SLAs for Apogee on the exam, but we have them here anyway. So for standard, 99. For enterprise, 99.9%. For enterprise plus, 99.9%. For Cloud Spanner, you have 3 nines of durability for multi-region, and then we have 2 nines for regional instance. So there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at GCP support plans. So we got basic, standard, enhanced, premium, and then just for costs, this one's free, this one's $29, this one's $500, and this one you have to contact sales. So this is premium is your enterprise support, enhanced is your business support. When you're looking at AWS or Azure, they'll charge $100, but for some reason, GCP charges $500. I think that is not smart on their part because it really makes it hard for adoption when you are a small to medium company. No idea why they did that, but that's just what it is, okay? So you get unlimited access to support for standard, enhanced, and premium. They just mean, like, I guess, to access the platform. I would think that it's unlimited across the board, but that's just how they display it there. For billing support, that's asking billing queries. You can use email, phone, or chat. In terms of response time, standard is priority 2. So the larger the number, the lower the priority, okay? Priority 0 is the highest, right? So you can expect a 4-hour response here. In enhanced support, you're looking at 1-hour response. And for premium, you're looking at 15-minute response times. But I mean, this varies based on, this is when you actually have a severe issue. So it's not for general questions, okay? For technical support, you can only do email with standard. And this is pretty common, like with either Azure or AWS, they'll call it, the standard will be just called developer support. So yeah, it's just emails. And you're looking at pretty much a 24-hour response time for that. And for technical support for enhanced and premium, you got case emails and phone. So that is a, I don't know if they have chat because I didn't really want to pay for $500 to find out if they had chat. But I've definitely experienced chat via billing support, and it's pretty darn good. But if you want to get on the phone for someone, you got to be paying a lot more. For 8 out of 5 response for high impact issues. So 8 out of 5 means 8 hours out of the day, so your standard at 5 days a week. So that's your standard work week, 24/7. So anytime you want to ask a question, they're going to be able to help you out, okay? You only get English support in standard. If you need Japanese, Mandarin, Chinese, or Korean, that's an enhanced support and premium support. And so some of the features that are found in both enhanced and premium is Active Assist Recommender API, third-party support, cloud support API, technical support escalation. For enhanced support, you get you can purchase additionally technical account advisory service (TAAS). In premium support, you get a TAM, so a technical account manager, and so that is a person that is assigned to you. You get event management service, operational health reviews, customer aware support, new product previews, training credits, and access to purchase mission critical services. So you can see there's a lot of stuff here. In terms of the exam, I didn't see a single question about like what support plan does what, which I was shocked because when you do AWS and Azure, you see that kind of stuff there. It's definitely on the exam guide, so I don't know why I didn't see any questions, and all the other people I asked never saw those questions either. Maybe they'll add them in the future, so it's worth knowing this page, I think. In terms of all these feature sets, they're definitely not going to ask you them on the exam, but we're going to cover them anyway, all this stuff here, because I think that if you are learning fundamental knowledge, and you want to convince your stakeholders, why to use GCP, you want to know the full offering of support, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at Active Assist Recommender. So Active Assist is a portfolio of intelligent tools and capabilities to actively assist you in managing complexity in your cloud operations. So make improvements easily, prevent mistakes from happening, find out what went wrong quickly. And so here on the right-hand side is a recommendation where it's saying, this is my current configuration, but it's recommending that I reduce this instance to 6 vPCUs and 20 gigabytes so I can save a bunch of money. So 3 activities is making proactive improvements to your cloud with smart recommendations, preventing mistakes from happening in the first place by giving better analysis, helping you figure out why something went wrong by using intuitive troubleshooting tools. If you use something like Trusted Advisor in AWS or Azure, it's the same thing, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at Cloud Support API, and this allows you to integrate Google Cloud's customer care within your organization's CRM. So the API supports create and manage support cases, list, create, download attachments for cases, list and create comments in cases, and so the Cloud Support API is available to customer cares with enhanced or premium support. So why would you want this? Well, if you have your own CRM, right, so you use a CRM to have your own cases for customers, it allows you to kind of centralize all of your case information in one place so that you don't have to have your users or your support team go out and make cases in Google Cloud. You can just integrate directly into a single platform. And this is a very unique offering. I haven't seen this on AWS. I haven't seen this on Azure. So this is pretty cool that GCP does this. Hey, this is Andrew Brown from ExamPro, and we are looking at Technical Account Advisory Service, and this provides proactive guidance and reactive support to help you succeed with your cloud journey. So TAAS delivers the following services, so guided onboarding to help you get started with enhanced support and set up your operations with Google Cloud, best practices and additional support for the most critical cases, including proactive monitoring and guidance on case escalation, monthly, quarterly, yearly reviews to assess your operational health across Google Cloud and deliver recommendations for improving your usage of enhanced support, recommended training paths and courses tailored to your organizational needs. When you purchase TAAS, you pay a monthly fee with a minimum 1-year contract. After the first year, your contract is month to month. So third-party technology support is available to customer care support with enhanced or premium support. So it's just something you can pay for additional on top of enhanced support or premium support just to get more guidance, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at mission critical services. So this assesses and mitigates potential service disruptions for environments that are essential to an organization and cause significant impact to operations when disrupted. To prepare you for this service, Google Cloud analyzes your current operations and onboards you to mission critical operations mode, a mode standardized by Google. The onboarding process includes the following: assessing key elements of your mission critical environment, including architecture, observability, measurement, and control, delivering delivering a gap analysis to help you prepare for mission-critical operations, bringing your organization into mission-critical operation modes to drive continuous improvement of your environment through proactive and preventive engagement. After you've onboarded, you've received the following services: drills, testing, training for mission-critical environments, customer-centric incident reporting, proactive monitoring and case generation, priority zero, so P0 support case filing privileges with 5-minute response time, war room incident management, impact prevention follow-ups. So you can see this is a pretty darn serious service, but it's only at the top tier of support, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at operational health reviews. So this helps you measure your progress and proactively address blockers to your goals with Google Cloud. So the reviews serve as a regular touch point with your TAM, where you can discuss various topics related to your customer care experience, including the efficiency of cloud operations, including support trends, analysis of trends and operational metrics, incidents, case escalations and outages, tracking of open cases, status reports of high-priority cloud projects. So there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at Cloud Billings Account, which is used to define who pays for a given set of Google Cloud resources and is connected to a Google Payments profile. So over here on the right-hand side, you can see that link. So projects are going to be going to your billing account, and then your billing account is linked to a payment profile. If you want to see that you can create multiple under a payment profile, you create multiple billing accounts. So here is just a single one, but it's very easy to create multiples. So billing account includes one or more billing contacts predefined in a payments profile. Billings can have sub-accounts for resellers, so you can bill resources to be paid by your customer. So let's compare the two so that we fully understand these two offerings, okay? So for Cloud Billing Account, it is a cloud-level resource managed in the Google Cloud Console, tracks all of the costs, charges, and usage credits incurred by the Google Cloud usage. A Cloud Billing Account can be linked to one or more projects. Projects usage is charged to the linked billing account, results in a single invoice per cloud billing account, operates in a single currency, defines who pays for a given set of resources, is connected to a Google Payments profile, which includes payment instructions defining how you pay for charges, has billing-specific roles and permissions to control accessing and modifying billing-related functions, so established IAM. So on the payments profile side, we're over here now, it is a Google-level resource managed at payments.google.com, connects to all of your Google services such as Google Ads, Google Cloud, Phone service, processes payments for all Google services, not just Google Cloud, stores information like names, address, tax ID when required legally, or who is responsible for the profile, stores your various payment instruments, so credit cards, debit cards, bank accounts, other payment methods you'll be used to buy through Google in the past, functions as a document center where you can view invoices, payment history, and so on, controls who you can view and receive invoices of various cloud billing accounts and products. So hopefully that is clear. On the exam, they're not going to ask you to choose out of these at a lineup, so I wouldn't worry about that. It's just more for your benefit, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at billing account types. So there are two types of cloud billing accounts. We got self-serve or online accounts. Payment instrument is a credit or debit card, ACH direct debit. Depending on the availability in each country or region, costs are charged automatically to the payment instrument connected to the cloud billing account. You can sign up for self-serve accounts online. The documents generated for the self-serve account include statements, payment receipts, tax invoices that are accessible to Google Cloud Console. Then you have invoiced or offline accounts. So payment instrument can be a check or wire transfer. Invoices are sent by mail or electronically. Invoices are also accessible in the Cloud Console, as are payment receipts. You must be eligible for invoice billing, and you can learn more about it somewhere in the documentation. So that's kind of interesting. I don't know. I don't remember seeing whether AWS or Azure had that, but it's cool that you can do that kind of offline method. For payment profile types, there's two as well. We got individual individual. So you're using your account for your own personal payments. If you register your payment profile as an individual, then you can only manage the profile. You won't be able to add or remove users or change permissions on the profile. And then we have business. You're paying on behalf of a business, organization, partnership, or educational institution. You use Google Payment Center to pay for Play apps, games, Google services like Google Ads, Google Cloud, phone service. A business profile allows you to add other users to a Google Payment profile you manage so that more than one person can access or manage payment profiles. All users added to a business profile can see the payment information on that profile. So there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at charging cycles. So for self-serve cloud billing accounts, your Google Cloud costs are automatically charged in one of two ways. So you either have monthly billing, so costs are charged on a regular monthly cycle, or threshold billing. Costs are charged when your account has accrued a specific amount. For self-serve cloud billing accounts, your charging cycle is automatically assigned when you create the account. You do not get to choose your charging cycle, and you cannot change the charging cycle. For invoice cloud billing accounts, your typical receive one invoice per month, and the amount of time you have to pay your invoice. So your payment terms is determined by the agreement you made with Google. So there you go. Hey, this is Andrew Brown from ExamPro, and we're looking at cloud billing IAM roles. So cloud billing lets you control which users have administrative and cost viewing permissions for specified resources by setting identity and access management, so IAM policies on the resources. So to grant or limit access to cloud billing, you can set an IAM policy at the organizational level, the cloud billing account level, or the project level. Cloud billing roles in IAM include billing account creator. So this creates a new self-serve online billing accounts. Billing account administrator, manage billing accounts, but not be able to create them. Billing account user, so link projects to billing accounts. Billing account viewer, so view billing account cost information and transactions. Project billing manager, so link and unlink the project to and from a billing account. Billing account cost manager, so can view and export cost information of billing. In the documentation here, I've just pulled up one. This is for billings admin, and just shows you all the permissions that are possible. Okay, so this is basically a condensed list of all this information, all these descriptions and stuff. But if you want to have an idea of exactly what you have access to, you can see that there. Okay. Hey, this is Andrew Brown from ExamPro, and we are looking at billing health checks and also budget alerts. So billing health checks are recommendations to avoid common billing issues. So within your billings overview, you'll see this billing health checks, and it'll either be red, like saying, look at these things, here are some ideas and things that are good. And so if you click into that, you can see a full kind of checklist. The first recommendation is to go ahead and create a budget alert. So this allows you to make multiple alert thresholds to reduce spending, surprises, and unexpected cost overruns. Lots of great suggestions here, but let's take a look more detail at budget alerts. So you can narrow down the budget scope to specific projects or specific resources. You're going to go ahead and provide a value. So here I say $100. Notice that it draws a trend line, so you can see where your spend is currently at. And you can set multiple thresholds that preemptively warn you when you approach your budget limit. So here I'm saying $50, $90, $100. This is really nice because other cloud service providers, what they'll do is you'll just set a threshold to say a single threshold, which is like 20%. And if you wanted these incremented stuff, you'd have to make multiple budget alerts or plans or whatever you want to call them, the other CSPs, but it would cost you more money. Whereas this one, you can just do it all in one go, which is really nice. So notification options, so email alerts to billing admin users, link monitoring email notification channels to the budget, connect a pub subtopic to this account, this budget. So there you go. Hey, this is Andrew Brown from ExamPro, and I just want to show you how would you get to all the cool billing features in Google Cloud Console. Well, you just go to billing in the drop down, and from there you're going to have a lot of options. But the ones that Google wants you to know, and you definitely need to know these for the exam, are the built-in billing reports. There's 4 that they have in mind. So there's billing reports, so an interactive pricing explorer including graph visualization, cost table reports, a tabular breakdown of the cost to analyze details of invoices, cost breakdown report, so at a glance waterfall overview of monthly charges and credit, pricing report. So access SKU prices for Google Cloud Services. Here they are. Just notice that they're not one-to-one in terms of naming. So that's why I highlighted these in black. So you could just see like cost table report is just called cost table. Pricing report is just called pricing, things like that, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at the billing reports in greater detail here. So billing report is to view and analyze your Google Cloud usage costs using many selectable settings and filters. So configuring various views of cloud billing reports can help you answer questions like these. How is my current month's Google Cloud spending trending? What Google Cloud project cost the most last month? What Google Cloud service costs me the most? What are my forecasted future costs based on historical trends? How much am I spending by the region? What was the cost of resources with label X? And you can also have customized report views that are savable and shareable. So on the exam, they actually might ask you, like, okay, you want to do this, right? Which built-in report will let you do that? So you need to remember these, okay, and which they apply to, all right? Hey, this is Andrew Brown from ExamPro, and we are looking at cost table reports. And a cost table report is to access and analyze the details of your invoices and statements. I know this image is really small, but down below it actually shows like kind of like a summary of costs, just like an invoice. So you can filter that out to understand those totals and things like that. So because your generated invoices and statement PDF only contains simplified summarized views of your costs, the cost table report is available to provide invoice or statement cost details such as the following, including project level cost details from your invoices and statements, including tax costs broken down out by project. Includes additional details you might need such as IDs, SKU IDs, project numbers. The report view is customizable and downloadable to a CSV. So there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at cost breakdown reports. So a cost breakdown report is an at-a-glance waterfall overview of your monthly costs and savings. So this report shows the following summarized view of monthly charges and credits, the combined cost of your monthly Google Cloud usage, on-demand rate calculated using non-discounted list prices, savings realized on your invoice due to negotiated price, if applicable for your Google Cloud billing account, savings earned on your invoice with usage-based credits broken down by credit type. Your invoice level charges such as tax and adjustments. So they call it a waterfall because it looks like a waterfall, but the idea is like this is just a much clearer view than using billing reports. Of course, you can get the same visualization with billing reports. It's just an easier visualization, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at pricing reports. So use the pricing table report to access SKU prices for Google Cloud services, including Google Cloud, Google Maps Platform, Google Workspace, as of the date the report is viewed. The report shows the following pricing information. Displays SKU prices specific to the selected cloud billing account. If your cloud billing account has negotiated contract pricing, each SKU displays the list price, your contract price, and your effective discount. If an SKU is subject to tiered pricing, each pricing tier for an SKU is listed as a separate row. All the prices are shown in the currency of the selected billing account, and the report view is customizable and downloadable to the CSV for offline analysis. Let's talk about some best practices when we're talking about cloud financial governance. And so first we'll talk about challenges with cloud spend. So we have unintentional overspending. So unmonitored resources can lead to surprise costs. So imagine you have a VM you forgot about. Cost transparency. So lack of visibility can lead to unpredictable spending. If you have a lot of resources, you might not even be aware of what's going on. Then we have how we can control and have predictable resources. This is where we have real-time monitoring. We have collaboration. We have the Cloud Center of Excellence. We have Google Cloud native tools, so we can use the cost management tools, which will help us explore that information. So it's pretty straightforward here is that, if you don't want to have those two problems, use the cost management tools, okay? Let's take a look at Google's Cloud Carbon Footprint. It's a tool that helps organizations measure, track, and reduce carbon emissions associated with their use of Google Cloud services. So here's an example of seeing missions that you are utilizing when you are utilizing services. I don't think AWS has this. I haven't seen it in Azure, and so Google has been the best at providing transparency around your carbon footprint, if that's something you care about. When you're choosing a region, it can tell you where there is a region that is low carbon impact. Remember, there's like a little green leaf that they show you. There is also low carbon regional signals. So this will tell you a guide about regions with lower emissions. So that's more stuff about tying to regions in particular. There's the active assistant recommendation. So it will suggest things where, if you shut down resources, you can save money. It's so bizarre because, when I was getting really heavy into learning cloud, like over 10 years ago, it was all about running as many things as you could across many regions and stuff to keep things up. And now it's like, oh, shut them down. You don't need them. We have Google Workspace Carbon Footprint. So this is specific to Google Workspace to help you identify stuff there. So here's a screenshot of that little green leaf I've been talking about, where you're looking at the regions and they're telling you where the CO2 is lower. By how much, I don't know, but I guess it probably tells you there in that table. Google CFE indicates the percentage of energy consumed from the carbon-free sources in each region. So there we go. And we have the grid carbon intensity measure, which measures the amount of carbon emitted per unit of electricity consumed in the region. That's what we're looking at right now. But there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at the pricing overview for Google Cloud because they have a lot of different schemes for pricing, and it's going to vary per service, but we can break it down into 7 types of pricing. So we have the free trial. So this is a risk-free trial period with specific limitations. We have free tier. These are services that have a minimum monthly limit or of free use. And then we're more now into compute. So if we have on demand, the standard price paid per hour, minute, seconds, milliseconds varies per service. Committed use discounts, a lower price than on demand for agreeing to 1 year or 3 year contract. Sustained use discounts. So these are passive savings when using resources past a period of continuous use. Preemptible VM instances with deep savings but at a cost of being interrupted. Flat rate pricing, so prefer a stable cost of queries rather than paying on demand. So this is only in particular for BigQuery. I don't know if they plan to do it for other services. We have sole tenant node pricing, so dedicated compute. So this is basically a single tenant virtual machine. So for the exam, you're going to want to know all of these pretty well, like broadly speaking. These two aren't going to show up on the exam, but we're going to cover them anyway, just for your own benefit, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at free trial and also free tier. So this is going to show up on the exam, but it's for your own benefit. So when you sign up for Google Cloud, you are going to get 90 days free for $300 of credits on the platform that you can use towards different types of products and services. And so there are some limitations to this trial that we need to go through. You cannot use these on GPUs to your VM instances. GPUs is generally used for machine learning or deep learning. You can't request a quota increase, so you get $300 or credits, and that's all you get. You can't create VM instances that are based on Windows Server images. You need to verify a credit card or other payment method to sign up. And at the end of your trial, to continue using Google Cloud, you must upgrade to a paid cloud billing account. Upgrading early will end your trial because you really are in a sandbox to keep you safe. That's one of the benefits of Google Cloud, where other providers like AWS, you have a high chance of going over your free trial into real spend, okay? So for free tier, all Google Cloud customers can use select Google Cloud products like Compute Engine, Cloud Storage, BigQuery free of charge within specified monthly usage limits. When you stay within the free tier, the resources are not charged against your free tier credits to your cloud billing account payments method after your trial ends. Okay? So for App Engine, we have 28 hours per day for F instances, 9 hours a day for B instances. 1 gigabyte of egress, so data leaving the network, like downloads. The Google Cloud free tier is available only for the standard environment, so it's not for flexible. For artifact registry, you have 0.5 gigabytes of storage per month. For AutoML natural language, you get 5,000 units of prediction per month. For AutoML tables, you get 6 nodes hours of training and prediction. For AutoML translation, you get 500,000 translated characters per month. For AutoML video intelligence, you get 40 node hours for training, 5 hours for prediction. For AutoML vision, you get 40 node hours of training and online prediction, 1 hour for batch classification prediction, 15 node hours for edge training. For BigQuery, you get 1 terabytes of querying per month. And to me, that is like super awesome. And one of the reasons why I like to use BigQuery as my primary data warehouse. You get 10 gigabytes of storage per month. For Cloud Build, you get 120 build minutes per day. For Cloud Functions, you get 2 million invocations per month, includes both background and HTTP invocations. 400,000 gigabyte seconds, 200,000 gigahertz seconds. Gigahertz, is that GHz? I think that's what it is. Seconds of compute time, 5 gigabytes network egress per month. For cloud logging and cloud monitoring, you get free monthly logging allotment, free monthly metrics allotment. For natural language, you get 5,000 units per month. For Cloud Run, you get 2 million requests per month. 360,000 gigabytes per second of memory, 180,000 vCPU seconds of compute time, 1 gigabyte network egress from North America per month, and the free tier is available only for Cloud Run. Okay, free access to Cloud Shell, including 5 gigabytes persistent disk storage. So don't fear spinning up Cloud Shell. It's a very useful tool. Cloud source repository, so up to 5 users, 50 gigabytes of storage, 50 gigabytes of egress. For Cloud Vision, 1,000 units per month. For Firestore, 1 gigabytes storage per month, or just in general, sorry, not per month. 50,000 reads to 20,000 writes, 20,000 deletes per day. For Google Kubernetes Engine, no cluster management fee. And that's a big one because other providers will charge you a management fee for the cluster or control plane. For autopilot or zonal clusters per billing account. For clusters created in autopilot mode, pods are billed per second vCPUs. Memory and disk resources request. For clusters created in standard mode, each user node is charged at a standard compute engine pricing. For cloud storage, 5 gigabytes per month of regional storage. So that's pretty good, but only for the US regions. 5,000 Class A operations per month, 50,000 Class B operations per month, 1 gigabyte network egress from North America to all region destinations, excluding China and Australia per month. Free tier is only available in US East 1, US West 1, US Central regions. Usage calculations are combined across those regions. Last page, I believe, of our free tier here. So for Google Maps, you're getting 10 gigabytes messages per month. For speech to text, 60 minutes. Video intelligence API, 1,000 units per month. For workflows, 5,000 internal steps per month, 2,000 external HTTP calls per month. For compute engine, 1 non-preemptible F1 micro VM instance per month within US West, US Central 1, US East 1, 30 gigabytes months HHD or hard disk drive. 5 gigabytes months snapshot storage in the following regions. 1 gigabyte network egress. Your free tier F1 micro instance is limited by time, not by instance. So each month eligible use for F1 micro instances is free until you have used the number of hours equal to that. So just remember F1 micro when you're looking for a free instance. Usage calculations are combined across supported regions. Google Cloud free tier does not include external IP addresses. Compute engine offers discounts for sustainable use of virtual machines. Your free tier use doesn't factor into sustained use. GPUs and TPUs are not included in the free tier offers. You are always charged for GPUs and TPUs that you add VM instances. And that makes sense because they're physical pieces of hardware. They're really expensive, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at on-demand pricing. So this is when you pay for a Google Cloud resource based on a consumption-based model. A consumption-based model means you only pay for what you use based on a consumption metric. So that could be hourly, minutes, seconds, milliseconds, can be multiplied by configuration variables such as vCPUs or memory, by API calls, so maybe $1 every 1,000 transactions. On-demand is ideal for low cost and it's because it's low cost and flexible, only pay per hour, short-term, spiky, unpredictable workloads, cannot be interrupted, and for first-time apps. So generally, it's the one you usually use, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at committed use discounts, also known as CUDs, and this lets you commit to a contract for deeply discounted virtual machines on the Google Compute Engine. It's simple and flexible and requires no upfront costs, ideal for workloads with predictable resources needs. You purchase compute resources, so vCPUs, memory, GPUs, local SSDs. Discounts apply to the aggregate number of vCPUs, memory, GPUs, and local SSDs within your region, not affected by changes to your instance machine setup. You commit for payment terms 1 year to 3 years, purchase a committed use contract for a single project, purchase multiple contracts share across many projects by enabling shared discounts. You're billed monthly for the resources you've purchased for the duration of the term. Whether or not you've actually used the service is it's going to happen anyway, okay? So 57% is most machine types and GPUs, and 70% is memory optimized machine types. So look here on the right-hand side, just to give you an idea. So the idea is that when you want to do committed use, you choose the product that you want. You're going to choose the plan that you want, the region, and the commitment, and then it's going to tell you your estimated savings, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at sustained use discounts, also known as SUDs, and these are automatic discounts for running specific compute engine resources for a significant portion of the billing month. So, sustained use discounts apply to the following resources, and this is broken into two broad categories. The first is vCPUs and memory. So, when you're dealing with these two components, you have general purpose, custom, and predefined machine types, such as you going in and dropping down different types of machines, compute optimized machine types, memory optimized machine types, sole tenant nodes. Remember, that's kind of like dedicated machines. And so here it's 10% premium cost, even if the vCPUs and memory in those nodes are covered by the committed use discounts. And then the other part here is that there's ones for GPU devices. So you can apply SUDs to GPUs, which is a great savings, okay? Applied on incremental use after each reach certain usage thresholds. You pay only for the number of minutes that you use an instance. Compute engines automatically give you the best price. There's no reason to run an instance longer for than you need it. Automatically applied to the VMs created by both Google Kubernetes Engine and Compute Engine, and it does not apply to VMs created using App Engine's flexible environment and data flow, okay? But what I want to remember is that SUDs is if you keep on using something, you're going to save money, and it's going to be particular with most CPU types, most compute types, and GPUs, okay? Oh, and also it does not apply to E2 and A2 machine types. I missed that there in the end. Just to kind of give you an idea of what kind of savings you can expect. So there's ones for up to 30%, and that's when you're using general purpose N1 predefined and custom machine types, memory optimized machine types, shared core machine types, sole tenant nodes. And so here's kind of the idea of usage level based on also the incremental charge, okay? And then we have sustained discounts for 20%, so general purpose N2, N2D, predefined custom types, computer optimized types, and then another graph. So for the exam, you're not going to need to know these details, but you just need to know SUDs. You save money when you have continued use, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at flat rate pricing, and this is only for BigQuery. Would it ever be for any other service? I don't think so. But the idea here is that if you have high volume or enterprise customers who prefer a stable monthly cost for queries rather than paying on demand, price per gigabyte of data processed, this is where flat rate pricing comes into play. So you have purchased dedicated query processing capacity measured in BigQuery slots. Your queries are, the idea here is you consume your queries via this capacity, and you are not billed for bytes processed. If your capacity demands exceed your committed capacity, BigQuery will queue up slots, and you will not be charged additional fees. To enable this flat rate price, yeah, the slide doesn't want to go forward there, but to enable the flat rate pricing, use BigQuery reservations. So there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at sole tenant node pricing. So a sole tenant node, a single tenant virtual machine, is physical compute engine server that is dedicated to hosting your own project's VM instance. You've heard me mention sole tenant many times in this course. When you create a sole tenant node, you're billed for all of the vCPUs and memory resources on the sole tenant nodes, plus a sole tenancy premium, which is 10% of the cost of all the underlying vCPUs and memory resources. It does, for sustained use discounts apply to this premium, but committed use discounts do not. After you create the node, you can place the VM on that node, and then these VMs run for no additional costs. vCPUs and gigabytes of memory are charged a minimum of 1 minute. After 1 minute of use, sole tenant nodes are billed in 1 second increments. The price of a node type depends on the following. So number of vCPUs of the node type, gigabytes of memory of the node types, region where you create the nodes. So will sole tenant show up on the exam? Probably. So just make sure you understand. You don't need to remember all the details to it, but remember, just understand what it is and generally how expensive it is, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at the Google Pricing Calculator. So this is a free web-based cost calculating tool to generally calculate costs of various GCP resources, so you do not need a GCP account to use this tool. You can create a shareable link or email that estimate to your organization or key stakeholders. So this is generally what it looks like. You choose the service. So here I say I want 2 instances, and there's other particular details, and then it's going to generate a cost. So here it's saying it's $97. You can email it. You can change the currency. Very straightforward. So there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at the concept of resource hierarchy within GCP. So this is kind of a graphic of what a hierarchy could look like, and there's a lot of components that go into it. We did cover this a little bit earlier in one slide about folders, where we talked about folders, projects, and resources. But there's a lot of moving parts here, and on the exam, they're definitely going to ask you about resource hierarchies. So let's make sure we know this, okay? First thing is a resource is a service level resources that are used to process your workloads. Could be BigQuery, Compute Engine, whatever that is a service you want to launch. Then you have resource management, how you should configure and grant access to cloud resources from your team, setup and team setup and organization of your account level resources. You have domains, primary identity of your organization, define which users should be associated with your org, you universally administer policy for your users and devices, linked to either a Google Workspace or Cloud Identity account. A Google Workspace or Cloud Identity account can only have one org, just so you know. Then you have orgs or organizations. These are the root nodes of your Google Cloud hierarchy of resources. You can define settings, permissions, policies for all projects, folders, resources. Cloud Billing account is its parent. Organization is associated with exactly one domain. Using an organization, you can essentially manage your Google Cloud resources and users' access with proactive and reactive management. Then you have folders. This is a logical grouping of projects and other folders. Folders can be used to group resources that share common IAM policies. You got projects, so logical grouping of service level resources. Projects can represent teams, environments, organizational units, business departments, and this is basically where resource hierarchy is very detailed in its variants. Basis of enabling services, APIs, and IAM permissions. A service level resource can only belong to a single project. You got labels, so categorize and filter your resources with key value pairs. If you used AWS or Azure, they call these tags, okay? But here at GCP, they call them labels. Great for cost tracking at a granular level. There are 3 suggested hierarchy architecturals you can use: environment-oriented, function-oriented, and granular access-oriented. They're not going to ask you what kind of architecture it is, but they're going to talk about these, like saying like which would be a good setup, and they'll describe kind of what the setup would be, and that's why you want to know these 3 types. And we'll go over to the docs to look at that, because that's where the most detail is for this, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at environment-oriented hierarchy. And so this is the most simplest one to implement, and pretty much what you would think that you would want to do. And so the idea here is you have a single organization, and you're going to break up your folders into different environments, so production, quality assurance, and development. And then underneath, you're going to run your application. So this works pretty well in a very simple setup, but it can pose challenges if you have to deploy services that are shared by multiple environments. Okay? Hey, this is Andrew Brown from ExamPro, and we're looking at function-oriented hierarchy. So this one looks a little bit more complicated, but the idea here is that you have one organization that contains one folder per business function, okay? So notice here we have apps, management, and infrastructure technology, and then the idea is that down below, now we can define production or environments as another layer of folders. So you have folders inside of folders. So each business function folder can contain multiple environment folders. Multiple business functions are apps, management, and information technology. More flexible compared to environment-oriented gives you the same environment separation, allows you to deploy shared services. Function-oriented hierarchy is more complex to manage than an environment-oriented, and it's separate access by business. So there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at granular access-oriented hierarchy. So this one's a little bit larger. We have 3 layers of folders. And so the idea here is we have one organization that contains folders per business unit. So now, as you can see here, it's retail, risk management, financial, commercial. I know it's hard to read, but it's hard to fit that whole image in there. Each business unit can contain one folder per business function. So now we have our functions, so application, sandbox, shared, core services, data analysis, controlled services, and each business function folder can contain one folder per environment, so production, development, etc. So this is the most flexible and extensible option. You need to spend a greater effort to manage the structure, roles, and permissions. The network topology is more complex. So really, like when you're looking at it, the idea is that we had the three types. So the first one was environment-oriented. So this is the environment. Then you had function-oriented over here, and then this one here is granular access-oriented. So the idea is that you're just adding additional folders for organization, for organizing your resources, okay? Hey, this is Andrew Brown from ExamPro, and we are doing the GCP follow-along. So the idea here is that we are going to just launch a bunch of cloud services. It's not going to be super challenging, but the idea is just to kind of help cement the knowledge of what we've learned in the lecture content. They don't even recommend it necessary for the exam, but I like to do it, and I think that you'll appreciate doing it too. So once you've created your GCP account, you should have an organization and a default project. And so one of the first things I want to show you how to do is to set up a resource hierarchy, because the idea is you have your cloud workloads below, which run in projects, and you can organize them into folders. And this is all tied to your organization. And this is a little bit tricky, and it does show up in the exam, so it's important to know how to do this. And so that's the first thing I really want to show you. So what we'll do is we'll go ahead and make our way over to IAM, because that's how we do it. And it's not going to work, and I'm going to show you why, and then I'm going to show you how to get permissions, okay? So we'll go to IAM, and on the left-hand side, if you expand it, down below, there's one that says Manage Resources. Now, you could also go up here and type in Manage Resources, because sometimes it's really hard to find things in GCP, so you just have to kind of work those two ways. But the idea is I have a bunch of projects in here, and I have my organization, and I want to go ahead and create a folder. And so I might have a folder coming back over to our structure here. We might want to have a folder like applications and then production. So if I try application here, and my organization selected, notice that I have this little caution sign that says you do not have the required permissions. Resource manager.folders.create permission to create folders in this location. So you go, okay, well, how do I get permissions? I would think that if I'm the owner, I'd have permissions to everything, but that's not the case. So if we make our way back to IAM, all right, we go all the way back here. We're under the top one here, which is for the users. And we see I have the owner role. If you look up the documentation, it's going to say, go ahead and add project or admin folder. Okay, so you go admin folder or project folder, and nothing's going to appear. And the reason why is that you can apply permissions or roles at the project level and also the organizational level. And because of that, the roles that are available are different. So you're never going to find it at the project level here. And so what you got to do is go to your organization. All right, the way you know that you're in your org right now is that it has this little building, and notice now it's just listing people at the organizational level. And so what I can do here is go ahead and edit the member, and I'm going to add a role. I'm just going to type in folder. Okay, and so now we have folder admin, and that's going to give me full access, full control to create what I wanted to do there, which was folders. Now, if we go to the left-hand side here and go to manage resources, we should have an easier time creating folders now. And so we'll go ahead here and call this application. Okay, we'll hit create and give it a moment to create. And what we'll need to do is go ahead and refresh to see that new folder, and there it is. So now that we have that folder, let's go ahead and create a folder within that folder. So I think, yeah, if we go ahead and hit create folder here, and we'll choose our organizational structure. Whoops. Sorry. So I got to go and choose the org. And then now what we can do is choose the folder. So I want application here. And following our guide here, we're going to go with, let's say development. Because we're not serious about it running any kind of production workloads today. We'll go ahead and create that. Okay, we'll go ahead and hit refresh down below, and now you can see we have application development. So let's say we want to move, or let's say we want to create a new project that's going to sit in here for our development workload. And so down below, you might want to specify the names, but what I'm going to do is create a new one in here, and I'll say create project. And this is just going to be my app. And we will choose its location. Okay, we'll hit create. And it doesn't take that much time for these to build. So if we give this a hard refresh, there's a refresh button up here. We should now see our my app. So if we go back to GCP up the top here, I should be able to switch over to my app. All right. And so now what we'll do is go ahead and create stuff there. But that's what I just wanted to show you, was the fact that you had that folders and project structure and how easy it was to create in some of those headaches there. I can't remember. You probably can apply permissions at the folder level. Let's just go take a look. I'm not running crazy workloads in GCP, so I don't always know. But what we'll do is go back to the resource manager, manage resources here. And I think you can... Yeah, I'm not sure, but it's not really in the scope of this certification. But the idea is we have our project set up, and I will make my way back to that. And now we'll start launching some resources, okay? Hey, this is Andrew Brown from ExamPro, and we are on the GCP follow-alongs for the Digital Cloud Leader. And actually, before we launch any resources, I probably should show you a bit about spend and how to control your spend. So this is a new project that we started up, and there's nothing really in it. Now, I was playing around in this other sample project here called ExamPro, and I purposely ran a bill so I could show you what billing looks like, because it doesn't make a lot of sense. Like, it's very hard to understand it if there's no billing happening. So on the left-hand side, you'll go to billing. All right. And we'll just give it a moment to load here. And so we have a bunch of different options here. So reports, cost tables, cost breakdowns, commitments, et cetera, et cetera. And so for the exam, you're going to want to know about the different types of reports, the overview reports, cost table, cost breakdown, and generally understand the differences. They're pretty thoroughly covered in the lecture content. So, it's not a big deal if you don't absorb it here. But the idea here is we can see... And this is just the overview. We have our cost trends. So we have some nice charts here. So it's just kind of like a breakdown. So maybe top products, things like that. It's very straightforward. But over here on the right-hand side, we have billing health checks. And so if we were to click this here, it's going to give us a bunch of suggestions that we should do. And so the first is grant access to view billing reports, assign multiple billing account administrators, turn off billing account creator role for domain, set up a budgets alerts, link a project, or close an unused account. So I would say that Setting up a budget alert is on our high priority here because we do not want to end up spending more than we have. So if we go over to budget alerts over here, you can see I have my spending limit and showing that I've spent $2.43 out of $100. So if we want to go ahead and create ourselves a budget, it's pretty darn easy. I'll just say my second budget alert. Okay. See, I had a lot to spend the other month there, and now I don't have so much. But the idea here is you can go and say, okay, do I want to take into account credits or not? Credits would be if you were given GCP credits to utilize for free. A lot of times startups get those. But the idea is you can go ahead and hit next. Then you can specify the exact amount. And so I could say $50, right? And it shows you a line where it can go. We'll hit next. And this is really nice, which I like. You don't see this in like AWS where you'd actually have to set up separate building alarms, but in GCP, you just can do it all in one go. So the idea is if you want multiples, you just add multiple thresholds, and it's going to warn you when it approaches those numbers. And if you go down below, you can see that you can receive emails about it. And if you also want to push it to PubSub, you could do that. So you could programmatically code it into your platform. In terms of the exam, you just need to know that you can set thresholds and why you'd want to use budgets, right? Just to make sure you're monitoring your spend. Now, I don't need to go ahead and create one because I already have one. It's a very simple process, but that is budget alerts. Now, if we go back over here to reports, this is really cool. This is basically a great way of visualizing your data. So you have a bunch of different options, and you can really pare down and say, okay, I want to know exactly what the spend was for this service. And stuff like that. So if you really want to do visuals, that's what you'd use that reports tab for. Then you have your cost table. And cost table is basically like a dynamic invoice. So the idea is like invoices just aren't able to show you all of the line items. And so here we can go and expand and see every single charge at a granular layer. And I'm pretty sure you can export this. Download here. Yeah, download it as a CSV. So it's a better way to review your bill from like an invoice perspective. Then you have cost breakdown, and this is kind of like just a simplified report. So like we have reports up here and the overview, but this is just more so kind of so you can see it at a glance per month. So is it up? Is it down? Where are we? Right? So not super complicated. And again, the questions are not hard in the exam, but really all I wanted to show you was those four there and how to set a budget alert. And that's pretty much all we need to know. So what I'm going to do is make my way back to my sample project. And now we're ready to launch some resources, okay? Hey, this is Andrew Brown from ExamPro, and let's go take a look at Compute Engine. So what I want you to do is go to the top left corner here onto our hamburger menu, and we'll scroll down, make our way over to Compute Engine, and go to VM Instances. So this is where we would launch virtual machines. So we'll give it a moment here to load. And as you can see, I've never used it within this project. So pretty often you'll have to go ahead, hit enable. So you are agreeing to use a particular service. Every time you create a project, it's always going to show you that. But we'll give it a moment to allow us to use that API. It just takes a little bit of time. And I don't know why, sometimes the UI is a little bit buggy. Sometimes it freezes like this. And so if it does do that, what you'll need to do is just go ahead and hit refresh. It's usually pretty darn good. The experience is usually pretty smooth, but not always the case. So I'm going to go ahead and hit enable again. Okay, and it just does not want to work right now. So if that happens, and it's totally possible that can happen, what I recommend is just step away, go get a tea, go get a coffee, and then come on back because it'll probably work in just a bit, okay? I'll see you back in a moment. All right, so after a short tea break, I'm back, and it's now just all of a sudden working. So that's the thing with these large cloud service providers is that their services are so massive. It's very common to run into inconsistencies in the UI where you think you've done something, but it's telling you haven't, but you know you have. And so you have to have confidence knowing, okay, I did do this, and just give it a little bit of patience and time. And just check in again. And so here you can see it actually launched multiple times because I pressed the button 4 times. So it actually worked the first time. But here we are. And if you want a quick start, you can hit this button here. And the thing is that GCP, and only GCP does this, but they have a really, really good tutorial system. So if you want to be shown around anything, you can hit show me now. and it'll help you step through all the things that you need to know. And so this one is just kind of like a tutorial on how to do something. I'm not going to go through it. This is more for you. This is how to do a to-do app with MongoDB. I don't like MongoDB, so I'm not doing that today. But I just want you to know that's a great way to start learning with GCP. But what we'll do, and you can see we have different instances here. So VM, instance templates, sole tenants, those are dedicated machines, machine images, etc., TPUs. But what we want to do is just go ahead and create ourselves a regular old virtual machine. So I'll go ahead and hit create instance, and we'll give it a moment here. Today's a slow day for GCP. It's usually super fast. And here we're in here. And so on the left-hand side, we have new VM instance from template, new VM instance from machine image, or the marketplace. Now, I really like how GCP shows their forms compared to AWS and Azure, because they're always like on one screen, and they're very good about showing you the price, which is really nice. And here you can do you get a breakdown to kind of see where the hidden costs are. So it's not just the CPU cost that, it's just like there is a persistent disk. And maybe if you're using sustained use discount, if you've used it on a monthly basis, it'll show you your savings. Notice it's like a negative, so it would show you a reduced cost there. But the idea here is that we want to name our instance. So I'm going to just say my website. Okay. We'll see if it takes that. We can add labels. Labels are tags, so I could go here and say env production. We'll go ahead and add that label. Other providers call them tags. For some reason, GCP wants to call them labels, but it's the same thing. Notice we can choose our region. So I'm going to see if there is a Canada region. I'm pretty sure there is. I just started typing as if I was on Azure, and that's not the case. So I got to scroll on down and look for it. I know there's a Montreal. There's always a Montreal right there at the top. And so I can choose between my zones. I'm going to stick with Zone A. Notice we have general purpose and compute optimized. Notice as soon as I went to compute optimized, it's $135. We'll make our way back. E2 is, I believe, the most cost-effective instances. Another thing that's really nice about GCP is that they just have fewer things to look at. So it's just a lot easier to get set up here. But this is good for me. I don't need a 2 vCPUs and 4 gigabyte memory. I want to go super small, so I'll click on that. Now I'm down to $7.83. I'm a lot more comfortable with that. We'll scroll on down. So confidential VM services enable the confidential computing service on this VM. So this service adds protection to your data in use by keeping memory of the VM encrypted with keys that Google doesn't have access to. That sounds really good. So you can see we can checkbox that on, and we have some additional settings. We're not going to do that today, but I think that's really cool. This is something I really like, is that most instances, I think basically all instances, can support this container option. And what it will do is it will install a container layer for you, and then you can just specify your container image, and it makes it very easy to launch containerized services, like single container services. Azure doesn't do this. AWS doesn't do this. Only GCP does this in this kind of convenient way. So I really, really like that. Not to say you can't do it on AWS. You'd have to go to the marketplace, but that is like a super bonus for me for GCP. Notice there's some advanced options here. So like the command arguments, you'd probably specify environment variables, maybe the entry point. Yeah, that's the entry point there, if you know anything about containers. If you don't worry. Then you have your boot disk. So this is the boot disk, right? And so we have some options here. It starts with 10 gigabytes. I wouldn't want something larger than 10 GB, but we'll take a look around here. So here we could choose Debian or Debian 9. We can change our operating system. I'm pretty comfortable with Debian. I like Debian. Oh, Fedora Core OS, that's pretty cool. I really like Fedora Core OS. I just learned all about that recently. You can provide your own custom images. You can set the size of snapshot. You can attach existing disks. But we'll stick with Debian because that's a pretty safe one there. Another one is pretty safe is CentOS. That's what a lot of the cloud service providers base their managed instances on. But what we'll do is scroll on down. You can see we can apply firewall stuff. Yeah, that's all fine. We don't need to do any more with that. We don't need a firewall. So we'll scroll up, make sure our price is okay, $7.83. You know what I'm looking for is a lot of times cloud service providers will have a startup script. Here it is. And this would be cloud init. Okay. So Cloud Init is a pretty standardized, or CFN Init, Cloud Init, can't remember what it's called, but it's a standardized way of providing your virtual machines with a script to start. Like it's the first thing it runs. So if we wanted to install Apache, we could do that. I'm just trying to see if there's like an example here. Like it's just a bash script, right? So I'm just thinking, yeah, see it here? Yeah, this is actually exactly what I want too. So this is perfect. I didn't know they had this. And so here, the idea is that we'll just take this. If you specify the first line in a Cloud Init file as this with a shebang, it's going to know it's a bash script, but it can also take a YAML file, I believe. But anyway, what this will do is it will do an update, and then it will install Apache 2. And I believe this is actually for Debian, because if we were using CentOS, it'd be like yum, but apt is for that. I don't know if it needs a sudo in front of here. It doesn't seem to need it. But what we'll do is we'll put that in there. Save me a lot of time. I didn't have to try to remember what to write. You can set custom metadata. We don't need to set any custom metadata today. And just looking at some other stuff, availability policy, on host maintenance. Nope, everything is fine. So we'll go ahead and hit create, and fingers crossed that just works. I didn't set up any SSH though. Huh. Well, if there's options, what we'll do is we'll just launch another one, but we'll see how this one goes. So what we'll have to do is wait a little while. So I just hit refresh up here. So there's a connect option for SSH, but we're just waiting for it to start. It's just going to spin. So let's give it 5-10 minutes and I'll see you back here in a moment, okay? Okay, so after waiting a little bit of time there, I did have to hit the refresh button in order to see that green status, but let's see if our website works. So what we can do is go over to this external IP, that is our public-facing IP address, hit that button to copy it, and we'll go ahead and paste that on in there. And so notice that it's not resolving. If that's happening, it either means two things. Our Apache server is not running, or our firewall rules is not allowing us to access on port 80. So that is something we're going to need to figure out. So we need to SSH in. I'm so used to providing an SSH key or generating during the creation process. I forgot the GCP doesn't make you set one in the creation process. You can just click here and it'll let you in. So we can open browser in window on a custom port, view gcloud command. I kind of would prefer to do it in the Google shell. So let's just try the browser first, okay? And what it will do is it will transfer the SSH keys to the VM, so you don't have to do anything. It's really easy to get in, okay? And we'll just give it a moment. Not fast, but easy, all right? And we're in, okay? So you can type in ls pwd just to see where we are. Let's go see the gcloud command. If that doesn't work, we'll just make our way back here. But I would like to try to use the Cloud Shell, because I think that's really nice. So we'll go view gcloud command, and there it is. So what we'll do, I'm not sure if this is going to work, but what we'll do is copy this. The following gcloud can be used in the SSH into the instance. Okay, so, running Cloud Shell, perfect. So if we didn't click there, we could go up here and click Activate Cloud Shell. Cloud Shell is like a terminal. I think GCP was the first to have this. Azure has one, AWS now has one, but GCP has the best experience for this. But what we'll do is we'll go down here and say View in gcloud and just hit Run in Cloud Shell. Okay, gcloud is the name of the CLI. Okay, and we'll give it a moment to start up an instance here. I assume it's containerized. It's probably containers. Is how it's able to launch so fast. Usually it's super fast, by the way. It's not super fast today. And then it'll run that gcloud command. It should get us into our instance. Also, another cool thing about gcloud is it has a editor built in, and it looks just like VS Code. I'm not going to switch over to it because I do not want to interrupt our terminal. But if you want to do coding, you can totally do it within the GCP platform. And again, that's a lot easier than the other ones make it out to be. So it's pre-filled it in here. It looks like this is a beta feature, but we'll go ahead and hit enter. It's requesting access. We'll say authorized. We will say yes. We'll say enter. Enter. So what it did is it generated out an SSH key for the Cloud Shell, and then I imagine what it's going to do is then take that SSH key, move it onto the server, and then allow us to then authenticate that way, okay? And so I believe Yes, we are in the instance because it says my website down below. So I'll type in clear. Okay. And so one way we could tell if it's working is we could do like a curl. So if we did curl localhost and it returns HTML, and it does, that shows us that the Apache server is running. Probably could also type in sudo Apache or maybe sudo service Apache to status. Yeah, and it's running. So it's running, and we did a query. So probably the issue has to do with the fact that our firewall's not open. So let's go take a look there and see what we can do, okay? So we need to go create ourselves a firewall rule, but I just remembered that we're going to need the IP address. So I'm just clicking back to the instance here whenever this page loads. I'm going to grab that external IP address and click back forward here. We'll go ahead and create ourselves a new rule. I'm just going to scroll on down and change this over to specified all instances in the network, and then specify the range and put /32 on the end there, okay? So the top here, we're going to type in port 80, and we'll maybe say website, and we'll say let our website be accessible on port 80. Probably would help to type correctly. It's not going to hurt anything, but you know, if someone else reads your stuff, they want to make sure that it reads okay. Logs, will leave that off. Default network is fine. Priority is fine. Ingress means inbound. Egress means outbound. So we want to get in, like to get something back, right? We can allow or deny, so we are allowing. If we scroll on down below, we can specify the ports. This is TCP. We're going to put port 80. And then we'll go down below and go ahead and hit create. Does not like the name, must be lowercase. It's hard to remember all these rules. We'll go ahead and hit create. We'll give it a moment. And what we'll do is go back to the internet, hit enter, and see if this is working. Doesn't seem to be working just yet. Let's give this a refresh, see if our rule appears here. So port 80, that is correct. Priority, so it has a high priority, so it should be applied. 32, 203, 103, /32. The 32 just means exactly that IP address. We'll go up here. It did not resolve. So just give me a moment. I'll take think about this, okay? So I think we might have an easier way to make firewall rules in the way we were doing it here. So what I'm going to do is go back to my instance here, because I could have swore that it was here, but I probably just forgot. If we go down to View Network Details, I think here we'll get, yeah, so there is, we don't have any network tags, so we don't have any way to specify tag. But here we have the external IP and the internal IP address. And what I wanted to see was what firewall rules were being applied. So here, if we go over here, we can see that we have port 80, so this should be applying. And down below, we could probably do a connectivity test here. And we'll see what we get back. Okay, we'll go ahead and create a connectivity test. We'll say port 80, port 80 test. TCP sounds good to me. And we want this to hit the 35.203.103.0. And that's the IP address. We could also just say the VM instance. That's a lot easier. I like that instead. Notice it's hitting the primary internal IP. So that's not going to be very useful because we have to go from the outside in, okay? So we'll do 35.203.103.0. Is this IP address used in GCP? This is an IP address used in GCP. Yes, it is. Okay. And that's correct. So we'll do port 80 and we'll say create. And we'll see if we get some connectivity. So it's just a way for us to effectively see if it's working. Last time test, last packet transmission result. So it's probably running it. I'll just go here and hit rerun. Yeah, that's fine. And do I have a refresh button here? No, I don't. And so it says it's reachable. Okay. Well, we could go ahead and view the results. So we have the VM instance, the egress firewall rules, the static route, NAT, VM instance. So everything seems to be working. So maybe I'm crazy. Maybe our thing is working. Let's go back and take a look again. Okay. But it's not working. Another thing we could do is we could open up our Cloud Shell. And so we were using Cloud Shell within the server. Let's just make sure we're not on the inside. We're not. That's good. And what we can do is just do a curl and paste in that IP address and see if we get anything returned back. If it times out, that means that it's not going to work. And notice it's timing out. So we still have a firewall rule issue here. So let me just try a bit more. But hey, we did learn about cognitivity tests. That's kind of nice. So we'll be back in a moment here, okay? Okay, so I think I know what the problem is. I haven't tried it yet, but I was just staring at this thinking, okay, I put the IP address in. Why is it not working? Well, the problem, I think, is the fact that I provided the IP address for the VM instance, but we're actually trying to say what is allowed in, right? So it really should be my IP address or a public-facing internet. So what I'll do is I'm just going to say, what's my IP? Okay. And we'll grab this here. Now, I bet that's the problem because we're not trying to allow the own IP address of the server into itself. That makes no sense. It would make more sense if it was ours. So what I'll do is go ahead and click this. We'll go ahead and edit this rule and we'll scroll on down and we'll switch this out for my IP address. Now you could do 0.0.0.0/0 and that's what you'd want to do if you're launching a real website here. We'll go ahead and save it. How embarrassing. But it just goes to show, it doesn't matter how many years you work with cloud, it's easy to get turned around, okay? So we'll go up here, hit enter, and now our website loads. So there you go. It's not that hard, as long as you know what you're doing. Okay, so what we'll do is we'll make our way back to our instance. So we'll say compute engine up here. Probably could pin it. I don't really like pinning things, but so that was our instance. Is there anything else of interest to show here? Not really. So let's go ahead and just delete this instance. Okay. And we'll hit refresh here. Okay. It's going to delete. I'm pretty confident about it. I'm not too concerned about this resource. And so what we'll do is go back and click on GCP or Google Cloud Platform, and we'll move on to the next follow along. Okay. All right, so we learned about compute engine. Let's go learn about, I don't know, let's say databases. So what we'll do on the left-hand side here is scroll on down and let's go take a look for SQL. So there's Spanner and there's SQL. So Spanner, it's a relational-like, it's its own variant of a relational database, but it's neither Postgres or MySQL. But if you were to be launching a web application, you'd probably want to just use the SQL service. So we'll go here and we'll launch ourselves our own SQL instance. I'll go ahead here and create an instance. And we have the option between MySQL, Postgres, and SQL Server. I am particular to Postgres, so I'll go ahead and click this. And we'll go up here, and so lowercase numbers, letters. So my relational database, or my Postgres. And we'll need a password, so we'll go ahead and generate one there. We'll show the password just so I don't have to figure that out later. And I need to dump that somewhere. So I'm just pasting it off screen. So just make sure you know where your password is. Postgres 13 seems fine to me. I like to launch things in Canada, so let's go look for Canada. There's Montreal. We have single zone and multi-zone. Now notice, does it show us the cost here? It's not, but I can tell you, if you have it in multiple zones, it should cost more because you're running redundant servers. So I'm gonna go single zone. Okay, I want it to be cost effective, all right? We could even specify the zones. I'm gonna say any, I don't care where it's gonna go. We can customize our configuration options. So let's open it up because we want, again, the lowest cost for our example here. So we got high memory, standard, shared core. Shared core sounds cheap. We have lightweight. I'm just checking the values here over on the left-hand side. So look at high memory, 26 26 gigabytes. That's insane. I don't even have a gaming computer that much. We go over here. Now we're down to 7 gigabytes. That's lightweight. Nothing. I don't see anything changing there, but I imagine it's cheaper. Then we have a shared core, 600 megabytes. This has to be cheap. All right. So this is the one we're going to choose. For storage, SSD is fine. We're not really doing anything real, so I'm going to choose HDD. That should be cheaper, right? I'm going to go 10 gigabytes because I'm not doing anything real. Enable automatic storage increase. That's something you'd want to have, but for our purposes, I'm turning that off. Do we want to have a public IP address? Well, I do because I want to connect to it, maybe do a query on it, so we'll leave that there. You might want to turn that off if you're running a secure workload. Generally, you would, and you just only allow access through, the firewalls and stuff like that. I do not need backups today. We don't care when the maintenance windows is. Flags are fine. We don't need insights. Insights are nice if you want to query and see information. I don't think this costs extra, but I'm going to leave it off anyway. We don't need it today. We can set labels as per usual. So I can say env. Dev. Should have been dev last time too. And so I'll go ahead and create this instance. Okay. Now I didn't specify a database name, so maybe it's just the identifier. All right. So I'll just wait for this to provision, and I'll see you back here in a moment, okay? All right, so after waiting a little while there, it looks like our instance is ready. It took about, 10 minutes for that to spin up. Not too bad. And so down below, we have the public IP address, the outgoing IP address, the connection name. But looks like there's an easy way to connect with the Cloud Shell. So let's click it and see if it auto-fills it in for us. That'd be really, really nice. I'm not sure if that's the case, but I guess we'll find out here in a moment, right? Looks like it is. So it says gcloud SQL connect my Postgres. Puts in the username, which is Postgres. So it looks good. Let's go ahead and hit enter. Might have entered that in twice there. Permission denied. Cloud SQL admin API has not been used in this project before or is disabled. Enable it by visiting this link. So I guess that's what we'll have to go ahead and do. So we'll go and click that link there. And we'll give it a moment. Say enable. Usually this doesn't take too long. Sometimes you can tell by going up to the top, so that's good. So what we'll do is go back and hit up. We'll hit enter and see if it connects now. Allowing your IP address for incoming connection for 5 minutes. Sounds cool. Can I do stuff? I'll say \D. Oh no, we're waiting. Okay. Well, not sure what's going on there. That's not too clear, but I mean, that's not usually how we connect to a Postgres instance. What I would do is collect the names and use something like Table Plus, and that's what I want to do here. So that's what we're going to do, okay? All right, so what I got here is Table Plus, and this is just a way of connecting to Postgres instances. So I'll go ahead and make a new connection to Postgres. This is free software, by the way. You can go and download it. Works on Windows, Mac, and etc. And so we got to fill in a bunch of these things. So we need the host. We need the username and the password. So the username is Postgres. Okay. The password I saved earlier, so I'm going to bring that on over here and paste that in. The database name would be what? It could be, this is connection name, but that's not very useful. I mean, my Postgres is probably, because this looks like this is probably the name of the database. That's probably the database name there is my Postgres. What would the host be? Usually, like if it's AWS, they have a connection URL. I suppose you could use an IP address. I'm just not used to having that. So we have a public IP address and an outgoing IP address. Let's try the public IP address here, 35.203.16.181. We'll say GCP my Postgres here. And so it looks like we have mostly everything. The default port is 5432, so we'll just do 5432. We'll hit test and see if that works. Fingers crossed. Okay, so what I'm waiting for is this to go green. It might not go green. Let's just try connect instead. On Mac, it goes green. It'll say, hey, you're connected. And it did not connect. Okay, so that's fine. So what we'll do is we'll give it a little bit of check here. So what else would we need to do? Give me back. I'll be back here in a moment, okay? You know, something I was just thinking is, you know, it looks like all our configuration settings are correct, but maybe our firewall is just not open. So what I'm going to do is make a new tab here, and we'll give it a go. It's all about trying things on the fly here. Nothing's too hard for the cloud. And we'll go firewall. I just want firewall rules. Well, that's App Engine, so we'll go here. Because I imagine this must be in a VPC, so what we'll do is go here and create ourselves a new rule. And we'll say my Postgres rule. And we'll go down, we'll let ingress, allow, specify targets. We're just going to do all instances in the networks with a particular IP range. So I'm just going to get my IP address like I did last time. So my IP address, right? Then we'll grab it there. We'll drop it in /32. We'll say TCP 5432. We'll go ahead and create that rule. So now that I have this rule on 5432, which is the port for Postgres, let's go ahead. Well, I guess we got to wait. We should probably be patient. There is the rule. I'm going to go ahead and hit test. See if it works now. Probably it's not going to work if I have that colon in the name in the database. We'll try again. Just connect here. That doesn't work. We'll just edit it again. Test connection. Is the server running? 5432. Still no good. Okay, well, I'll give it another try, okay? Give me a second. Okay, so another thought I had was I was just poking around, and we have users and databases here on the left-hand side. So here we have Postgres, and then here we have Postgres again. So there is no database called, I mean, again, I haven't tried it, but there is no database called my Postgres database. That's just what I wrote in because I assumed it's based on the instance name. That's just the name of the instance internally for GCP. So what would happen if I was to type in Postgres instead here and then test this connection? Would this work? Because to me, like, this would make a lot more sense, right? And if that doesn't work, I would say that we have the database right and the username's right, but maybe there's something wrong with the host or the IP address or the connection. So we go over to users. That looks fine. We go to the databases. This one's called Postgres, so that is fine. We go to connections. And it's public IP to authorize a network or use Cloud SQL. So we said public IP address is fine. You do not have an authorized any external networks to connect to your Cloud SQL. External applications can still connect through Cloud Proxy. So if we don't have a network, maybe that's our problem. So, whoops. What if I go and grab my IP address here? Maybe that's our problem. /32, my home address. We'll hit done. We'll hit save. Scroll on down below here. Here it says you can manage if you're encrypted, public IP address, only allow unsecure connections are allowed to connect. And that's fine. We just want to be able to use it. So what we'll do is go back here, try this again. We'll hit test. And this thing is super buggy, but notice that it's editing our Postgres. So I'll see you back here in a moment, okay? Okay, so we waited a short amount of time, and what I'm going to do is go edit, and notice my connection's Postgres, the database password I put in, the host name, and if I go ahead and hit connect, it now connects. So I don't think that firewall rule mattered at all. That's for VM instances. So I probably can go back and just delete it out just to make sure, you know, that is the case. So we'll just type in firewall here. Okay. And I'm going to go ahead and delete this rule. All right. And now just to do a sanity check. It's not uncommon for cloud service providers to have, you know, that stuff messaged separately. Like in AWS, you have security groups that are like DB security groups that are specialized. So to me, that's not a surprise that was like that. We'll go ahead and hit edit, hit connect. Can we still connect? Yes. Okay, so that's how we had to grant us access. Now this is Postgres. This is the default table. You really wouldn't be making, or database, you wouldn't be making stuff inside of that. What you'd probably want to do is go ahead and create a new database. So what we can do, go back to our instance here, close some tabs out so we don't get confused. And probably what we'd have to do is create a new database in here. So we go here and I'd say, you know, my database. Okay, we'll hit create. And we'll give that a moment to create. Probably the Postgres user is a super user, so we can do whatever we want there. But if we go and enter a connection, we're going to leave out the database. It should allow us to connect to all of the databases here. So it should show us Postgres and the other one. We might have to select our database, so Control K or, oops, that's not it. Control K. Okay, so there we go. So we can see we have Cloud SQL Admin, my database, and Postgres. So I'll go ahead and click into Postgres here. All right. And there are no tables, but I can go and maybe I can make a new table here. Yep. So there we go. So we say ID, and I will add a new column. It will say name. We'll make that a varchar. Let me just drop down, change it to varchar, or text. I just prefer text. Okay. And we'll go ahead and save that, create untitled table. Oh, we got to name the table, so it'd say users here. And now what does it not like here? Zero length identifier, create table, undefined table. Well, I just named it up here. The primary ID would be ID up here. Can I save it now? Maybe it doesn't like this one. Hold on here. I'm doing Control S, by the way, to save it. I never create tables this way. I always go through and make a manual connection, but I'm giving it a go here today for the first time. So zero length delimited identified at or near, double quotations. Just want to be named over here, maybe? I mean, it's named right. I don't know. It doesn't want it. You know, if that doesn't work, that's totally fine. The other way we could do this is, I'm just thinking here, because if we, like, I don't have Postgres client installed on my local machine. I don't think I do. So I don't think I can use that. I can try. Let's see here. No, I don't think I do. So the only way I'd have to do that is probably through Cloud Shell. And through Cloud Shell, we would have to allow the IP address. I don't know how much of a pain that is. But my point is that, you know, like, it's not necessary for the exam to know how to set up a table, but the idea is to establish a connection. I just wanted to show you how to do that. And so I kind of feel like we've kind of satisfied it there and solved all the stuff that we wanted to do. But what we'll do is we'll just go ahead and destroy this, and we're all good to go, okay? And what we'll do is just checkbox that off or click into there. We'll go ahead and hit delete. And we will put in the instance name. There we go. And it's deleting. I'm pretty confident that will delete. And that's it there. So we're done with that. We'll move on to the next. Hey, it's Andrew Brown from ExamPro. And in this follow along, I want to show you Google's App Engine, which allows you to easily deploy web applications. So in the top left corner, we'll go all the way up here to the navigation menu, and we'll scroll on down looking for App Engine, which appears under serverless. So we'll go there. We'll go ahead and create ourselves a new application. And the first thing we're going to see is a bunch of regions we can choose from. I like to always choose from Canada. So what I'll do is try to find my region if it is available. It might not be, which is totally fine. And I don't think I'm going to get Canada today. So I'll just go with US East 1. So let's zoom in on this map here. Oh no, there's Canada. There we go. North America Northeast 1. Great. So we'll go next. And we'll give it a moment to load. It's just thinking really hard there. Thinking really hard. And I cannot tell if it's frozen. So what I'm going to do is just give it a hard refresh here, see if that helps at all. All right, so I just had to give it a hard refresh there in order for this to actually show up. But what I want you to do is go down and we'll choose our runtime to be a Ruby because that's what I know and love. And we have the option between standard and flexible. For the exam, you definitely want to know the difference. For this follow along, not a big deal. We're going to stick with standard here today. And the great thing is they do have some samples here on GitHub. So what I'm going to do is right click here and just take a look here at what they have. And they got a bunch of different stuff here. And so what I'm thinking is we can open up our Cloud Shell. So I'm going to open up Cloud Shell here at the top. And it actually has an editor mode. I haven't really given this a go, so let's try it out. I know what it looks like. It's like VS Code, but I'm just saying I haven't done a big workload in here yet, so I'm kind of curious. And we'll let that load up. And oh yeah, there's me doing some BigQuery stuff from earlier. But what I'm going to do, yeah, see, I was just doing a quick test there. But what I'm going to do here is bring in a new repo. So here, source control, I don't really use VS Code. But usually you can go here and press this button here. And that's not really helping. So that's fine. We'll open up the terminal. It's not a big deal. And I'm just going to do ls pwd to see where I am. So I'm in my home directory. And here it's going to ask me to do a git clone. So I should be able to clone this. And we'll hit enter. And so now we have all those samples. So the question is, and here down below it says app engine, / app engine, whatever. What I noticed is that there is no folder called app engine. So which one will be run? Well, intuitively, I would pick something like Rails or maybe Sinatra. So maybe they have a very simple example. They also have static files. So they have Sinatra and Rails. But they have an hello world example here, and if we click into it, it is Sinatra. So I feel that this will probably be the easiest way to deploy. And then we have our app YAML file. That's actually how we configure most, like whether it's App Engine, Elastic Beanstalk, or Azure App Services. They always have like this accompanying configuration file that you can use with it. I'm noticing that this is set to Flex. So maybe we might want to use flex mode. And to me, it doesn't really matter whether it's standard or flexible. So maybe we'll just switch it over to flexible here. And what I'll do, is, it says initialize deploy. So what I'll do is I'll just cd into that hello world directory here. Oh, we got to first cd into our Ruby docs and then into our hello world directory. Oh, look at that. Now there is there's an app engine right here. Maybe we're already in that folder. Oh, okay, that's why. So we'll do app engine and then we'll do hello world. Okay. And so we'll probably have to do a bundle install. So we'll just do a bundle install. Gem file cannot be required. You have etc. It could be just because this machine doesn't have Ruby installed. So maybe we'll do gem install bundler. Actually, I didn't even check if this has Ruby. Does this have Ruby installed? Yeah, it does. Okay. And actually, it's a very recent version. So we'll do gem install bundler. It's really not even necessary to do this, but it's just out of habit. I like to make sure that it bundles before deploying. Bundler is just like requirements.txt or npm. It's just Ruby's package manager, or Composer if you're used to using PHP. And so then I can just do a bundle install after install the packages. Did I not just install bundler? Gem install bundler. Yep, it's installed. Bundle install. I'm not really that worried about getting it running locally. I just want to deploy it. And so in order to deploy it, we will have to run the gcloud app deploy command. We'll just double check and make sure that's the case here. I'm pretty sure that's what it says down below. Yeah, it's just as simple as this. So hopefully this works no problem. And we'll authorize it with gcloud. If you're installing this locally, you probably use gcloud init to authenticate. It's giving us some details here. It's really hard to read this on white on black, or black on white there, but let's see what it's doing. So we have a description. It's going to tell us the source. It's going to show us the target URL where it's going to deploy. App Engine default service account sounds good to me. So we'll hit Y for yes. And we'll let it go ahead and provision. Probably the most simple out of all the providers in terms of like a platform as a service. I would say GCP is out of all the three. Great, and so if you just take a look there, you can tell it's actually building out a containerized image, so it gives you the idea that this is running off of containers. Also noticing that it's setting up Cloud SQL and Cloud SQL proxy, so I would suppose if it needed to be backed by a database, this shouldn't require a database. We'll just take a look here. Maybe the configuration it has that in there. Nope, it just says environments, flex, runtime, Ruby, resources, memory, disk size, etc. So I'm not sure why it's spinning up a relational database there, but and this doesn't even have one, but maybe that's just part of what it does. Okay. So we'll just have to wait here a little bit of while, and I'll see you back here in a moment. Okay. All right, and so after a little while there, we can see there's a cloud build fail. It doesn't say as to why. Hold on here. You have added gem, etc. I know Ruby pretty well, so for me, it's not hard to figure out as to why. But looks like we're going to have to go check the logs. So I'm not sure where the logs are, so just give me a moment, and I'll go figure that out, okay? All right, so what I did here is I went down below and I opened up this link, which brings us to our build details. And if we scroll all the way down to the bottom, notice how many steps it's out of, 11 out of 14. So this is actually building the container image. And when it went and did a bundle install, it ran into some trouble here. So you are trying to install in deployment mode after changing your gem file. Run bundle install elsewhere and add the updated gem file.lock to the version control. So I think maybe we just have to get that bundle installed to work. So what I'll do is go back here to my editor. I really wish I could figure out how to change the theme here. Is there a way we can change the theme so I can see what I'm looking at? I'm not sure. Maybe settings, color theme, and we will go Abyss. Oh, there we go. That's a little bit better, so we'll work with that, I suppose. So maybe we just need to make sure that the bundle install works, which is something I try to just get around, but if there's no gemlock file, that's what it's probably going to be complaining about. So if I just expand this here, yeah, notice there's no gemfile.lock or gemlock file. So we'll do bundle install, and this time we'll just be a bit more thorough about its read. So could not find bundler required by your home directory to update the latest version installed in your system. Do bundle update bundler. So we'll do bundle update bundler. Let's see if that works. I would have thought that we were up to the latest version because we ran it. The lock file is being updated to bundler 2, after which you will be unable to return to bundler 1. Totally fine with that. Nobody uses bundler 1 anymore. But if we take a look here on the left-hand side, I don't see bundler gemlock file there, so I'll do bundle install. And so now I should have one. Maybe I have to hit refresh here. Still don't see one here. Let's do a clear, and I'll do a ls-la. Yeah, it's right there. So, oh, you know why? It's because I'm not looking in the subfolder here. So we're supposed to go App Engine, Hello World. And so there's that gemlock file. So now let's go ahead and try that deploy again. I don't know what happens when you have a failed deploy like that. So we'll just hit enter. And I wonder if anything has changed here with App Engine. Probably not. Probably have to do a successful deploy. While that's going, let's go take a look here what was going on through our build history. So nothing exciting here. But I wanted to see what the services was. So it was doing it through Cloud Build. So Cloud Build, I imagine it's just like AWS Code Build, which is just a build server. So it's a server that is designed to build things, and so that could be preparing artifacts for code, or in this case, it could be building out a image, which I think that's what it was doing. It was building out an image. So that's interesting how they link that up. So we'll go ahead and hit capital Y here, and we'll let it go and deploy again. And I will see you here at the end of it, and hopefully it works, or we'll encounter a new error. Okay. All right. So after waiting several minutes here, it looks like it is done. And it has this nice command here called gcloud app browse. I don't know if it's going to work within the Google Cloud Shell here, but let's give it a go and see what happens. Okay, so it didn't detect a browser because we're not running it on our local machine. We're running it within the Google shell, but that's fine. We can just copy that link and paste it up on here. And so we can see the application is working. So let's go give it a peek in the actual service and see what we can see, okay? Because usually we will see some additional stuff here. So I'll go give this a hard refresh here. It's still showing us that. We'll go ahead and click the dashboard here. And so our app should be here. Looks like it must be running here. I'm just trying to distinguish. Okay, up in the top right corner, that's where we can see it. We can see our versioning here. We've got services. Okay, that makes sense. If we wanted to upload different versions or we deploy new versions, I guess it would be version management. So yeah, pretty straightforward. So I'd say we're all done here. And now we just need to go ahead and tear this down. Good question. So I mean, I see this running here, so I imagine we can just go ahead and delete it. Oops. I have no idea how we should delete this, so just give me a second and I'll figure this out, okay? All right, so it looks like we don't delete app engines, we just disable them. So let's go ahead here and click on disable, and we will enter this key in here, okay? And so that should disable it. So why they don't let you delete them, I do not know why. But I mean, that's totally fine as long as we're not getting billed. So here it says your app has been currently disabled, okay? So yeah, there we go. So we'll just make our way back here and move on to the next service. Hey, this is Andrew Brown from ExamPro, and let's go take a look at some storage options for GCP, in specific cloud storage. So what we'll do is scroll on down here. So we got our compute, and we have our storage, and here is cloud storage. Okay. And you will notice, oh, our screen's a bit messed up here. Just give it a hard refresh here to get that weird navigation out of the way. But you can see that because we set up our app engine, we already have some storage here. But let's go ahead and create ourselves a new bucket. And we'll just say my new bucket. Okay, these are globally unique names, so it's just like domain names, so you might have to put in some random numbers there. Click continue. Now we have an option of multi-region, dual region, or just region with the lowest latency with a single region. I'm just going to stick with multi-region for this. I'm going to see if I can choose Canada. Actually, I only have 3 options: US, European Union, or Asia. If I choose different ones, what are my options? Do I get North America? There we go. So actually, I want Toronto because that's the closest place that I am here. Clearly, multi-region would give you the highest availability, but if you want the lowest latency and you just want a single region, more options, you probably might just want to choose region there, okay? We'll go ahead and hit continue. I like on the right-hand side, it's estimating our cost here. Now we have our different storage options. This will absolutely show up on the exam, so you need to know the difference. So standard, best for short-term storage and frequently accessed data. Near line, best for backup and data access less than a month. Cold line, best for disaster recovery and data access less than once a quarter. Archive, best for long-term digital preservation of data access less than once a year. So we're going to stick with standard. And then here it says prevent public access. One of the most common vulnerabilities for cloud service providers is through cloud storage when they're made public, especially on AWS. I'm sure it's no different for GCP. So it's probably good to have public access prevention turned on the bucket. And then you have access controls under it. We have uniform and fine grade. We're not sharing this with anybody else, so we don't have to worry about that. We'll go ahead and hit continue. You'll notice that we can set encryption to be the Google managed encryption key or a customer managed encryption key. We'll just stick with Google's managed key there because that's very easy. You can set up a retention policy. If we check boxes, we get more information. So we could say how long we want to retain stuff for. I'm going to leave that off for now. Apply labels as per usual. We'll go ahead and create our bucket. And so now that we have our bucket, let's go ahead and I'm going to create a new folder. I'm going to call it Star Trek. Okay. And what I'll do is I'll just go grab some images to upload, just a couple images. And I'll be back here in a second, okay? All right, so let's go ahead and upload some files. So I'm going to click into the Star Trek folder. We're going to hit Upload Files. I'm going to go into my Star Trek folder, and I have a couple of graphics from my one of my previous courses here. We'll hit upload and you'll see the files upload, and there they are. If you want to go ahead and download them, there's a download button on the right hand side. We have some other options here. Nothing super important. I'm going to go ahead and delete these files. Okay. And give that a moment. Not that this would cost us anything to keep these two teeny tiny files around, but it's probably a good habit to learn how to delete stuff at this level here. And I'll go ahead and delete my new bucket. And we will type in delete to permanently delete it. Okay, and there you go. That is Google Cloud Storage. Hey, this is Andrew Brown from ExamPro, and we are taking a look here at BigQuery. So what I want you to do is go to the top and type in BigQuery. And this is one of Google's flagship products because it does something that other cloud service providers does not do, and it's the fact that it's a serverless data warehouse. So other providers like Redshift or I'm kind of forgetting the one, Azure Synapse, things like that, they are not serverless. That means that they have an idle cost that you pay for, and they're generally really expensive. But BigQuery is very cost effective because it can scale to 0 and you're paying for consumption, okay? So for me, it's actually a service I definitely use on a regular basis, and I really, really like it. So just to kind of give you an idea of how this works. Now, if you have not attached your credit card yet and you're using the sandbox, it is totally safe to do this. But if you do have your credit card attached, I'd probably suggest not querying if you're trying to be cost effective here. But they have a bunch of data sets here. And so here is one for COVID. And a lot of these are public data sets, or I mean, this one is at least. And that means that Google has made it available to you. And for this one in particular, for new users, you can store up to 10 gigabytes of data up to and query up to 1 terabyte each month for free. So you can really play around with BigQuery in that sense. Once you attach a credit card, it's no longer free. Actually, I'm not really sure if it's still extended to be free outside of sandbox mode, but I can't be certain, okay? So if we go back here, we don't have to do anything. The data set's already there. We just have to reference it. So it was a bit hard to find any available queries, but I did find one on this blog post. So thank you, whoever did this. And let's go ahead and grab this here and see if we can run ourselves a successful query. Notice it's going to suggest how much data it's going to process. This is important because it's our consumption. And we'll go ahead and hit run. Okay. And we will see what we get back. And so there we go. We got some data back. You go ahead and export the data. So export in Data Studio or GeoViz. So if you have some other things there, you could see that data, create some live dashboards and things like that. But that's pretty much it. That's all I really wanted to show you. And that is BigQuery. Hey, this is Andrew Brown from ExamPro, and in this video, we're just going to take a peek into Vertex AI. I just like doing this because at some point, you know, maybe your company or you might be considering to do a little bit of ML, okay? And the thing is, a lot of people are scared of it, and they're really worried about it being extremely expensive. And so this is kind of my way of just kind of getting your toes into the pool, so you're not too afraid to do it. So we'll go ahead here and type in Vertex AI. That is GCP's offering, and we'll go ahead and just enable it. And I wonder if I can do it in Canada. I always like to pick Canada if I can. Montreal. It'd be nice if it was Toronto. They just don't have data. I mean, they have data centers there, but there's never data centers for the main providers there. And so we chose our region, okay? And I just want to do anything, like opening a notebook. That's usually what we would want to do. But what I really want to show you is about compute, because that is the hidden cost to any type, whether it's SageMaker, Azure ML Studio, or Data Studio, ML Studio, can't remember off the top of my head what's called, Vertex AI. It's just that you have to remember to turn off the servers. If you remember that, it's very not scary to use these services. So if we want to have a notebook, so migrate your notebook. I don't have any right now, but I just want to run anything. So we'll go ahead and create ourselves a new instance. And so here, just like all the other ones, you have to choose your environment. CUDA or GPUs you do not want to touch because those are super, super expensive. So we will just choose Python 3. Notice it comes with scikit-learn, pandas, and more. That's usually the safest one here. If you look here, it'll tell us what it's spinning up. So 4 vCPUs, 15 gigabytes of RAM, 100 gigabytes standard. So it's pretty darn large, but that's pretty standard for what you'd want to use. So what we'll do is go ahead and hit create. Actually, let's go take a look at advanced options. I've never clicked that before. Nope, nothing exciting there. So we'll go ahead and hit create. Notice it says $102 a month. So if you're afraid to run this, don't do it. But I mean, we're going to turn it on or turn it off. So it's like not going to cost us much, right? So I'll go ahead and spin that up there. Okay. And I'm not sure how fast this is going to start up. On AWS, they have like ones that will start up within 1 or 2 minutes. But I don't think that's something that is offered on GCP or Azure. So the green usually means it's running, setting up the proxy to Jupyter Lab. So this is what we really want to do, is we want to open up Jupyter Lab. So we'll just have to wait a little while until that's ready, okay? So I'll see you back here in a moment. All right, so after waiting a very short while there, now we can see we have this open Jupyter Lab. So we'll go ahead and click that. And that will give us our Jupyter Lab environment. This is just an IDE specialized for data scientists or people working in the data field. Notice that it comes preloaded with tutorials, which is pretty nice. So we have some BigQuery, Cloud ML Engine, Fairing, storage. If we go in here, this would show us how to work with BigQuery pragmatically. And the idea here is you go ahead and you just hit play on these, okay? And the idea is if you hit play, I'm not too afraid of doing this. If you want to just watch, that's totally fine as well. But here it says locations are required, et cetera, et cetera. So that ran. And so here, this would just query some public data set. So that's something we did when we did BigQuery. We just ran a query there. But if we hit run, it should output the results. Notice there's an asterisk. It just means that it's running. So we'll give it a bit of time. And so there is its data. So this is pretty, this is pretty, pretty straightforward. And very similar experience to the other providers there. So once you learn one, you kind of learn them all. But yeah, the real thing that you got to be a bit fearful of is the fact that, depending on the machine type you choose, they get really expensive. So what you can do, I'm just going to check if they have them on the left-hand side here. Sometimes the providers will have like a category just for compute. But when you're actually in Jupyter Labs, you can go over here. It shows the kernel session. If you're on AWS, they would actually show you the compute here that you can shut it down. But what we can do is, if we're really concerned about it, we just go here and stop the instance, okay? But the thing is that you could also be paying for storage, so that could be kind of expensive. So I'll actually just go ahead and delete it. But we have to stop, I think, the instance before we can go ahead and delete it. So we'll give this a refresh here, okay? And while that's going, I just want to show you something else. Actually, I really like this channel called ByCloud because they cover a lot of different kind of AI techniques. But the reason I'm bringing it here is not to promote this channel, but more so because they'd like to link in these Google Colab files. And so Google Colab is kind of a way of utilizing, it's like a notebook. It's like a Jupyter notebook. Or it may be a Jupyter notebook. It just doesn't look one-to-one with the Jupyter Labs notebook. But it allows you to run ML models, but also to utilize GPUs. And GPUs, like your graphics cards, are really, really expensive in the cloud. And so this is an opportunity where you can use it for free and you're just sharing it with other people. And it's one of Google's initiatives to allow you to learn in a cost-free way with Google. And I think it's really cool. But you could just click through this stuff and kind of get a result. So I can go here and hit run. And I'll just say run anyway. That's totally fine with that. Okay. And I could just say run all, like that. And this is not going to cost me anything. Like I do not have to worry about it. So that's something that's really nice that Google lets you do. I assume it's using underutilized machines or machines that aren't being in use. So if you're learning, you could just use Google Colab. But if you need to use, or you need to build a real model to deploy, then you're going to be doing that with Jupyter Labs and Vertex AI. Okay. So I'm going to see if that is finished shutting down yet. Is it done? No. It's pending. I'm going to shut that down. Maybe that was causing the issue there. Okay, so I'll wait till it gets out of the pending state here. And this is just running. I don't know what this is even going to do. Execute a 3D photo in painting. It's going to do something cool, something relating to something to change poses for people. Okay. But anyway, I'll see you back here in a moment when this is out of pending, okay? All right, so just as I stopped the video, it also stopped the instance. So now I can go ahead and delete it. We'll just say delete. Okay, and that should take care of any lingering costs, just in case you're following along and you do not want to get billed $100 by the end of the month. There probably was instances that were a bit cheaper that we could have chose. Like, you don't have to do this. I'm just kind of taking a look here. So there probably was, yeah. So we could have chose something like this. Notice that was $29. That would have been a lot safer to do. Because when I think of like SageMaker and Azure's ML Studio or Studio, this is usually the cost that I run my notebooks at. So probably it just had a very expensive default, and we just had to change it down below to this, okay? I figured that was probably the case, but I should have showed you that as we're doing it, so you're not super scared. So really the real cost would be $30, and you can do a lot with that, but again, you can use Google Cloud for free. But there you go, that's it.